let's see if everything's the same, understandable. It's just the other side, but this will be our headphones. See if it's connected. Yeah, looks good. This is on. And here the catch, I guess it's this. Okay. So for changing the battery. Everything else is the same, right? So any questions?
Batteries are where?
Here.
Ah,
Well, it's already set up. It's ready to go. And in the brake, no longer. Here you actually see.
yeah, the
See the-
status of the
Yeah.
battery.
So one, if they're full, but if they're half full, I don't know how long they're gonna
Mm-hmm.
still go. So once they're on half, I would just go ahead and change it.
Mm-hmm.
I'll be sure. In the next break. When
Just one more question. The Pixum is the rotating head itself, right? Or what exactly is the Pixum?
yeah, that's the. That was programmed as a main.
Mm-hmm.
The green
Okay.
blinking
Yeah.
head there is a.
But that also runs on batteries.
No, that's plugged in.
Okay, check.
So that.
Yeah, just because it says
Yeah.
okay. Got it. Yeah.
Okay. So.
So and the muting of the catch is also actually the sound guy does it, right? You don't have to take care of that.
Yeah.
It's only to check if it works.
Yeah.
Right? Yeah.
Alright. Should I still come with you or?
Yeah, we meet all together. You can leave your things here if
Yeah.
you want. But we're gonna.
That's a problem.
Sound good?
So, are you the
Organizer, yes.
organizer? Okay. You need to get the presentations uploaded.
Yes, that's what I was trying to do.
Okay. Can
I
I
am there as, that's me.
right there?
Yeah, that's
Okay,
me.
let me give you presenter.
Okay.
Do you have, let's see. Wait, how do I think it's over here?
There's a button, take presenter. Should I click that maybe?
Well, that would work, but I just gave you presenter.
Thank you. So yeah,
Okay.
I'll upload everything now.
Yep, okay.
Thank you very much.
Good. Let me move this back to. Yeah, that's good, okay.
Then should I give presenter back the laptop?
Give it back to this one that's not the webcam.
Okay,
This is this laptop,
Okay.
and the webcam is the one back there.
excellent.
So then this speaker will have control of the slides.
Excellent, thank you very much. This works. Come on. Then what I can do is link thing in the chat, so you can just click on the thing there. Is it just a kernel this page here? Okay. So is that there already? Okay. So. Interesting. Excellent. Good job. Got this, got an actual template. One morning. Okay, so it's there. Let's see. So, how does this work? Yes, I need to take back presenter. Okay. Excellent. It already works. Okay. And then switch to this. Perfect. Okay. All right. the box. Should I take it over the front?
Sure. It's not too far to the front.
Okay. Here, you're the custodian of the green box now. Make sure nobody sees them. So I start with intro, and then
I do this speech about that. These things goes for celebration. We have been removed from our systems. Much for everything.
Oh, really? I'm still the person who's now the person trustee.
These are the facts that you hear.
Yeah, absolutely.
want the warning or leave 15 and leave 10 questions on the wall?
I don't know. I think we should do like more visualization all the way, but just do it at 5. I think we should do it with everybody. Like, tell us.
Yes, we're ready. All right, good morning, 10 o'clock, let's get started. Welcome to the kernel user space init system management boundaries and APIs microconference. Pretty sure this is the record for the longest microconference name in the history of Plumbers. So we are going to have a lot of great talks today, starting with Leonard in a minute. But first, a few admin items. Let me start by thanking our sponsors. This conference would not be possible without them, so thank you all. Secondly, as a reminder, there is an anti-harassment policy and a code of conduct, so we are here to have discussions, lively discussions, technical discussions, but let's keep it civil, please. The final thing, as usual for every conference, we are live streaming, we are recording. If you have questions, please raise your hand and we'll throw you a green box and speak into the microphone. Don't just shout, because we want people that are connected online or watching the video to also hear your question. And for the speakers, if that happens, please repeat the question in the microphone. We'll have 5 minutes break between every talk, and that's pretty much it. So let's welcome Leonard. You know how to do this?
Yeah, from yesterday, yeah. Okay. How do I get my slides?
Like this. And like this.
Right. So this is supposed to be less of a talk and more of, like, I don't know, my slides are supposed to start a discussion, because I'm not presenting answers so much, I'm more presenting questions. Yeah, I'd like to talk about whether we can revisit how kernels do initrds, because I see various places where we could optimize things. When I say initRD, by the way, I mean the way how we currently boot, even if it's technically called initramfs. And even if that's a lie, given that it's not a ramfs anymore, but a tempfs, I would just, like, from our system perspective, we always use the term initrd regardless of the actual technology used. So yeah, in the following discussion, that's what I'm going to say, even if I don't actually mean a RAM disk. I mean the tempfs backed thing that we do these days. So to start the discussion, let's look at the status quo, how initrds is actually done these days. Initrds are a series of typically compressed, like some of them are compressed, others cannot be compressed, CPIO archive. CPIO is a very, very simple archival format, like tar, but in text. They are loaded into memory before the kernel initializes, so that's usually the job of the bootloader, or in UFI, like in the UKI world, it's SDStub. It's a firmware that loads the PE binary, and then it's already in memory, and then it's a stub that makes sure that this gets passed to the kernel. Once the kernel did its basic initialization, it starts to unpack these CPIOs into a tempfs. This tempfs is already accessed before user space starts for a couple of things like firmware stuff, microcode, and a couple of other things. And then eventually /init is invoked in it. All right? So this is relatively flexible, because in most systems these days you have a couple of these CPIOs, right? Like CPU microcode is glued in front of the actual one that the OS provides. So even though we mostly think about the latter one, we should not forget that it's a series of things usually. The initrd, like the code that's in there, then does its thing. Eventually, the root, like the hash, is overmounted by the final root file system. This is actually relevant because it's overmounted. It's not replaced, it's overmounted. Then the final process, like the process of the actual system, is invoked. In the background, we then empty the tempfs of the initrd, right? Like there's basically RMRF running. For the rest of the time, the super block of the tempfs stays pinned, right? Like it stays around. It's hopefully empty, but just hopefully. Nobody knows if. And in some cases, like if you use Plumbers or something like this, there will resources stay pinned. It's kind of weird. However, it's not really visible, right? Like because it's overmounted, it's kind of there, but also you don't see it. So much about the status quo. I see a couple of problems with this. Like, I kind of get the impression that most of generic and not so generic distributions are probably going to move to the UKI world right now, meaning that you have vendor-built initrds, right? Like so. It's the Fedoras and Ubuntus of these worlds and the RHELs and so on who will build the initrds on build servers and then glue them together with the kernel to make an UKI and sign that as a whole. But that basically means initrds cannot be adjusted to the individual system how we traditionally did this, right? And that implies that they get larger because then they need to carry a larger amount of drivers. And these initrds can get very large, really, because we have some firmware, some drivers, which are just terribly huge, GPU drivers usually. So we can, of course, add a certain level of modularity, but everything has bounds, right? Like they're never going to be as small as they used to be. So this is less than ideal, right? Like because, as I mentioned, like we unpack the CPIO archives, which are compressed. And we have to basically touch every single byte of them. And that is not the greatest thing in the world because, as mentioned, they can be quite huge. I mean, we're doing a lot of things with these initrds anyway, right? Like because they first get loaded off disk in UFI mode, which is already slow enough because UFI disk drivers are not the best. Then we hash them for measurement, and we hash them again for measurement. Then we pass them to the kernel. That's hopefully zero copy. Then we decompress and CPIO, de-archives them into tempfs, and then eventually we delete them. So we're doing a shitload of stuff, and I'd would prefer if we don't do that where we can avoid it. We probably can't avoid it so easily to read them off disk and to measuring them. But what I think we could do is like that we don't start decompressing and touching every byte, even like for firmwares and drivers we're not actually going to need, because the local system doesn't have that hardware. The emptying of the initrd is slow again. I mean, it's not that slow, but it's still like, if your initrd is large, in systemd we nowadays fork off a little background process when we do the initrd to host transition, which just goes through every inode in the initrd and just doesn't unlink. And that's it's not terrible because we do it asynchronously, right? Like we already transitioned otherwise to the real file system. But there's also a lot of busy work that we'd rather not do. It also means that pivot root is not possible, you know, because on Linux, like you have a tree of mounts, and because this initrd tempfs thingy is the first mount that is established, it's the root of everything, and that makes it impossible to unmount. Because it's impossible to mount, you can't actually use pivot root to get rid of it. You know, pivot root is supposed to change the root thing from the current view, but that doesn't work for the original one. That's why we actually have to empty it, right? Like because if we could pivot root it, then we wouldn't have to empty it because it would just be a tempfs, and if it would go away, nobody cares, right? What I also don't like about it is it's mutable, right? Like we try, at least within our system worldview, to get everybody to use more immutable OSs, but for the initrd we can't, right? Like because it's a tempfs and the kernel mounts it writable, I mean in recent systemd we nowadays broke everybody's initrds like half a year ago because we decided that let's try to lock it down a little bit at least and make /user really early on and user space read only when we are running an initrd. That did break a couple of things, but I'd like to be tougher, right? Like that user space doesn't have to do this, and the kernel just gives us, like, it unpacks it into the tempfs and makes the tempfs immutable, and makes it immutable in a way that user space cannot make it mutable again. Because I think boot time integrity and these kind of things matter, and if you can modify your initrd, because initrd's nowadays are network facing and whatnot, I think we should try to make them immutable. So much about the status quo and the problems with this. Anyone has? I kind of wanted to make this a discussion, so please, you raised first. Let's start.
Yeah, I don't know if this will work for systemd, but there is a trick you can do to make pivot root work. There is bubble wrap has a trick that we were going to do the same thing in run C as well, because
No, that doesn't work.
That doesn't work.
That doesn't work.
That trick doesn't work. Okay.
Because you can never unmount the root, like the initial tempfs.
Yeah. So
it's off limit. Yeah, that's why we have to add.
Right.
So pivot root does work for like if you're in a file system namespace, and that one you can pivot, right? But it's the actual tree root of the entire tree you cannot.
Right, but I'm talking about so that there is. People complain about not being able to run C inside of like a VM where you already in RAMFS, and there is a trick that allegedly works, which is you create a new mount namespace and then you bind mount to a different directory and then you move the mount and then you chroot into the mount and then pivot root allegedly works. We can talk about this later because I'm not sure if this will work for system.
Christian, like who's one of the file system attendants, no.
Okay.
He says.
Sure.
He should be around here, but yeah.
He's hiding.
All right, so maybe I can provide some background on why some of these things are done. The reason rootfs can't be unmounted is because it solved a huge problem that we had, which was what to do with the root of kernel threads. We don't want the root of kernel threads to move around. And so what we never really anticipated was that the init-tempfs which was originally init-ramfs, tempfs didn't exist yet. That it would be used quite so large. It was meant to be a small user space that would just replace a bunch of the in-kernel code, and that never got merged. But it wouldn't be very hard to add to the kernel to overmount rootfs with a non-magic tempfs.
So, one of the ideas that I had was actually, but it's not in this.
No. We had so many problems back in the day when we mounted the file system image. We really don't want to go back there.
Wait a moment. So one of these things that one of the ideas we discussed was actually introducing something like that is actually rootfs, which is would be basically a special file system that has exactly one inode and
that's basically what I just said. That would be easy to do.
Yeah, but exactly. That would be the real root, and then the tempfs would just be something that is overmounted to that, and that would allow us to do everything.
That certainly can be done, and then you can get it would be very easy to do your to tell the kernel that tempfs should be should be immutable or whatever. But the other thing that I wanted to say was the RM-RF is perhaps not as big of a deal as you think it might be, because the kernel does exactly the same thing when you mount a tempfs.
Well,
it has to.
But it doesn't have at least that doesn't have the syscall overhead of like 1 million files.
But the system call overhead is relatively small in comparison.
Not really. I don't know, it's measurable.
It is, but this is something that gets done and as you said, it's asynchronous. In fact, I think that you might be actually worse off because the umount is synchronous.
So
the work has to be done one way or the other.
I remember, but anyway, for us, already from a security perspective, it's really ugly if there's a process hanging around from the init that usually comes with a completely different security policy because SLinux and things like that are initialized during the transition, right? So it is this weird process that comes out of of a prehistoric world where it's a lot more privileged, has capabilities that the rest of the thing doesn't have, and just sits around there and does its thing while the lockdown world is already up there, right?
Okay,
Like we'd
so
rather have this not.
Yeah.
So I think it's a performance issue, but yeah, sure, I already said that it's not the biggest performance issue, but also it's a
Now
ugliness security thing.
that's a very different. That's a very, you know, and obviously, if you make it so that user space can't modify it at all, then you can't do that anyway. But yes, so I think that the idea of just layering a tempfs on top of the rootfs would be very simple to do. But I really don't think we want to go back to the world where we had a file system image, because there were so many problems with that.
Yeah, I mean, this was one of the other ideas that we were thinking about. Like, let's just make it so that erofs or squashfs is the root file system. This would have nice properties for us, right? Like, preboot would still put it into memory. And then only the files that are actually accessed need to be decompressed, and there's buffer cache for this, and everything's nice for us. But it does create problems. Like
and again, you are touching that memory so many times before.
But it's huge memory, right? Like it's 500 megabytes sometimes.
Yeah, but you are, you know, the typical boot, the typical firmware. A bootloader will probably copy that like 3 times already.
But you know, it's not just about touching around; it's also about decompressing.
Yeah,
right?
but the decompressing actually in a lot of cases improves performance, and you can, if you're using one of the less aggressive compression styles, you know, they can be faster than a non-compressed block copy.
I don't know, like we didn't do the detailed analysis what's fast and what's slow, but it's measurable like already for a human to see how long it takes for the iterity to actually show up. Anyway, so but let me just say the problems that I see with the approach is simply that I mentioned this earlier that CPIOs, we have a series of them, right? And we nowadays, in SD stub, for example, we generate more CPIOs on the fly to pass in the sidecar files that we pick up that allow to parameterize the iterity. And these are, so basically this means that we have to expect that the kernel gets in a series of, I don't know, 7 or something CPIOs passed in. Some of them are relatively static and predefined by the OS vendor, but some of them are entirely dynamic and generated on the fly during early boot. So somehow, if we would go for a block-based thing, we have to find a solution for how that's going to work, right? Like, in particularly, as many of the CPIOs, like the microcode one, are accessed really, really early on by the kernel when it initializes before user space is up there. Like, it has this weird thing where it directly goes to the CPIO before it even has unpacked it in a tempfs, and hence I figure whatever we do, this kind of behavior has to stay, and there needs to somehow be married with a block-based thing which doesn't decompress everything. So I don't know, like maybe something could work where we basically say for the once user space, like the actual mount that we set up for user space would be a block-based EROFS or squashfs, and then we would mount the CPIO stuff that we will always also get passed into some directory / iterity or whatever.
If you want to do that, you actually flip it around. Just put your image as an uncompressed item in a CPIO, shows up as a file in your init tempfs, and just mount it.
I mean, I guess we could do something like that. The EROFS provides /user, right? So that then we do the traditional thing for all the dynamic stuff. You get your root file system set up, and then we just say that the kernel I mean, the kernel already has this magic code in there that pre-mounts /dev from dev tempfs. So if we could say that the kernel has this magic code also in there, that it pre-mounts /user from a block device, I think I would probably be happy, because then the kernel could jump into that.
We have that, and we've been trying to get rid of it. It's like, no, please, we don't want to have more magic code in the kernel. Anyway, someone else wanted.
Yes. So there's, I think, Daniel, you were first.
Yeah, maybe crazy idea. Probably somebody was thinking about, is it possible to build file system on top of CPIO instead of copying?
Sure. I mean, there's overlay-fs. So first of all, EROFS actually supports something like overlay-fs on itself. So you can have a couple of EROFS images, and then they overlay, and they're exposed as one without involving overlay-fs. And then there's overlay-fs. But I think it's a hard sell to kernel developers to say that on the kernel command line that you should be able to configure arbitrary complex overlay-fs stacks.
I was not saying about overlay-fs, but I was thinking about building directly the file system on top of CPIO. So then you don't need to, then you don't need to unpack the file, the CPIO to file system.
But I mean, the kernel has no functionality for this right now. The only thing that the kernel gives you, the only thing that the kernel gives you is that CPIO tempfs mounted to / and /dev mounted to dev tempfs. This is the environment you typically end up with, and yeah.
Okay, thanks.
When we are talking about the need to compress, what is crucial in this scenario is that we may have 500 megabytes of code, and we only use 150 of that in a specific boot. So we really need to have compression so that the whole image is not too large, but then we only decompress some subset of it.
Yes, so there is no requirement for compression. You can have, if you want to have an EROFS image, you can just, your user space, that item. In fact, the initramfs protocol supports a mixture of compressed and uncompressed members. So you can have if you want, an EROFS image that you can then mount.
But if you ship an EROFS image inside of a CPIO, then you have touched the memory already, right? Like you do get rid of the decompression, you do not get rid of the additional unpacking thing, right?
Well, okay. So first of all, see previous statement. You're going to be touching this memory a lot, so you're kind of suffering from
the point is that we're not, right? Like, because as mentioned, as Zbigniew just said, like these innerties are likely going to be really huge, right? Like gigabyte even.
But it's loaded from somewhere.
Yeah, it is already loaded once, right? And then you we'd rather spend the CPU cycles on actually decompressing things, not touching always like a gigabyte of data, but instead of just like the 100 megabyte we actually need.
I'm not saying that what I'm saying is you don't have to decompress it. If there's no reason to compress an already compressed piece of data, and the initramfs supports that.
Sure, but I mean, you always get the copy, right?
Okay. We could change the initramfs code to be 0 copy if you have proper alignment of a member. CPIO doesn't enforce any kind of alignment, but we could opportunistically do it, and then you could say, okay, I'm going to align this member so that the kernel can 0 copy it.
Can you insert arbitrary alignment within a CPIO?
Yeah, you can do. You can do. You can put any number of zeros before the next header.
I mean, I guess what we could do is, instead of having one CPIO with 500 files, have 500 CPIOs with 1 file each, because then you actually can insert any kind of alignment.
Well,
it actually wouldn't be that bad, I guess.
But
Well, okay, we could at least do that for the EROF's image.
that's what I'm referring to. Yes, because when you're doing the individual files, you want compression. It's going to be faster, especially once you count in just how much additional overhead you're going to have loading uncompressed data from a firmware device. That's going to kill you.
So we have a 1 minute warning. Do you want to wrap it up?
Yeah, sure. I don't know. Do I have to say anything? Like, thank you everybody for all the good ideas. HPA in particular. Yeah, that's all I had, really. So.
Do we have a plan? Do we have a plan?
Do we, like, if we can make the TempFS thing happen that we can initialize the TempFS with 0 copy?
Yeah, I think
then we do.
We have a plan.
Well, now we just need somebody to actually implement that, I guess.
All right. Thank you, Leonard. So next talk in 5 minutes. Morning.
I think the first
Version, you want to double check
that's
Like that, like having a root FS.
having the root FS being nothing but in fact,
Yeah, I was wondering about that. Like, I mean,
all it would do is that if you're not taking advantage of this, you have an extra
but then later you'll have
What?
So you have
the internet ecosystem, then you'll have the same model.
Yeah. And like one super block structure is nothing. In fact, I personally think that those blocks kind of attractive to have the kernel threads. You know, just kind of
Well, user space and control.
yeah. And that also be at that point that can also be nothing there. Actually, it doesn't even have that. Oh yeah. I can actually look at this.
Oh, you're volunteering?
Yeah, I'm volunteering.
Yeah, to make that
I have our next year for this year.
How's it going?
It's amazing how much you get done. I said you can join on the trick with the
It's fine.
The thing is, this website I didn't know about until like he wanted it for a year in the process. It's the needed by specifically because that would help you with getting rid of the.
So it says on Euro, it says other benefits as well, which you mentioned.
All right, time for the next talk. Join me welcoming Mikael.
Hey everyone. Hello everyone. My name is Mikael Salin. I work for Microsoft, and this talk is about being able to control script execution. So a bit of context first. So this might not be, well, suited for every Linux systems because, well, you can do a lot of stuff with Linux, of course, but in some contexts, for some highly secure systems, you want and you need to really have control of what you're executing, which code is executed on your system. So in this case, you should trust all the code that is running on your system. And that means, for that, you need to have some security guarantees, some prerequisites. You need to be able to know for sure, well, if the code really comes from you. So you might rely on some existing security mechanism like secure boot or integrity checks. For instance, with a new IP LSM. But the idea here is that once attackers get a foot into your system, because one day or another that might happen, well, you don't want them to be able to execute their own code, to be able to, well, bring their own scripts, their own tools, attack tools, and so on. So what we don't have right now, well, we have a lot of stuff in Linux. We have a lot of different kind of access control systems. You can enforce them with either discretionary access control on your files, with files owned by root, for instance. You can enforce some restrictions with mount points, and with some LSM like Linux, AppArmor, Lanark, or others. So we have a way to configure access rights on the system, but, well, talking about execution, well, we might not be covered with all use cases. So mostly the issue is with scripts. So in a nutshell, there is kind of two ways to execute scripts. The first one is to go to the kernel and to use the execv syscall. So that's the first case here. And the second one is to directly, well, execute the script interpreter and pass the script as argument. So at the end, it should be kind of the same result. You might use one or the other. But it doesn't really, it's not really the same for the kernel and for, well, security systems. So just kind of about here. Well, what execution is kind of relative to what you want to execute stuff. So that might be there might be one definition for, well, CPU code, but there might be another definition for use-based code. And even, well, with some Linux feature, you might want, well, you could execute arbitrary data, like you could really well open a picture by just passing it to execv. But the goal here is really to be able to protect from untrusted instructions. So the thread is that an attacker might execute some nasty stuff, and that, well, most of the time goes through, well, calling syscalls, kind of arbitrary syscalls, or directly accessing data. So, well, you can do that with most script languages, but for instance, it is not the case for pictures, or most, kind of stateless data like this. And the goal is to not rely on, well, specific script interpreters. We don't want to have, a secure version of Python and kind of a, well, totally free and restricted version of Python, because, well, that would be an issue for maintenance, mainly, and for, well, be able to give this kind of feature to everyone. And, well, we also want to, well, handle kind of legitimate use cases. So that is not only about passing an argument to a script interpreter, but also to handling or not commands passed to standard input to allow or not interactive use of shells. So for instance, there are a few legitimate use cases here. So different ways that you can execute, for instance here, Python scripts. So yeah, you might not use all of them, but that's not the point here. The point is that with these calls, everything goes, let's say, through the kernel interface. So what matters is that the access control part of the kernel can, well, should be able to restrict this kind of stuff with the new feature. What should not be allowed, because, well, on a really secure system, is to only rely on a script interpreter to interpret stuff. So for instance, just calling Python and typing commands or scripts, well, there's no way for the kernel and really for the access control system to check if it's trusted, secure, or not. So of course, well, there are different use cases, and well, for instance, for system administrator or end users or developers, well, you need to have this kind of feature. So that's okay, we need to handle that. So there are really different use cases, and there are also use cases where you don't want arbitrary code to call scripts. For instance, if you have well-defined system services, let's say a web server without CG scripts or stuff like that, well, there's no reason for this web server to execute, well, to even call Bash or Python, except maybe if there's kind of injection issue in your website. So that would be a way for an attacker to get a foot in your system and then be able to freely, well, operate on it. And one thing to keep in mind is that we could enforce some restrictions on script interpreters themselves, but, well, we want to have something consistent, to have a consistent security policy throughout the system. So well, the common point is the kernel semantic, and what the kernel can enforce. So there is really two steps here. The first one is to define what should be able to execute or not. And second is to enforce this restriction or not. So for the first step, the last proposal, the last patch version, so there are links at the last slide, is to extend the execv add syscall to add a new flag, so I think the fourth argument. And the use of this flag with a call to the syscall, like one of the arguments might be the file you want to execute, then the arguments you want to pass to this binary, and then the environment variables, and so on. And so if you use this flag, then the result should be kind of the same. I mean, from a security point of view, it should check if you're allowed to execute this script or not, and then return 0 if it is okay, or e-access if it is not. But yeah, that's the point here, that it is only a check. It is just a way for your space to ask the kernel, well, will I be allowed to execute this script if I directly path them to execv? So really, the idea is to tie to the same semantic as the kernel. The second part is to either enforce or not enforce restrictions on script interpreters, user sessions, system services, and so on. And, well, I would say that's the main challenge here. that's a quite challenge because, well, user space and kernel are not hosted on the same repository. You might have a lot of different kernel versions with running different kind of user space, different kind of version of Python, Bash, or whatever. So you need to have a way to give some power to system administrator or distributors to configure either they want to restrict stuff or not, according to what is installed in the system and what is configured. So the idea here is mainly to add new secure bits. So these secure bits are, well, mostly informative flags that are set for one process and inherited for every new children created by such process. So the first one is, well, for use space, for script interpreter to ask to the kernel, should I kind of follow the kernel security policy when executing a file? So that's the segbit exec restrict file. The second flag is for use space to ask the kernel, should I let users that is running, well, the current process, kind of inject arbitrary script, and should I execute that? These are two complementary configuration flags. And if you want to have a really full control system, well, you should enable both of them. But either one or the other might be useful, even for a kind of incremental change of your system and to make sure that it works. So that was the main way to configure script control execution, but that might not fit for all systems. Some might be a bit more complex, and you might want to have more, well, some exceptions and so on. Well, one thing I didn't mention is that by default, these flags here are not set, which means the current behavior isn't changed, so nothing breaks. But if you want to have an extended security policy, for instance, to only allow a set of users to execute some scripts, but with some set of script interpreters, well, you could do that with an extended, for instance, SNX security policy or uppermost security policy. And yeah, so there's one way where we want to easily configure some set of processes. For instance, if you want to launch a container with some script execution restriction, so you can do that with PSCTL, so simple code. And if you own the full system and you own the security policy, you can have much more fine-grained control on that. Another thing to keep in mind is for this kind of restriction to be efficient, well, you need to have something which is consistent. And, well, the idea is, for instance, if an attacker got kind of access to some shell, or you might be able to execute to change argument in exec syscall with, let's say, a PHP issue or this kind of stuff. Well, the attacker might control, for instance, environment variables. So it might, for instance, set, well, LD payload is set to this text, is set to this path, to this file that previously uploaded on the server, this kind of stuff. And of course, that will change the behavior of the execv. So for this, to have something consistent, we also need to patch the LPC to have constant security policy through whole the execution story of Linux. So here are some drawbacks of the current implementation, some limitations, but that should be okay for what we're looking for. So first, well, the idea is to use execv at the execv at syscall. So there are two ways to execute a file. Either you pass a string, a path, so text, or you might also only pass a file descriptor. So there are, well, use cases for both, of course. And from a security point of view, if you want to first check that you should be able or not, you should be allowed to or not to execute a script, then you should first open the script, use this file descriptor, pass it the first time to the execv at syscall with the @check flag, And then, according to the result, we'll interpret it or not. If you use the same path only and not the same file descriptor, there might be some race conditions. So from a security point of view, it might not be a good idea, but there are kind of legitimate use cases. For instance, if you want to have a tools like find that might check some properties on some file, well, it might not need to open the file to actually read the file, but only get this kind of property. So that's the kind of flexibility Linux and Linux actually wants. XAV only works with regular files, so you cannot, well, if you pass pipe or directory to XAV, it will just return, well, this invalid, but that's okay. Well, secure bits were until now only useful for, well, only used for root kind of access restrictions. So if you wanted to kind of limit the use cases of capabilities, for instance, well, there are some secure bits for that. But the underlying ID is kind of the same. There are a set of restrictions that are set for a process and inherited across all the children. For this to work, you, well, need to have security policy. So one way to do that is, for instance, to set, well, the executable bits on every script that you may want to restrict, and also, of course, executable code, but that might not be direct scripts, but libraries too. But that should be okay. Thanks to the incremental approach, there's no need to change and to update the whole system at first. You can start piece by piece. And of course, last but not least, well, if you want to have a secure system, you need to know what your code is doing. And, well, writing safe scripts is, well, might be a bit more difficult than writing safe executable code in other languages. So, well, you need to be careful and to check that, well, some random input and some random data might not be used and evaluated as code. Otherwise, well, that would not be useful. So, in a nutshell, that was not the first approach, but the 19th. There were different approaches before. So quickly, the first one was to extend the OpenSys call and to add a new flag or make deck. So that was the initial approach. The second main change was to use the fxsr to syscall. So that's a syscall which is used to get in file properties, so really access permissions tied to a file. So something to keep in mind that is not enough to check if a file should be executable or not, because some properties might not be on the file permissions, but they might, for instance, be on the mount point options. You might have the noexec configuration set, so checking only with this syscall is not enough. Then we created a new syscall, which was kind of more generic, but maybe too much. And we are asked to really provide something which sticks to the kernel semantic, to have really the same semantic and to know really what the request should do. Then we also had a proposal to extend, again, the access syscall with a new mode. But once again, I think that's not a good approach, because here we're not only looking for file properties, but for file properties according to a context, so to namespaces and so on. So that's why we ended with this patch series, which is actually not exactly what I talk about. I proposed some changes. So this talk is about, let's say, V19th. But that's the main ideas are already there. So in a nutshell, there are two main changes. The first one is to add a new flag to the XAV add syscall for use space to be able to check the kernel semantic if the kernel will execute or not a file. And the second is for use space to configure user space in a kind of a generic way, to let the system administrator express if for, let's say, user session, a web server, whatever, if some restriction should be enforced or not. So we're working with some script communities. So there's a proof of concept for Python. And yeah, we're looking for more help to kind of enlighten these script interpreters. So that's not, well, that's something which is new for Linux. That's not something which is new for some other operating system, like Windows. So there might already have some framework in place, which should ease these new changes. And of course, we need to update the LPC. The next step is to send new batteries, which are much simpler implementation, and to also include a TOR interpreter to let everyone see how this is used in practice, and to extend some tests, so that should be sent very soon. And then, of course, to enlighten script interpreters and LPC. So you can find some resources here. And now feel free to ask me any question. Thank you.
So the actual check is done by user space.
Yeah.
And so why not just have user space do the check using maybe a shared library to implement the shared code and not involve the kernel in this at all?
Yeah, that's a good question. One thing to keep in mind is that interpretation and execution really is something which might not make sense for the kernel. A Python script, there is no Python interpreter inside the kernel. So by execution here, well, this might be interpreted by user space. So interpreted might be the only part of the system that know if, well, this is code or not. So you cannot directly ask the kernel, well, should this data be executable or not? You need to rely to someone that will interpret this code. So for instance, for an ELF binary, it is the kernel itself. So the kernel knows if it can, well, it makes sense or not to interpret that. For Python scripts, it is not the kernel, it is the Python interpreter. So the trust is kind of delegated to this interpreter. And the system already allows this interpreter to be executed. So the system already trusts this code to do the right choice.
Yes, exactly. And so we have delegated trust to the interpreter. So let the interpreter make the decision on its own. And then, for example, so because Python might be executing a Python script, or Python might be executing a snippet of Python code that was passed in some strange way. And in this second case, well, in the first case, we could ask the kernel for help. But in the second case, it's only Python itself that can reliably make any kind of decision about this code. So just let it make the decision and have also in parallel another way to make a decision whether given code should be executed. And this policy can be even stored in some shared file on disk so they can update it easily. But you will need to have the interpreters doing the decision anyway.
That's what is done. There are only, I would say, passive APIs that are made for interpreters to use them. So that's their choice if that's just tool for them. These are tools for user space to check some, well, if they should execute some stuff or not, but the final decision is their own. So you might want to add some, well, complementary configuration file, for instance, but at the end, from a system administrator point of view, well, you need to have a consistent security policy across all your system. So you need to have something that makes sense for well, executing ELF binaries, for executing Python scripts, to load shell libraries, and this kind of stuff. So yeah, that's kind of a middle ground.
Would you also consider a disk image loaded by QEMU as interpreted code? Or where is the boundary?
Yeah, that's a good question. Again, the question is, what is execution? So the question depends on your use case. But what matters here is really, it is really a security feature. It is meant to be used by security systems. So the question to ask is whether executing an employee virtual machine could harm your system. So if you let an attacker launch a virtual machine, I guess there's an issue there. So either there is no accessible, let's say QEMU, accessible for this attacker. In this case, there's no question. Or, this attacker might be a developer. In this case, there's no solution. So really, the idea here, once again, it might not fit. It will not fit for every systems. Developers need to be able to write their own script and to execute their own script, but we don't want attackers to have the same ability. So, yeah.
There's not that much difference between this and running an ELF binary, simply because we already delegate a whole lot of things to user space when we start loading shared libraries. And so fundamentally, we already have a case today with ELF binaries where glibc or LDSO is going to bring in a whole bunch of code and allow it to be executed without any kernel permission control.
Yep.
Have you envisioned extending this to also the dynamic loader and enforcing this on shared libraries as well?
Yes. Yeah, that's the idea when I say, enlighten libc, okay. That's what I mean. Yeah, there's a bunch of details, but you're right. Well, if you want. So last word maybe. So these kind of restrictions are enforced by Windows, but kind of already by some specific Linux systems, like for instance Chrome OS. So, but they are kind of hacky solutions and not generic enough. Thank you.
Thank you.
Right, 5 minutes to the next talk.
If you want to organize a BOF, it's kind of you to check if there's availability. But just to check.
I forgot to mention one thing was to thank you for all the insights. Thank you. That was really
Yeah, it makes sense. I just wanted to know about it. Yeah, I don't see why there's a kind of needs to be involved in this overall because this role is definitely I did a very specific thing and it's not
I have this one for moral support. I really have like a 5-minute talk, so it will be early break.
If he goes over,
Sure.
All right, time for next talk. Let's welcome Zbigniew.
Hi, this is going to be a very short talk. My name is Zbyszek, and I work on systemd in Red Hat. And this talk is about something kind of similar to Leonard's talk, that where the user space needs a little bit of help from the kernel to do things the right way. And we are, in this case, we are 90% of the way there, but just some missing, some bits are missing to have the full thing working. So when we, this was even mentioned also in the previous talk, it's when we execute something from disk, we find an executable to launch. So systemd does this all the time, right? For example, we look at the executable, and then we spawn it by path again. So it is in principle possible that somebody changes the binary on disk in between the inspection and the execution. So we would like to look at, when we inspect the executable, we would like to look at, I don't know, the permissions on the file, and for security reasons, but maybe also for other things. In systemd, we added this functionality to, well, not in the systemd project, the functionality to inject information about package for which a given binary was compiled. So we can inspect a binary, and for example, before we execute it, we could record the package version from which this binary came. But if we do this and the upgrade process happens in the background, we could actually, well, record stale information. So we would like to use a file descriptor to spawn the binary. And we have fexecv, which actually maps to execv@, and so we would like to replace the execution by path with execution by a file descriptor that well maps to the path that we previously inspected. And yes, we can do that. Systemd has code to do that, but it doesn't work as expected because of the following problem. Well, you launch the executable, and things like pgrep don't work. The process is there. It looks okay, but if you look at the com value of the process, it contains the file descriptor number. So it should say sleep here, but it should say sleep, but it says 4, and the 4 is particularly offensive because it's the file descriptor of the calling process. So by the time this process is actually called, this file descriptor has already been closed because it was opened with fd with awk exec. So this is a number that is not useful, and it's completely meaningless to the process that has this number as its name. And I think if we fix that, we can use fexecv to spawn binaries. So the ask is for the kernel to allow us to set com in some way, whatever arbitrary way, before execution. it can already be set after execution. So like we could go over every binary and fix it to do it after execution, but well, that's hard. So realistically we cannot do that. So the only way is to have the caller do some additional step before execution to set the COM value. And well, I hope that there is some ideas how to do that, and it will be a trivial patch in the kernel.
Anybody? Yes.
Maybe I misunderstood the problem. Like, why is it better that they can do it before rather than after? Like,
well, after, so we transitioned from, let's say, from systemd code to Python. And Python would need to know that it was called by systemd in a special way and actually needs to fix up the execution. So it's, I mean, we cannot patch every binary out there to support being called in a different way.
Any other comment?
Actually, some binaries look at their proc_self_exe to decide like what to do. So even some binaries don't know what to set it to. I wonder, can you just have another PRCTL that's set after exe or like after exec? There's like some precedent for this, like AppArmor does this. You just keep the string around and then set it afterwards.
Interfaces like this are always a little bit icky with multi-threaded processes, right? Like, because you set it and then some other process gets weird comms fields set.
So maybe a crazy idea. We just started in glibc PID FDS spawn. Can we maybe add a new POSIX spawn set attribute for this, and then have glibc set this after they fork the process, but before they exec? Because we use PID spawn now to spawn
so
processes.
So basically you're saying that if we link to not glibc but something else, new lib, and then it doesn't work, and then we do a whack-a-mole.
Yes.
Oh, sorry. I guess you can stop the executing child via ptrace on exit of execv, and then you can fix up the COM. At least, well, it will be race free, but it's a hack.
So, I mean, back to the upstart protocol, right? But it will actually, yes, it's enticing, but.
So maybe dynamic linker can do this early. Dynamic linker actually executes a lot of instructions before the actual main of the executable is started. So it would be able to do a simple thing like this.
But set it to what? Yeah. Triggered by what?
So how to pass this information to? It should be a way.
Magic.
Not necessarily magic. Not necessarily magic.
Other ideas?
Yeah, I mean, but please note that I mean, we can figure stuff out like on the user space side, but the current thing that the kernel sets is just completely pointless. It's like an implementation accident that doesn't. It's just not. It's a random number essentially. Well, like not very random, but a bit random, right?
Yeah. So which subsystem of the kernel does this? I have no idea. Do we have the right person in the room? Is the question.
I don't know.
It's exec. It's well, case in that case. Yeah, I mean, the one suggestion that you had was like if you do at empty path to somehow stuff it into the path argument or have some sort of special flag. I find all of that pretty distasteful. To be honest, it feels very hacky. So the PR cuddle waste, like having a new special PR cuddle might be the best thing, but
So PR set name lets you set like an arbitrary string. Do you need the string to be arbitrary, or is it? Because the thing I'm wondering is like, if it was the case that the com you would get, I mean, I think the PR cuddle in theory would be nicer because it's more generic. But if it was just the case that like rather than getting the number, you get equivalently what proc_self exe would give you in com.
I would be perfectly happy with that. Yes.
Okay.
I mean, it will solve our case.
Okay.
So do we have a deal then?
Yeah, I just want to point out that like if you're going to exec anyway, you're going to destroy all your threads. So actually, it doesn't matter if the API is thread safe or not.
So this is not going to work because true and false, like these binaries, are hard links are symlinks to each other, like depending on distro and implementation. And basically, the exa one will always show to the final one. So that basically would mean you can start false and it will show up as true.
Yes. Proc_self exe actually. Yes. I take back what I said.
Oh, by the way, I take back the earlier thing I said about the threading. Doesn't matter, of course, because we're talking about exec, right? Like hopefully, like I mean, if you do exec in a threaded application, you destroy everything anyway. So it's fine if we have one field already set up because this is not something that's going to happen, right? In case of exec, you will already have forked or you will already have closed all your threads, right?
Wants the box. Have you got enough out of this?
So it cannot be set like proc_self exe, but it should be set like argv 0. It could be set to.
Yeah, but that's also weird because argv0 usually, in many cases, contains the full path. Right, so then the kernel would have to look for a slash and then cut off the prefix and things like that. It would be kind of magic then. So, but I mean, something I wanted to say is like, I think it was a misdesign in the system call, right? Like it was an omission in the system call. So maybe this is like, the system call should just be fixed so that there's exec ve add 2 or something. And it's the same one as the current one, which just gets a flag parameter and an additional structure, and then we can add whatever the fuck we want into that structure.
Well, also, we have exec v add with add empty path. Where is the here? We could.
Okay, it already has a flag.
We could add another flag and then, like ignore and put this
here in this.
Well, that'd be different to every other Right, but then it would be different to like every other add syscall because like I mean you can have arguments about the add empty path design, but like I mean.
But I like that idea.
That's better than PRC.
Well, the thing I was going to say, hang on. The thing I was going to say, sorry for the argv thing, is that the kernel, I mean, for com, it already has to parse it, right? Like that's already a thing it has to do. So like if the issue is that, I mean, from my perspective, I think that if we're going to say, well, personally, I think it'd be better if we just fix this for everyone. And like, as you said, it makes no sense to get the number. And yeah, you're right, the proc_self exe thing wouldn't work. But again, if argv0 is, I mean, personally, given that proc command line, proc_self CMD line is set to argv, like, why would it not also be the same for com? That's my thing. That's my guess.
So I quickly wanted to say that I kind of like the idea of using, like overloading the second thing, because ultimately this is exactly where com is initialized from, right? Like, so if you actually do specify something there, that is what com's going to be. So it kind of makes sense to say that if you do empty pass and add an extra flag, that we directly, like we only use it for com, that sounds very natural to me, actually.
It sounds natural to you because you want it.
Repeat the comment for the audience.
I said it sounds natural to you because you want it. I think I keep wondering, wasn't there some sort of, we recently changed exec behavior or exec viet behavior because it's not legal to pass argv0 as null. And when that is because then you can trip over other user space programs that rely on that not being null. So I think we silently behind now fill in some random string when it happens. And I wonder if we can make use of that, like when you pass argv0 as null and you use execv@. I don't know. I know it's
So
all,
wait,
it's
so
all
you're
sounds
saying
ugly
that
to me.
instead of adding a new flag, we should put a string starting with 0 and then magic value after the 0 and then another 0?
That's sexy.
I mean, I just don't. Maybe I'm missing something. Like, what is the problem with just making argv0 be the source for com? I mean, like, I understand like it's different to the way that it's done without empty path, but the whole point is that empty path is special in that way. Like, but they, I mean, but it already does that. Like, if you pass a full path in execve, it already mangles it, right? The com is already mangled in that case, right? Like, it's the same. Oh, sorry.
Well, I don't know. I personally find it weird. Like argv is like this really user-controlled string, and you can basically pass anything you ever wanted there. And it sounds really weird to me that this user-controlled thing that where you can pass with the weirdest shit, basically, like I don't know, escape characters and whatnot. Right, and then you mangle that and parse off everything out before the first slash. That sounds so strange to me.
Yeah, but com is already user controlled. You can set it with set name. Like but maybe it's just me, but I don't see the difference between com and CMD line. Like I mean, obviously they're different, but like conceptually, what's the distinction, right? Like, it seems like if you.
It's about initialization, right? Like, I think conceptually the difference is initialization, right? Like one is initialized by the kernel, the other one is initialized by user space, and suddenly yeah, I don't know.
Any other takes?
So I don't know. Just to like summarize, I think that it doesn't really matter for the user space side which option is used, but like we are 98% of the way there. Systemd has the code to do this for the last 2 years, and except we cannot enable it because well, this stupid thing is missing. So.
One thing I want to say very quickly about the argv thing is if we did use argv, then this would fix all programs that do that, as opposed to having to update every program to do it, right?
Yeah.
That's at least one benefit over the functal or kernel.
So then are we going to do that?
The file descriptor that you're using is the file descriptor of a regular executable. It's not some shit like proc self fd something.
Yeah, it's the regular file descriptor for the regular file.
Yeah, but I mean, then why can't we change it internally to do something with dpath?
No, but the problem is that the problem is like BusyBox, where everything is a symlink, and so if you use dpath, then yeah, exactly, yeah.
No, it's not the problem because you will get. It's not the problem with with hard-linked executables because you get this information from argv0, and no one uses com. It's used only for PS and the like system inspection stuff. So basically, it doesn't break anything. Like the behavior is just weird and well makes system less usable. Having com set to nonsense when you run execve with zero path, with empty path, because well you pass the information about what command to execute via argv0. So I mean, I guess like the best approach to fault kernels to try to like do some hack like with ptrace or whatever. I like P-trace because, well, I propose it. But anyway, but for neural kernels, I think that, well, your idea about like supplying COM via the second argument is the best. Well, an additional flag, because well, no one cares about COM in that sense, I guess. Because well, it's 16 symbols anyway, and so on.
I wouldn't be so sure, by the way, if they really don't care, because, you know, for shell scripts, like for interpreters, like argv is going to be like the original command line, right? And com's going to tell you about the interpreter, and there are some interpreters which enable, I think Z shell, for example, has this born shell compatibility mode that it looks into com. So I don't think you're right. I don't have proof, but I'm pretty sure there's some logic where people, like interpreters, look at how they're called and behave differently.
Right, but it's like, does Z shell check that com is Z shell, or is it it's just checking that argv is not? I mean, like I get, like in theory, I guess something could break, but I'm just wondering, is like, is it like if I'm the author of Z shell, I'm not going to be like, oh, is the programmer currently running Z shell? Like I don't see. Maybe someone does that, but I don't, like I understand checking arg 0.
It looks at argv 0, I believe.
Yeah.
Yes. I mean, all shells do that.
Right, but like, so I guess the thing with the argv thing is that like, if com was wrong, so it's like if you're running Z shell, but like com is bash, is that actually going to cause a problem or not? Is the thing I'm wondering.
It causes problem in a different place. Wait, but wait, we have it. Oh.
Where is it? Yeah, I think that the COM is mainly used by kernel because it's limited to 16 bytes, so it generally cannot work if someone wants to decide on that. And secondly, I think the purpose is so that the kernel has a copy of a string that it can use for its purposes, and it doesn't have to reach out to the user space memory.
Well, it's also used by pgrep and other things, right? It's like different things look at different fields, but it's not just the kernel. It's the user space certainly looks at it too.
Yeah, but okay, so it's for some debugging, or it's not for like deciding some logic, or
no. So pgrep, for example, looks at com.
And it's com. It's not looking at a CMD line.
Pgrep, pkill. I mean, I'm surprised how, because I was running on my laptop with this code enabled for a while, and most things work, but it's just some select things that don't work enough to be annoying. But
okay, so I just wanted to point out that it's limited, and yeah, I thought that the purpose is for the kernel, that it has the copy of the string.
Yes, I think the kernel makes a copy.
5 minutes warning.
Yeah, I think we should wrap this up. Just, you know, it's a plea for help from my side. So.
All right. All right. Well, then, thank you very much, Zbigniew. We are now on a break. We'll be back at 12. Back at 12.
Which is the structure that they use for 65 minutes.
Why is that?
They also kill processes, like services via files, because bits are reused. We added, everybody uses this --name switch, right? And it's explicitly documented to use the com field, process comment on the test. So the com has policy. So it comes with a lot of value. Am I
far right, but like you basically having a driver right? Like, so, but are you sure the systems are ready for this so that they?
By default, they will just do the same stuff that is right.
So digitally, in system we have this function that checks like that uses fxs xok on file descriptors all the time, right? Like because we want to know if something's executable before we do something with it, right? Like I think we use it, for example, when in the execvf case that this was just about, where we basically pin the binary that we're going to execute. We do a couple of things because we need to figure out if it has an interpreter and stuff like that. Because if you use fxvf, we have to start with interpreter. So that's a couple of things always with the simulation, and we would like to call it if we did this already, we would like once you were seeing land, right? We would have your stuff to raise the question why can't it be the stuff that we already do? Because then it has a magic effect that suddenly the stuff that system does also does your stuff, right?
So yeah. So what I guess what System is doing now is a sort of also saying like less setting so this kind of status is speak in-house but yeah, they need to do pretty sure the code they have access because check some it's not in my mind anymore.
But I think I think I can answer my own question now, which is that it's not generally accepted that Python scripts and so on should have an
I know doing that over here now. So
in that world where Python scripts do not necessarily they're still executed, my solution would work. Like, because I would require everyone to send it. Okay, I answered my question.
So that's that goes only about the check, maybe check or access, whatever, but not the configuration only one.
Yeah, secret and then the definition of form.
Maybe the trick is you're extending fx exactly anyway. Maybe add a constant at the same time. Add like a flag, add a constant.
Because your budget is so easy to get.
Good idea. So next year, here the satellite versions. So they will approve last year.
And the benefits, here's your
the next 10 years.
I'm told that Tejun might be on a plane.
Oh, okay.
But,
That might be.
But I gave him the reference for the talk, so at least he'll take a look. And he
Thank
can
you
talk
very
to
much. Thank you.
Okay. And there's something to.
I think so. There's tea and coffee.
When's the next thing?
12. 12 o'clock. Half an hour. I don't know the guy. Sounds like I'm wrong.
Yeah.
Name of the process.
Yeah.
So yeah, there's a few files.
Did you fix your bug?
No, we found out that figure form works. Maybe not very good, but it's.
What's that called?
I mean, it's good enough for Debian, right?
Oh, actually, we wanted to
Just
change
try
that
it.
and move to copy. Yeah. So which one works? Is the int or the PopPS one that works? Because there's two.
Don't give them any more ideas.
Should I propose the general functionality to have a BTF button that you can do arbitrary fix up in the kernel? Have this rejected?
You're too late. It has already been done. There was a proposal for BPF to write arbitrarily kernel memory. And that got shut down. That would only be executing arbitrary scores from the new processor. Yeah, true, but I don't think it's going to find any more changes. It's the people accepting ethics.
Yeah. I mean, then back to the idea of adding a new POSIX app, setup, whatever, and that you see do it then. Because that is for sponsors.
I think that having a new flag for the function call, for simple, is the most obvious straightforward. This would be like probably done by someone who knows it and somebody who doesn't know it and they
Okay, but then maybe I ask Christian why he was so strongly opposed to it.
I mean, I agree with this kind of ugly, but also.
Drink a beer with Christian.
chat is there intentionally because if people want to interact, because this is.
I never want to see whatever the fuck Neil Bomper has to say about anything.
We're live. There's a microphone there. This is a hybrid conference, so we want people to participate there, and the reason we have that is that we want people to, if they are connecting, to show up, turn on their camera. It's an open source.
Yeah, I did this, increase the font size of my slides once I saw how tiny it is.
That is a good shout. Let's see if mine are readable. Yeah, that looks readable. Okay. All right.
And I'm sure we'll know this next week. I mean, the buffer is the stuff that we need before, the stuff I added was the stuff we need for Mochi and for Muncie, the UCI stuff.
But Mochi is that written Rust?
That's really good. Rust with CFI to get Go functions. So that's what I want to use.
Oh, wow.
Well, it needed to be a shared library with CFI things. If you want other things to use it, it can't be a Go library.
But I would always have assumed that Go feeling library. There's always good to say like you think could be language infused.
I mean the Go binding is because the design is like FD based. The thing is that the annoying thing is that it turns out that most languages that have an FD construct, they really don't like. At least in the case of Go, for instance, Go's like OS file is like supremely magical. Like it has a lot of shit they have already. For instance, the fact that you can double close it is done using this like complicated like atomic system that only the Go runtime can use. Which this is just a lot. They have like it's like atomic because you interact and read the vitals and together all of them. And you could reinvent all of that yourself, or if you use OS file, that's fine. The other problem is that like if you want to have something that's like it's like file like like you just struggle with like leaking files. At least Go there is a way to leak a file in Go, but like there are ways you can accidentally forget to do it, or you can mess it up. So. Like there is like a library that I think this thing, which now has some of the stuff we need for security issues. We're probably going to do something.
Do you ever look at the stuff that we have the asset system yet?
Oh, did you get the like Chase outside? He was standing right next to it.
It was basically a shitload of that water right in the street. We were basically swimming in it. So like the Chase thing and a couple other things like maybe FS util and file util. I think like basically stuff that we use to write files atomically.
Yeah, I looked at Chase. I looked at Chase out and I looked at a couple of other stuff. I didn't look at all the stuff because it wasn't clear which stuff we want back. Because I mean, I didn't have pros yet. I mean, like that makes sense. I mean, obviously, with interest in the kernel, if it's a library, then you can have some
Organizer. Can you do me a favor and keep the time?
For you?
Like,
I'm not sure if I have that in.
because the other guy is gone.
Tell me how long.
25 minutes with a half minutes for.
25, so that ends at 12:25.
Yes, thank you very much.
is this thing on?
All right, we are 12 o'clock, so back in session. Next up, I am up. So hello, my name is Luca. I work as a software engineer at Microsoft in the Linux systems group, where I work on the Azure infrastructure. And I'm also involved in various projects like systemd, Debian, DPDK, and more. So today we are going to talk about PID FDs. Quick look at the agenda. First, a very quick recap on what they are, why we need them, and the work that has been done already on them. And then we move on to the important part, which is what gaps we saw while doing all this work to plumb them through the basic layer of the OS, and what we would like to have to fix those gaps. So the recap first, why do we need PID file descriptors? Because PIDs can be recycled, as we know. Used to be they went up to 65K, we increased that to 4 million and change, but still forking is unprivileged, so attackers can run the counter and overflow it. And this is not hypothetical, there were many CVs around this in the past. Now, this is important because nowadays process tracking is not just a parent-children affair, but there are things like polkit, dbus, and systemd that need to track other processes as well. So the usual thing of calling wait to see if a child has exited does not work. Some ancient history, so Christian added the PID file descriptors in 5.3, I believe. These are file descriptors, so instead of tracking a file, they track a process, and they're valid for as long as the process is alive and hasn't been ripped. And once that happens, then the file descriptor becomes invalid, and it can never be recycled, so this solves the window. Hooray. Also, because they are file descriptors, you can pass them around via SCM rights and other things to AF Unix peers, which is kind of nice, which means this is not limited to parent-children, but you can pass the descriptors to peers as well. And at any time, you can go to, if you have proc mounted, you can go and resolve a PID FD to an actual PID. More recent history, so in kernel 6.5, Alexander from Canonical added some SCM PIDFD and SO PIDFD, which is a bit of a mouthful. Basically, this allows you to ask the kernel, hey, give me the PID file descriptor for the peer I am talking to over this socket. And you can get this race-free, which is, again, kind of nice. Then Christian in 6.9 added a new file pseudo-file system, PIDFDFS. And this allows you to do kind of nice things that we needed, which is to, for example, compare for equality. You have two PIDFDs. You can now compare them and see if they are referred to the same process without a resolved in them, which is kind of nice. Now, with all this stuff, one more. glibc in 239 added PIDFD spawn, which is the equivalent of POSIX spawn, but it gives you back a file descriptor instead of a PID. Again, this closes the window where you have to go and take an FD manually after getting the PID back. And with all this stuff in place, then we started plumbing PIDFDs through the Linux user space lower level stack. So systemd 253, we added a bunch of new APIs. We still have a bunch of get thing by PID, both via dbus and via the SD library. And now we have the equivalent with PIDFDs. So yeah, shout out if you are using these APIs, please do switch over to the PIDFDs one because they are there, they're available since 2 years ago. In 255, we changed the way we spawn services. So we now use the new PIDFD spawn if it's available with glibc 239. And that also allowed us another nice thing, which is to use clone into cgroup because it's a clone tree wrapper. So before this, we used to spawn a process and then later move it into the final target cgroup. Now we can do this in one call, which is great. And I believe by 256, we are done with switching almost all the internal tracking. I think Lennart did most of the work there. And we are, I think, almost all done. And we are using PIDFDs through systemd to track processes and services. Other parts of the stack, so the dbus specification and the implementations now can give you back the PIDFD that refers to a peer. It already had this get connection credential, where you can ask for the credentials of a peer, and it gives you the PID, and now it also gives you the PIDFD. is available in a released version of dbus broker and in the next version of dbus daemon when that will be released. Then the first interesting use case, at least from my point of view, is Polkit. So Polkit allows you to authenticate and authorize unprivileged processes to do privileged actions. And in 1.4, we are now using PIDFDs to track processes in Polkit. Now, there used to be a big fat warning in the Polkit Unix process tracking source code that says do not use this. Because of this PID recycling problem, there were real security issues and it was basically unusable. It was only usable with dbus peers because the dbus broker tracks clients for you. Now, thanks to the magic of PIDFDs, it is now safe to use Polkit to authorize AF Unix peers as well. And this has become more relevant because of the varlink stuff that is coming as a new LPC protocol. And if you're coming to All Systems Go, small plug, Lennart will have a talk about varlink there. And another nice thing you can do in Polkit 1.4, thanks to this stuff, is that you can authorize or deny based on the systemd system unit name. So it used to be that you needed to check the UID or the group or whatever else. Now you can also check, is this subject, so the thing I'm authorizing, this system unit? And yes or no, and then you can use that as in your rules. Now, that's for the history, things that have happened. Work in progress. Now, one more thing I'm doing in user space that I think is kind of neat is that we are able to remove setUID from Polkit. So the way Polkit works is that it spawns an authentication agent in the session, the user session, where your process asking for authorization is running. And because it needs to authenticate the user, in case it's running interactively, for example, on your desktop, it needed to run the PAM stack, and that requires root. So the way it currently works is that there's a setUID binary, and your user session will the authentication agent, if you use a session, will exec this setUID binary. And setUID binaries are bad. We know that because of many reasons. Again, this is not theoretical. There were real security issues because the attackers control the execution context of a setUID binary, so if there are vulnerabilities, they can very easily exploit them. Now, thanks to the PIDFD stuff, I have a pull request in progress that allows this agent, instead of forking and executing the setUID binary, it will talk to via F Unix to a system service, socket activated, which runs as root, but it will be run by systemd, not by your unprivileged user. And then it passes over the PIDFDs and the credential that you got with SO peer cred. And then we switch to this, and we can remove the setUID bit from this binary. And it's one of the last one we have, at least in the low-level system. And again, this is work in progress. So the important stuff. What's next? So we are, as I just shown, slowly moving things over. But as this work went on, we found some things that, some gaps, basically. And there are some that are easy. At least they seem easy to me, naively. And there's one that is really difficult. So let's look at the easy ones first. Now, fair warning, I am not a kernel developer. So this is probably completely wrong. But this is the one that seems easy to me, and I managed to hack it together, and it works. So right now, to resolve PIDFDs, you must have proc mounted, and you have to do string parsing. So I think I've implemented this string parsing in at least 3 different projects, all over from scratch. And glibc now has an API that also adds another, at least the 4th one, at least, that there is. So it would be kind of nice if we had an API that kernel provides to let us directly resolve PIDFD for the cases where we need it, and without having to need, for example, proc mounted. There are still some cases that run where this is needed to have proc mounted is problematic, like some build system, for some reason. So this is what I came up with. Please shout at me if that is completely wrong. Otherwise, I can send a patch this to the PIDFS maintainer. You have any comment on, does this look fine to do with an IO cuttle? I mean, the thinking was, it's a file descriptor, so IO cuttles make sense. But.
I see Jeff behind me on the camera, and I think we talked about this briefly in relation to other patches, because we 611, 610 and 610 adds a bunch of new ioctals to PIDFDs. And in 610, I also added ioctals to NSFS that allow you to translate PIDs between PID namespaces, which is also kind of useful. And so the problem here is if you call PIDFD get PID, it would always be relative to your PID namespace.
Yes.
And if the PIDFD that you're getting is not within your PIDNS hierarchy, which probably could happen if it's difficult that it happens, but it can happen, and you would get 0 back, I think, or ESArch, I don't know, like some type of error. So I wonder if it wouldn't make more sense to have an extension on NSFS where you
on
can
what, sorry?
On NSFS, which is like the namespace file descriptor system. It's also a separate file system internally, where you can pass the PIDFD through an I see what the problem with this is. You would have to always I mean you would have to always open a NSFS first, which probably is kind of problematic. So yeah, by default we should probably have an ioctal for this on PIDFS, maybe with the ability to also specify a PID namespace. I don't know.
So we need input and output basically in this. That's what you're saying to me. So if I were to send you this,
I think this is a perfectly fine API.
Okay.
I'm just always thinking. I try to think ahead of what do we want? Will this be enough down the road? Will this like cover all of the use case? But in the end, we can always add another ioctal if we have to. This is fine. This is what I proposed or mentioned in a thread with Jeff a while ago.
Okay.
It's like this is something that we need. So yeah, I mean.
Okay. So that's the easy one then.
Yeah, I mean, in the future, I want most of the operations where it makes sense that we currently require procfs for to not require procfs anymore, but that we can only do it through PIDFDs, so that you can even use it in environments where you don't even want to mount procfs.
That would be kind of needed. Yes. Thank you. So easy, so I'll send you the patch. Yay! Next one also seemed easy, and I managed to work it together. Again, not a kernel developer. One thing that I found that I need to do in Porky, for example, is to check the credential of a process. And Porky does this by parsing proc fd, whatever. Sorry, proc PID, whatever, status. If we are talking to a peer or a socket, we can already do SO peer cred, I think it's called, and that's nice. We get the struct ucred back, but there's no way to do this with a PIDFD. So again, very naively, I did that thing there, and again, it seems to work, but is this the right thing to do for this kind of stuff? Can we return a ucred, for example, or is it the wrong thing to do? Is it ioctl the right approach in this case too, is the question.
What do we do? Is there any concept where you can find out the credentials for a process identifier in any way?
Yeah. Proc status.
Proc self-status contains all of the
so again,
fields,
you need to resolve the PIDFD to a PID, and then you need proc, and then you need to manually parse status. So again, same thing, it would be nice to have an API for this, and I would immediately use it across things.
You do realize that struct ucred contains the PID, so your prior slide is kind of useless if you have this.
Yes.
I mean,
but it's for the UID and the GID.
If you know that you have a bunch of properties that you want that are akin to struct to what we currently have in proc self status, then one sort of more advanced option, which would be a bit more work, is to come up with a StatX-like protocol. Some people hate it, some people like it. A StatX-like protocol. So first of all, you start with an extensible struct. This is something I would easily explained. It's just a way to keep the struct extensible if you want to add new fields later on, which happens all of the time. That even works with ioctls, because ioctls implicitly encode the size of the struct that they are passed. So if the struct size changes, for example, then the value, I think the value of the ioctl command changes, and then your switch statement won't hit anymore. But we have macros to like get the size out, and then really just switch on the actual ioctl command,
So
and then the size can change. So for example, and then you could, for example, say like how StatX works. It's like these are the basic fields that I always fill in. I don't know, the PID and whatever. And then I could, for example, I'm interested in also getting the credentials. So I raise a flag in the request in the struct and say I also want you to give me the cred. So the kernel doesn't do any unnecessary work and gives you information. So if you have a bunch of stuff that you really want and you think is core to have, then that might be one possibility. So you only do one system call, and it gives you the set of information that you want. It's like a static specific to PIDFD in a way, what I'm saying.
That sounds reasonable. Okay. Any other comments on this back there, please? Thank you.
Just wanted to add that when you're obtaining a struct you create with all these credentials, they could be not mappable to your namespace, so should be prepared for that.
Okay, I think in the implementation you're actually writing this and then doing the copy to user thingy. I think.
I mean, like UID could be not mapped to your namespace, and that kind of stuff.
Yeah. There is a resolve thingy, I don't remember, but it does kind of work with namespaces too. Sorry, please, Paul, go ahead.
Just since we're going to be going through the process of creating a new API, it'd be nice, in addition to the traditional, discretionary stuff that you get through UCred, it'd be nice if we also added in the LSM attributes too. Right. Yeah. So that way we don't have to have yet another mechanism.
Yeah, makes sense.
Okay, so one thing I want to say is that obviously we've long passed this particular bridge, but one of the things that obviously it's like all this stuff that you could have done like with the old PIDFD thing, which was like because it's a proc entry you could get stuff underneath it. I guess we obviously can't go to that with the new quote unquote new design. It'd be nice though if we could just like look at all the stuff that's in proc and then see if we can come up with a design that would let us just map all of that stuff, whether it's a statics design or whatever. Just because like otherwise we're going to keep adding more and more ioctls for like each random thing that was in proc thing. Yeah.
For ioctls, it's probably not that bad, but there's always kind of a trade-off. So we added a new set of I added a new set of ioctls in the 610 cycle where you can get the namespaces from a PIDFD. So it gives you basically it translates a PIDFD into a namespace file descriptor. You don't have to go through procfs, and that has a bunch of use cases. And for example, there I added individual ioctls for each namespace, but you could easily see someone being like, this is annoying, I don't want to do 7 ioctls, like I want one ioctl that gives me all of the set of the namespaces. So, there's always a trade-off. And I think that since this sort of goes in the direction you mirror parts of what happens in proc self-status, you can already see there will be probably more information coming that people want. And then it probably makes sense to like pack it all into one struct, I don't know.
Okay. Sounds sensible. I think there's a question back there. Oh, Jesus. Give a hand. Incoming.
Okay. Now, after the bruise fades, are you sure that the usual race is due to the PID? I like the PID-FD to PID ioctl or PID-FD to PID mechanism of some sort, but are you sure there are races due to there are PID races in that case? I thought if the PID-FD was open, the PID could not be recycled, so the races can't happen.
No, this is not about races. This is about not needing proc and not needing to parse.
Oh yeah, that's good as well. You just mentioned subject to usual races due to PID. I'm pretty sure it's not.
That's probably a stupid thing I wrote there. Right. Sure. Any other comment? Whoa, coming. Thank you. Okay, next one. So these were the easy ones. And then if this actually switched. cgroups. So this is 2 parts. The first one is, again, easy. I want to know which cgroup a PIDFD is part of. Again, ioctl gives you back the cgroup ID. Easy. The hard part. How the heck do we integrate PIDFDs and cgroups? Because right now, this is the only part in systemd we have that we still have to translate to PID and then use PIDs. Because cgroups, they work on PIDs, and there's in the cgroup node, there's the processes, procs, that is just a list of PIDs. So how on earth do we integrate these two things without having to do this translation? And I have no clue whatsoever. I wish Tijun was here. Unfortunately, I told you had to leave. So for example, you added this PID FDFS, where you show to change from unknown type to an actual type there, and we can list PIDFDs in a directory. Can we do something like that under a C group node, for example? I don't know. For example, I have a C group node, a file path there. I want to know which processes are in there. Can I get the file descriptors instead of the PIDs, for example? That's one thing we do.
But that would be a C group thing. That's something you would have to do on C group FS probably. Yeah. So you have a C group FD, and then you do. Essentially, it's read the semantics or read their semantics, but you have to implement it through an ioctl in a way, and you have to do it.
Okay.
I mean, this is not difficult for cGroupFS, I think. So because I did something similar for mount namespaces. So when you create a mount namespace, each mount namespace gets a unique sequence number, and then you basically a 64-bit sequence number, so they don't get recycled in the near future. And so you can basically have an RB3 where you can iterate either backwards or forwards or whatever, and then list of all of the entries in there. And maybe you can have a similar concept for C group FD. So basically, you need a reliable way. If you have a C group with like 1 million processes in there, I don't know if this is realistic, but I would say at least 100,000 is probably something that is possible. Then having it done in a single copy from copy to user is probably not the right API. Mm-hmm. You want some way to iterate through this, but then you need a reliable way to do this. And you can either do it the read way, where you have like a handle that keeps state in the kernel somehow, or you make the object somehow uniquely representable. But anyway, it's a C group FS problem, not a PID problem.
I think the enumeration of the process in a C group, like with the current APIs, we can implement this race freely, right? Like because we can get the PID out of it, and then after we created a PIDFD from the PID, we verify that it's actually still in the C group. So there is no race. Hence, for me, that's not the pressing thing. What is the pressing thing, however, for me, is adding a process via its PIDFD to a C group, because we cannot do that. We have to turn it into a PID, and the kernel cannot do this verification for us, right? Like because we simply cannot give the kernel PIDFD. So for the integration of PIDFDs and C groups, that's kind of what I would really like to focus on, because that's actually a major gap. That's actually a major gap in the API. And before we think about enumeration, we really should think about that.
No, I mean, that enumeration was just an example of the first thing that came to mind. I know there's more, and you're absolutely right. That is more important. I think Mikhail has a question there.
So I think the second example was better, because I was wondering whether you need the enumeration to be like race-free, because still you operate on the C group, so you should like operate with the whole group and not getting one individual PIDs.
Again, it was just the first obvious example that I could think of, but the point of this is how to do the whole integration. How do we
manipulating individual.
But the second example is of course.
That's better, I think.
Yes.
Could be changed, I think.
Yeah. So any incoming? So any idea how to do that then? Can we, or do we need or do we need for that?
Currently how it works in cGroupFS, and please correct me, is like you do a regular write, right? Mm-hmm. And you just write a number in there. Yeah. And you have two ways to go. Either you add some sort of, you make it so that cGroupFS internally parses some sort of prefix, I don't know, PIDFD : and then the actual number, which is kind of ugly, or you do it via an ioctl. But I mean, otherwise you need some way to differentiate between a PID and
so open the cGroupFS thingy and then do an ioctl.
But doing it through an ioctl is probably fine, I would say. I mean,
sounds reasonable. Any thoughts on having an ioctl for this? We have 1 minute left. Then it's ioctls all the way down, I guess. Sorry.
Netlink interface as well, if you want to complicate
What,
things.
sorry?
Netlink.
Oh, Netlink.
Yes.
It's an option, I guess. I note for the record that Lennart is not happy with Netlink option. Okay, but thank you. It's a fair point. Any other comments? We have less than a minute. Going once. All right. Well, thank you very much. Next talk in 5 minutes. Yes. Oh, you are up. I'll switch you once we are 1 minute. Okay. Oh yes. No. Actually, yes. I'll find the.
One reason to like the whole I opted to get the pin out of a pin FD is because back in, I think Christian was saying that he was before he burned out on pin FDs, he was working on things like kill by pin FD.
Yeah.
If you go get a pin and you're in the root namespace, which maybe you're thinking of doing this sort of thing with blocking tools in the car, you don't need any of that.
Yeah.
You don't need to do all this legacy stuff via pin FD because you just hold the pin FD open, get the pin, and you can do signal via pin FD.
Yeah.
P-trace via because I'm actually doing both of those.
All right.
Okay. Doing it in the race, I used to have this weight FD thing I stole for Red Hat.
Yeah.
And in the end, it turned out it wasn't necessary as long as you relied on the semantics and other horrific stuff. Because pin recycling and signaling it's all colliding in nightmarish ways. With pin FDs and stopping recycling, you can actually do this in a safe fashion that doesn't drive you mad. Anything that requires you to use POSIX timers and continuous hammering of signals racing is bad.
Oh my God, the code in POSIX was oh my God. But yes, I think your quotas of this, would be nice.
Parsing prop, but it's
Yeah.
disgusting. Much rather use it. Yes. This way, in every 10 years, I might be able to use it.
Eventually, better late than never, right? Yes. Yeah, thank you. Sorry, 1 second. I need to prepare for the next thingy. Share your screen. Chrome tab. This one. Hey. Excellent. Okay, he's ready. Sorry.
Scroll the size. Ah, you know what they could do? They could make it.
What the fuck did the camera just do? Still doing that. What the fuck?
Someone's controlling it.
Somebody hacked in. Where is the Mossad? It's gonna explode any minute now.
Yeah. The way like so what I read now is so I think this I don't know. I mean, problem is, I guess what it is.
How can I
Yeah. Action performance. Not all this stuff important. Yeah, there is yes, exactly. So that's why I think
So, I think to recall what we do.
It's trying to free itself.
What we need is to
we turn around this way. Do you think it kind of like 360 degrees?
Like, we have the cables interface.
Hello, it would just figure out, maybe it's an AI.
Yeah.
But I think it's a hacker in there.
One is to translate that PAD in our name.
So that works. So you need to get a you need to call PFD namespace. And then you use that to pass the PID, and then it will translate it to your bit namespace.
Okay, so I'm getting feed of the trace.
Yes.
I'm getting PDFD.
Yes.
Then I can get namespace.
Yes.
And then for it I can call IO call.
And then this new bunch of outputs come out.
Okay.
Yeah.
So that will
Forth and back end. So my idea is to generate my goal for the future videos.
Amir just wrote that he can hear us making Mossad jokes. Well, apparently he's on the other side. Hello, Amir.
1 minute warning.
Yeah, that means that I don't want to do it for more APIs than the transaction. Is the magnification thing? Did I say notify? Or is that not done yet? Did you make more suggestions?
Yeah, the camera just did it.
All right, for the next talk, we have Leonard again.
So this isn't really precisely talk either. I don't even have slides this time, and I have this website here. So this talk or this session is supposed to be two things. Like, first of all, I would like to make everyone aware that this page here exists. And after everybody's aware of this, I'd like to maybe discuss a couple of the things listed here in a little bit more detail. So, yeah, the first thing, yeah, we have this website. It's has been created like a couple of years ago, I guess, by people who do like basic user space operating system design, like systemd and similar projects.
Sorry, Leonard, link is in the chat for people who want to get this later.
Yeah, the link is somewhere in the chat. I don't see that though.
Over there.
Oh, there, yeah, over there. So, so it's all by low-level user space people who, and it's generally focused on core kernel features, like not driver stuff or something, but core kernel features. And it's basically a wish list of all the things we would like eventually the kernel to provide to us. It's mostly about missing functionality to close a couple of gaps to make the APIs that we currently have really well work well for us. So actually, a couple of the things that were talked about in this MC were already on there, like, for example, the C group related PIDFD stuff that we just heard about.
The rootfs making a proper rootfs mount. Making a proper rootfs mount I put on there as well, like a long time ago.
And like if we scroll, like at the top, it's all the items that we would still like to have implemented. And if you scroll, ooh, why is it zooming?
Does it work?
No. It zoomed. Anyway, so if you scroll down, it actually has a list of the things that were actually already implemented, thankfully for us. I think many of these things are actually not that hard to implement. So for, I don't know, people who actually want to become new kernel hackers, they're probably, might even be, a couple of them are relatively easy to implement and might get you started. How is scrolling here?
It's working.
Mia is in the chat. He can look at all of the notify and notify things.
So as you see, there are quite a few of them. And so here, this is the territory basically. This is the territory basically where we already got what we wanted, and we usually put the hash, the commit hash there that actually addressed this for us. All of these things in the list basically also come with a use case, which I guess is the important part, so that you actually know why we want this. We make suggestions sometimes how this should be implemented, but of course this is just suggestions. Whoever implements it, of course, gets to decide how to actually do this. Yeah, it would be great for like kernel developers who want to do favors to us user space people to look at this from time to time. We'd be very thankful for anything that is removed from that list. Anyone has any questions at this point? Because also, by the way, if you want your own shit to be added there, there's a GitHub like collaborate and GitHub thing. If you click on that, you can send us a PR. It's just a markdown file ultimately. If your feature request touches something that is not core kernel stuff, it's probably not the right place. But if you want something, I don't know, in the file system, APIs and things like that, then this is certainly the right place, I think. Yeah, like the pivot root stuff, for example, is also listed here that we talked about earlier. So if nobody has a question,
that's something else, though.
At this time, I would go to the top. Where the fuck is the page up? You actually have to. Okay, because
I should also point out there are some really bad ideas on there. Like ideas like you stand in the shower and you're like, this is a really smart idea, and then you make a pull request and you realize it wasn't a good idea.
But you still merged it.
Yes. I mean, for example, there's like there's one item about extending OpenTree. So one of the problems that we have for systemd is that we have a feature that is called ID map mounts, where you can change the ownerships of all files and directories beneath a certain mount point, and we need a way to update this, to update the ownership or change it. And that's sort of tricky because, like, first of all, we don't want any performance regressions, and second of all, I don't want to mess around with like doing RCU protection for additional properties on mounts. So we need a way to change this, and I have multiple ideas, and like this is one of the worst ideas that I ever had that I put on there. Out of the long list ideas that I had, so it's also at the beginning, like, you know, it's just not all items are like read through it and do it.
Yeah, if nobody has anything else to say at this point, I would just probably go through the list a little bit. The first item here is actually, this would be incredibly useful. Just that when you generically mount some file system, that you can specify a sub-path, if you so will, on the mount options, so that the stuff that you actually get mounted is already somewhere below the tree of the file system you're mounting. This would have uses, for example, in systemd homd, for example, because we set up a mount. Like we have a file system for each user, and we actually want to mount a subdirectory of it to /home username eventually. Right now, we can work around this by doing file system namespaces, but this is really involved, right? Like, because we need to create a file system namespace, then mount the file system into it, then do a bind mount of only the relevant part outside of the mount namespace thing again, and then kill the mount namespace. So you need to fork, you need to mount namespaces. I don't know. It's doable, but it's messy, and we'd rather not do this. And it's in particular not easy to do it properly because you don't want to generate mount events on the outer side that aren't there. Interestingly, Btrfs has something like that because you can specify subvol equals on the mount options, and you can specify. But it's a special case.
It's file system specific. That's sort of the thing. So you have to call into the file system to actually do this for Btrfs. But I have a patch series that allows you to do this now that I just didn't get around to sending, and it's essentially relies on OpenTree, and OpenTree creates a detached mount that hasn't been attached anywhere in the file system, allows you to create a detached mount that hasn't been attached anywhere in the file system. So it's a private FD that you have, but one of the restrictions that you have is you can't create another detached mount from a detached mount. Permission checking is probably one of the biggest concerns there, but I figured out a way of how to do this safely, and so that shouldn't be that far. It basically involves you would create an FS mount file descriptor. You would mount your ext4, XFS, whatever you have. You have an anonymous file descriptor that refers to an undetached mount namespace or mount tree, and then you can call OpenTree clone again, and then look up the subpath that you actually want to open, and then you discard the original FS mount file descriptor, and then you have what you want. The difference between the Btrfs case and the difference with the Btrfs case is that for Btrfs makes it appear like that is actually the root of the file system. So it switches the root entry of the file system out. So it just looks as slash when it's actually slash subdir. And with that mechanism, we don't pretend like this is your new real root. You would still see, okay, this is slash subdir. Like similar you would with a bind mount, but I think that's acceptable, and it would be kind of misleading to make that pretend like this is the actual root of your file system. This, I think, probably some legacy semantics that Btrfs has.
If you're going to do that, let's make sure that we unify the the mount option name. Because if you don't want different names across file systems, it's already going to be bad enough with Btrfs. Btrfs is different already, so.
This is purely VFS based. There is no mount option. Nothing. There would be no mount option ideally.
Anyone else has anything to say about this one? Otherwise, we just take another one, which is one thing that I really would like to have is having, we have SCM peer creds to get for, like, if somebody sends us a AF Unix message, that we can get the ucred stuff, and there's also for SL Linux and also for the PIDFD of the peer. It would be really, really useful if we could also get the C group ID this way, because the C group, in a way, identifies the app in this world today, because all the apps generally get their own C groups, and they have a nice name, like a string, and there's a really nice hierarchy that basically, constructs the whole system. So if we had this, we could use this for many things. We currently can kind of work around it, but it's awful because we now get the PIDFD, and from the PIDFD we can derive the C group ID. But this is ugly for various reasons, because once the process died, I think that we can't figure out the C group anymore either. And in particular for logging stuff, there's lots of stuff that just logs and exits. So that basically for that kind of stuff, we never can figure out their C group ID this way. So I would really like if we could add this. I think it would be relatively simple to add, and wouldn't even leak any information, because C group ID is kind of an opaque thing. And if you want to translate that to a path, which you can do, you need privileges via name to handle at. Sorry, handle to name, like the other one.
Name to handle at and open by handle at.
Open by handle at. But I think it should be really simple and would be really useful, and it would also make the policy kit thing that we heard about in the previous thing a lot safer, because at that point we could make security decisions not on the the C group membership of the peer process at the moment we check it, but instead of the moment where it actually made the bus request, which I think is a major distinction, because processes can migrate between C groups, at least in theory. Anyway, that would be awesome. I think there's somebody who already started working on this, like the
Alexander.
I would really love this. I think it would bring us major benefits, because suddenly we could turn C groups into this primary concept for identifying containers, VMs, apps, and everything else, and make correct trust decisions.
I don't have that exit path in mind right now. When you, what do you mean? When a process exits has been reaped, so it's a zombie.
Yeah.
Then you can't figure out the C group anymore.
Yeah.
Probably because in the exit path it gets rid of the C group. Okay. But then you...
But again, I don't want it even from the PIDFD. I want it from the message, right? Like, because there are two issues that I have right now. One of the issues is that...
But what if, my point is, what if you receive a message from a process that has already exited?
I want the C group ID at the moment that it sends a message. I don't care about exiting or not. I want them,
the process
for a security decision.
Oh, this is cooperative. The process sends you a message.
The process sends me a message, and then I want to derive from that message what was the identity of that process at that very moment. Because we get that for ucred and things like that, for the SL Linux label.
You stash it on the sender side,
Yeah.
It's in the control message, right?
Yeah, it's in the control message.
Yeah, I mean, sorry.
It's in the control message, so if the process exits, you still have the information. So.
Oh, and one brief thing to mention: this was proposed before, but at this before time, there were no concept of C group IDs. There were just C group paths, and there was some opposition on LKML by certain people that this would leak too much information to the other side about the C group hierarchy. But this issue kind of went away because we don't have to deal with paths anymore. We can now deal with C group IDs, and they do not leak that kind of information. Nothing about the hierarchy and no labeling and nothing. So, and there, as mentioned, there's for translating that into paths, there's still privileges required. If no one has a comment on this, I would just go for the next one. Now that,
One thing, I think this has been discussed as well already on LKML. Like one of the use cases of OTemp file is like this thing that you can robustly, without having to fear for leaving around temporary files when the system crashes, that you can install files in some directory. What's missing though, and what I think is actually much more important, is then that we can use this for updating files, right? Because right now you cannot, because there is no replace behavior when you actually link it into a directory. I find this really limiting. In systemd we have code that tries to work around this, which basically just creates a randomly named entry for a moment and then renames that to the final destination, because renaming an existing entry into another one that does exist with replacement, but it just shortens the window of risk. It doesn't remove it, and I'd really like to see this addressed somehow. I really don't care what the API looks like in the end, if that's a thing added to link add or a thing added to rename add or something like this. I just want it.
I would also, one trick that I mentioned before is now with the new mount API, what you can do if you need private temp files, you can create a private detached mount that you keep that only systemd has access to, and then you create all your temporary files in there. You know what I mean?
Well, but I mean, I want to create files in Etsy, for example, right? Like in Etsy, I don't know what that is, ext4, right?
Yeah.
I think we discussed this at LSF this year, right? I mean, Omar I think the idea was to use rename at too, right? Yeah, and with a new flag. So I think this is. I thought it was. I mean, it's been a while. I have to go back and look at the LLWN article, but I think there was a plan. So
okay, that's good.
And I think Omar, I don't know if Omar is actually working on it, but I think he had a plan to do it.
But yeah, it would be so awesome, because in systemd it's one of the most common things we do. Anyone else, anything about this? Otherwise I would just jump to the next one, which is the ability to open regular files only, right? Like,
That sounds easy.
It does sound easy, right? Like, so in Linux, when you open something, right, like you can specify this flag O directory, and if you do that, then you get an error back if it's not actually in directory. And it's a great feature. I know why it was added, but I would like to have this for regular files, because I think for regular files it matters even more, right? Like, so why do we want this? Because on Unix we have all these kinds of inodes, and sometimes some of them behave very weirdly. Like, for example, dev nodes. Like if you have open a device node, then it might block on you, right?
Wouldn't it make more sense? Wouldn't it make more sense, instead of having an O flag, to extend opener2 and have like basically an is format argument in the struct? Because O flags is always going to be contentious, like having an O flag. Yes, it will apply to open and opener2 and openet and whatever, but at the same time, like somebody will say, oh, what about device node or whatever? But with openet2, we can just stuff it like in the struct and have like, okay, this is the restriction that you want to have, and fine.
Yeah. So generally, I would say again, I don't really care how the API looks like. This is a very simple way to express what I mean, I think. In systemd, again, by the way, we have the code like this, where we first open the inode with opath, so that it's not actually open, verify the type, and then convert it into a proper file, FD via proc self-FD. But of course, it's really involved. And I mean, in my theory, at least, in libraries like yours, for example, this should actually be the way how you always open files, right? Yeah. But this is always basically, this means that you have at least 3 system calls, where you traditionally have 1, and that is kind of annoying to like, because I mean, it's hard enough to use the Linux file system APIs properly, like without races and things like that. Kind of pushing everybody to, like, trying to convince them, oh, please make it all 3 system calls instead of 1 is really hard. Yeah. So yeah.
Yeah, sorry, I was going to say, yeah, we could extend openet to, I mean, the one thing that I'm wondering, because then you could, if you would make it that it would take the format, then you would say, well, it's just the optimization of, like, you reduce 3 syscalls to 1 for this particular type of check. The other question is, like, presumably there's going to be, I mean, is there any other things people would want to check against? I mean, like, if you definitely want to open a particular device node, you probably want to check that it has the right major minor number or whatever, hypothetically, and stuff like that. But, like, I don't know.
I personally don't care about anything else, right? I only care about the regular files thing, as far as I know. I wouldn't, like, device, like, if you open a device, that's a really special case, and you go usually by pass, and that's even fine, right?
And device nodes generally don't exist outside of /dev, and we should enforce that by security policy, by the way. So I'm really not so concerned about that so much. I'm really concerned about regular files, because then you can trick arbitrary applications with this. And
it's always like sorry. There's also resolve cached as well to deal with that.
It's really fishy when you have a block device node on your XFS or ext4 file system. I mean, probably there are some use cases, but in my opinion, yeah, that's something we should have probably not allowed.
Was there a comment over there? Some question I thought I heard. No, sorry.
The other thing is that you also need you also want to use resolve cached, because it's not just the type of the inode, it's also like if it's on a detached NFS mount, you want to make sure that it doesn't. I mean, the problem with this resolve cache doesn't help you with that, because that will block stuff that is like on a local file system but is not yet in the page cache. Maybe we need to have. I suggested this when I did OpenAT 2, is that we maybe would want to have some kind of thing that says don't open. If it's a remote file system or something, like if it's something where like you could in theory block indefinitely on the open, because like if you have a stale NFS mount and you give me that file, it doesn't matter what file type it is, it'll still block.
You could already stumble upon that problem during path lookup itself.
Right, so it would need to be a resolve. It would need to be a resolve flag. So it would need to leave so it'd be like resolve cached, but rather than just being for cache stuff, it would be resolve no remote or resolve no whatever. Yeah, sorry.
I don't think that the idea of like limiting to regular files firstly solves your issues, because you can get all the kind of issues if you have a weird file system, as well, already mentioned NFS. And secondly, it will be limiting because like people often try to provide, for example, as I mentioned, FIFOs and stuff just to get to work around like existing limitations, to like pipe like some information into programs that will otherwise accept regular files, and it like sounds kind of limiting for these use cases, while not serving while not solving the issues of being blocked on something.
So regular files and directories and symlinks are special because you can create them. They're actually openable, and you can create them unprivileged, right? That means this is different from device nodes, which are privileged to create. This is different from sockets, because you cannot open them, right? So, or FIFOs are also unprivileged and things like that. So I think those are the ones that you need to be careful about, right? Like, because people can fuck with you by creating a symlink in some shared directory in /temp or something like this, and give you the wrong idea, right? So I don't know, like I'm not too concerned if the system created a device node in /dev called foobar. That's fine with me if somebody points me to this. What I'm really concerned about is that if I open a path somewhere else and through some trickery it ends up there, right? Anyway.
So so first of all, I want to address your thing about, doing additional system calls is annoying, and that is let's not confuse system calls with APIs, because there's a lot of functionality that can implement it in libc. And doesn't have to have, a kernel system call which increases the kernel attack surface, and so on and so on and so forth. So that's one thing, and the other thing is we have to be a bit careful about creating system policy that ends up being hard-coded into applications. And in particular, the mounting remote file systems thing that someone mentioned, that is actually a system policy. When the file system is mounted, the administrator of the system decides whether or not it should be a soft or a hard remote mount. A soft remote mount will time out and return an error. A hard mount is there specifically to not do that. Oh.
Right. Okay, but that's if you're running on like the host system. If you're inside a container, then you can you can create a fuse mount that always blocks and stuff like that, right? Like, I mean.
So let's do one last thing or something.
Sorry.
A question over there. Someone hasn't spoken yet.
One thing that hasn't been mentioned is the no-dev mount option. So if your system has no-dev on all the mounts, except for /dev, do you even have this problem at all?
Well, you know what I'm concerned about is symlinks and stuff, right? So so the concern about the symlinks, right? Like so that you have a symlink in /home, and it points to /dev, and then you're bad. So if it would be very, very easy if we would just say open regular, and then it doesn't work.
There is no follow.
Sorry?
There's no follow.
That is true. I mean, yeah. I mean, the two things that Linux currently offers you is to say it must be a directory and to say it must not be a symlink. But that doesn't really help you because it only is about the final element of the pass, not of the middle element of the pass, and that makes it pretty useless.
I mean, you can do result this.
Yeah, I still think that
it's impossibly hard,
especially
to use
for the
Linux APIs properly.
The no regular stuff I don't find very problematic. This is pretty useful, and we have O directory, and we have all kinds of like don't resolve this nonsense in all kinds of APIs. We have like don't trigger auto mounts, don't call into the server. For NFS file systems, so that you don't get to hang on statics. Like this is already happening because like user space keeps crapping itself all over the place.
So, do we have any time at all?
We have 5 minutes left, but we have the room until half 1.
Sure, let's at least do.
Now. So up to you.
I can keep on talking.
You can keep on talking. I know you can. That's the problem. But yeah, according to schedule, we are in 5 minutes down.
Okay, then I'm talking and you don't listen. Okay. Yeah. I mean, as long as people are interested, I can just keep on talking, right? So one other thing that might be interesting to mention is, you know, what's really weird right now in Linux is the fact that if you send a file descriptor over an AF Unix socket, is that the receiving side cannot turn that off. Right, like this is an implicitly always turned on thing that is impossible to get out of, and it has really weird semantics because file descriptors are going to basically installed in your process table, if you want it or not, if you make the mistake of using rec message on an AF Unix socket, if somebody sends you this. I think this is a security problem in many ways, right? Because file descriptors, not only does it like allow some remote side to install file descriptors in your process, but also if you actually do handle this, which we try to do in systemd, for example, then you have to close them, but close is synchronous on Linux, right? Like, so there's very easy ways to create a file descriptor unprivileged that takes 15 seconds or something to close, like by using a TCP socket that you bind to some port and then you make one connection and then you close it because of the SO lingersing. And it really sucks, and it creates a lot of vulnerabilities. Like, for example, in dbus, if you send across dbus and such a file descriptor, and the receiving side doesn't want it, it will just close call, and bam, dbus hangs for everybody, right? So this DOS really sucks, and it has been there since about every time. A lot of people know about it, but nobody does something about it. So I think this specific problem, of course, has two fixes, right? Like, first of all, we should have an asynchronous close where this doesn't happen. But secondly, I think the mistake is already that we allowed this to happen in the first place, that some remote site without any further authentication can install file descriptors of their choice into your file descriptor tables. So all I'm asking for is, I mean, we cannot just turn this off by default anymore because then everything will break. But at least we should have a way how we can turn it off explicitly. We have something similar for this, like for the peer cred stuff that needs to be turned on. It kind of sucks that we have no API and a similar set sock-up for that stuff to turn on.
Shouldn't it be possible to have like a receive option where you say like discard any file descriptors that I received and I don't know, offload them to
That sounds fine
K-thread.
to me too. But you know, ideally, I would like to have something where I can give some other process a file descriptor where I don't have to expect the other process to do anything anymore. So I'd really like a property on the file descriptor so that the file descriptor can basically be considered, never going to install FDs on anyone. From that point on,
That
right?
would
Like
have to
because in
be
Unix
not-
you pass file descriptors through shell pipelines and whatnot, right?
It can't be a property of the FD. It must be a property of the file, if at all, I think.
Sure, that's what I mean. Yeah, of the file. Yeah. So basically, it
That's
should be
weird.
stored at the same. Yeah. Like at the same place, basically where the at the same place where the peer creds thing is stored, right? Like because you can turn that off on a socket, and I want to be able to turn it off on a socket. That this stuff happens.
Do you only want to turn it off on a socket?
Yeah, I mean it's a socket thing.
The logic being then, if someone sends a message with a file to someone else, then we would just discard it.
Yeah, which is problematic enough because again we cannot.
You want to steal one of the
asynchronous-
F mode flags that I freed up with hard work.
Well, and then, but that doesn't struct file. This should be in the socket thingy.
Set socket.
Yeah.
Yeah, that's what
Yeah.
Because that's again, that's where the peer cred stuff is. This should be the same place. And I think it's kind of a mission that after all
I
those years of
understand.
Linux,
You basically want the socket to say,
Yeah.
I don't want to receive
Yeah,
any file
ever.
descriptors. Ah, okay, I get it.
but it's still problematic,
I thought
right?
you
Like
wanted to
because
say- I thought you wanted to
if
say
the
the file
receiving
is
side,
supposed to be sent, yeah.
I mean, it should not be discarded on receive. It should probably be don't even allow it to be sent, because otherwise, because closing is synchronous, you still have the synchronicity problem, right? Because I mean, if the receiving side
So
then
it's basically
automatically
like
already in kernel
socket
discards
open,
it.
but no SCM rights.
Yeah, SCM CRUD. Yeah, or
SCM.
SCM rights. Yeah. Anyway.
Yeah. Would you want the sender to error out, or would you want it to be that when it sends, it's as if the file descriptors weren't even in the message? Like which would make more sense?
I think it should be an error. I don't know. Like it should
Okay.
be something that people actually can see.
So given we have done for another half hour, I have very sneakily extended your session until the end of the half hour. If you get bored to hear him blabber, please feel free to leave. But please do go on.
I think, I mean, we have so many things on this list. I'm not gonna, we're not gonna go through all of them anyway. I invite everybody here. This is the URL again. Please have a look. There's lots of interesting stuff there. I think many of these things should be common sense. Like, for example, that this, in my opinion, should be common sense that this should be prohibited. Yeah, again, I think actually implementing this is probably not the hardest thing in the world because there is prior art with the peer creds thing. But who knows what kind of implications this has. Yeah.
So, do you have the situation where you initially don't want to receive file descriptors, but then you authenticate the peer and you want to turn it on?
Yes, absolutely. Like in DBus, for example, DBus has like these two protocols. Like the first one is the authentication protocol. You do not want to allow FDs there because you don't know anything about the peer and it's an evil peer potentially. But once the authentication took place and you know everything's in order, and you did like it even has a handshake protocol that figures out if FD passing shall be enabled. After all that passed, yeah, you want to enable that.
So it needs to be a toggle.
Yeah. I don't know. Should we talk about another one, or should we just finish?
No, I mean, go on. If people are here, they want to hear more. So.
Okay. Since we're talking about security problems, there's another one. Read-only propagation of mounts. So.
That's not happening.
So well, let me first, like, I don't know, maybe we have other ideas to address this problem. So the thing is, like, in system we have since quite a while, we added the support for sandboxing services, and this is implemented via mount namespacing, right? Like, so that every service as it starts gets its own mount namespace, and then we basically inherit the host mount namespace, turn off propagation on pretty much everything, like propagation from the sandbox to the host, but the other direction we leave on, and then we replace certain things or change the flags on certain things to read only. This sounds like wonderful sandboxing technology and would have no holes, but it turns out it very, very much has holes because Yeah, I mean the model here is like not disassociate from the outside world too much, right? And that's why we leave on the propagation from the host into the sandbox, because yeah, these services shall not notice that they're actually sandboxed. But this all falls flat if people actually mount additional stuff. I don't know, some USB stick that they mount to run media or something like this, because these things then get propagated into the sandbox, which isn't necessarily the problem, but it gets propagated in the sandbox without the read-only flag on that everything else has, right? So this is a major security hole or like omission in our model that cannot be reflected. What I'd like to see to fix this would be very simple, right? Like that if propagation takes place, optionally, the read-only flag, and probably the other flags too, the SUID one, NoDev one, should implicitly be added on the propagated version, so that you can never propagate a wide open thing into a really closed thing and nobody notices, right? I think, in retrospect, now that we have landlocked...
In retrospect, mount propagation was a mistake, I agree.
So in retrospect, now that we have landlock, I think the original problem set would have better been solved with landlock, because landlock does not create a new world. I mean, there are limitations to this, because like, for example, we have private TMP, which gives you your own /TMP that is disconnected from everybody else's. So you could not implement that with landlock. So this problem would still exist to some degree. But I think at least for the read-only making of stuff, landlock is probably the better solution, right? Like, because it does not rearrange things, because it doesn't affect the hierarchy of things and the settings of things. All it does is just prohibits access, and this is kind of what the read-only settings that systemd sandboxing are, after all, is about. So I'm kind of tempted to maybe, because our knobs are relatively generically named, we can probably make it so that we actually do both things, right? Like we do the mount namespacing because we always had to and because we need to remain compatible, but that we also start to install a landlock policy then that
I think
at a second level enforces
if you
this.
can solve this problem, so I have I mean, I have something against the implementation, but then the mount propagation as it is already complex, and I really hate the idea of adding some magic marker. Probably would have to be some marker on a mount namespace, I guess, where you say if you have incoming mounts from mount propagation, then mark them as read-only or mark them as NoDev and so on. And that adds ever more magic into mount propagation as it is. And it's really, I think the complexity level that we reach there is already hard enough with MS shared, MS slave, MS shared and slave, and peer group IDs and whatever we have. Like the mount propagation algorithm is horrifying to look at. So I'm generally against extending it. It sounds like some magic. Okay, we have some special mount namespace, which is probably the initial mount namespace that has these mounts read-write, but then we propagate into some lesser privileged mount namespace that somehow ORs into magic flags.
So my implementation idea, not being a kernel guy, was the assumption that we could attach to any mount a mask of stuff that is implicitly applied to all bind mounts added below that mount. So it would not be about namespaces, not at all. It would really just be a mask that you can specify on a mount that is applied to whatever is added below. I think that would be relatively simple.
Yeah, we talked about the mask idea. That's kind of maybe if you only had read-only, that would somehow work, because then there is no complex calculating of what mount flags what mount flags you actually need. If you add MS NoDev in there and MS NoExec and so on, things could become a bit more hairy. I also don't know if this actually. So the idea being, you mount on top of a mount, and that mount that you created, like how you need to mark the mount. How do you mark the mount as like having an implicit mask?
Like you couldn't just set it with Serata? Like you would it would have like a special, like another, like rather than setting the attributes of the mount, you would have like a different attribute, which is like, oh, this is the attribute of mask.
Yeah.
Well, that's what I would assume would be like the
that's what
simplest
I
way
had
of
in
doing it.
And then you mount on top of a target mount, and you start propagating, and then that propagates these mount flags to all of the clones that it creates for the other namespaces. It's so disgusting.
So
the attribute would be set on inside the target namespace, not on the host. So it would be like when they set up the namespace for the service, then they. Well, no. But it's set on the mount. It's set on the mount in the namespace.
Yep.
So like when the propagation. I mean, I'm sure this is horrific, but when the propagation happens and it gets attached to the thing, the mount that's underneath it's getting attached to, that's where the thing would apply.
See, Alexa gets me.
So like.
Underneath the mount you mount on top of.
When you say on top of, do you mean like A/B? So the mount when it's propagated underneath. So when you have like /media, right? Inside the namespace /media would have an attribute set with mount data, which says for any mount that happens underneath this thing, so it's attached as a child of this mount, that it will have this thing automatically applied as a whenever you mount to it. And so when propagation happens, it would also have it applied. Is what he's suggesting, as far as I understand.
It's a weird way to implement. That's a weird way to implement it. Like you could. Okay, so when you create another mount namespace, you create a second mount namespace. That implicitly, what the kernel implicitly does, not implicitly, what the kernel does, like it copies all of the mounts from the originating mount namespace, and then they just magically appear. How do you mark the /media mount?
Like the same way as we turn on we set everything to slave, MS slave, and my assumption would be this at the same time where we set everything to MS slave, we would also set this extra mask that is then further enforced on anything that is propagated under these.
So you need to explicitly.
Yeah. We add recursive, like the user space would do it. It's opt-in.
Yeah.
And any mount that you then propagate on top of this would also inherit the restriction flag, and then if you have no.
So unwinding a bit, I think the landlock idea is actually quite good for this.
It kind of feels weird, right? Like that we have two levels of the same policy.
Sure.
One is using one way, and
but we should use.
I'm
pretty sure.
Mac also prevents you from unmounting. You can use, for example, AppArmor to prevent you from unmounting a mount you would be otherwise able to unmount. For me, this is like mandatory access control territory, not something the VFS should take care about.
Well, so,
we do stuff, for example, of course, when you're you have a read-only mount and you propagate that read-only mount into a mount namespace. That mount namespace now is privileged over that mount. Yeah, you lock the read-only flag to make sure that the mount namespace cannot suddenly turn that into a read-write mount. Totally, yes, because that's a security issue. But this is essentially like you're propagating a read-write mount, and you're propagating it into all of the other namespaces. It's exactly what you do. It's not per se an attack vector or a security issue. And if you want additional mandatory access control.
So the thing is like in systemd we actually have read-only path, and then we have inaccessible path. And what inaccessible path, like the setting does, it actually overmounts a thing either with a empty file or with an empty directory that is immutable.
Could we have a device node or something?
Yeah, it could be a device node, like a zero out one. But so I mean, for these things, landlock isn't an answer, right? Because landlock cannot make file disappear, right? Like one is about visibility, the other one is about access. Right now, the sandboxing via mount namespaces kind of gives us both. But of course, landlock can never cover the visibility thing.
But for example, if you overmount, you need at least a second mount namespace that is not owned by whatever process is in there, so they can't just unmount whatever you.
Sure. I mean, yeah.
Obstructed.
It's not a solution on its own. If the client has privileges, they can undo things. I'm fully aware of this.
I mean, if you propagate it into there, then they become locked and they can't unmount it.
Well, if you use user namespaces.
No, not if you propagate it. If you would need to, if you overmount and then create an unprivileged mount namespace, and then they get copied as a stack and they're glued together, that's...
Yeah, I mean, you need user NS into the mix.
Yeah.
I don't know, but, or drop privileges, that's probably enough. I don't know, let's talk about something else if there's interest. Yeah, I think kind of already mentioned this asynchronous close. Kind of big problem for us. I already mentioned the attack to this. I think IOU ring, like Jens kind of suggested that you can use IOU ring for this. In systemd, it is actually a big problem for us because we maintain per service like this thing we call the FD store, so that the services can send us an FD and we keep it for them, and then they stick around, and then sometimes the service goes down and now we have to close all these files in the FD store, and then we could freeze. So our way around it is we know that threads are relatively cheap on Linux, and we can kill them any time. So what we do is we buy us this asynchronous behavior by wasting threads. So we fork off a little process that the only thing it does is call close. And then it might hang for 15 seconds or longer if this is a weird NFS FD or whatever. It's half a solution, right? Like, because it basically means, you know, what I really don't like about this thing is if we destruct stuff, right, which is like service stop is a destruction, we end up allocating new resources, like a new thread. And there are relatively low limits on things, right, like R limit and proc and things like that. So a destruction process that ends up allocating things from a set of resources that is relatively limited, I really don't like this, right? So the current code path is even that we try to fork something off, and if we can't fork off that thread, we actually fall back to a regular synchronous close. Yeah, Jens says IOU ring can give us that. I don't really know how that's all. Yeah, I don't properly understand why that wouldn't cost us memory instead of threads, which isn't that much better. But I don't know. I think it should be something that we can. It's a security issue to some point, right? I think we really should.
But also a resource issue. I mean, as you said, if you are out of memory and the room killer is killing a service, and then we kill a service and then we start spawning new things and take more memory, that's kind of icky. So yeah, it's not just security, even resources.
Yeah, I mean, ultimately it's a resource issue, but I think it's a security resource issue, like that. And a resource issue that easily turns into a security issue, like a DOS thing at least. I don't know. I think it's not entirely trivial to implement this because on kernel side there's something. Yeah. I don't know. Maybe we can find some solution to this.
Did you get any more details on the IOU ring solution other than use IOU ring?
Jens texted me. Like I talked about this with him at some conference, and he told me lots of things. And I did not quite understand why submitting one of these requests into the IOU ring wouldn't take memory, because that basically means you trade again memory against another resource, but yeah, I'm pretty sure he knows what he's saying.
Yeah, I mean, like, I don't think that's unavoidable, right? Because like, no matter asynchronously, something's going to have to be allocated to like wait around for those resources to be reclaimed, right? And like,
well, from my perspective, I don't really care what happens to the stuff that's behind it. I really care about that the file descriptors are released, right? Like, which are two different things, and I think it should be possible somehow. I don't know.
Well, so like, I'm not saying that.
Or it's also a concept of ownership, right? Like in the world that I live in, people send us file descriptors all the time. It really sucks that I have to pay the waiting time for closing it instead of the actual owner of the file descriptor, right? Like, this is like, to me, the resource ownership is kind of turned around there, because I'm the unlucky one who ended up being the one who actually closed the shit. I have to pay the penalty for it. So I kind of have the suspicion this should be, like, we should be tougher on tracking resources to the owners that created them and kind of make them pay for them. I don't know how that could work for close, but it's like a fundamental issue I see here.
If the original owner of that file could be long gone, and you're the only one holding a reference to that. And the only thing that we can do, if what you mean by asynchronously in the naive sense, would probably you close and it immediately, like mount detach, it immediately returns, and then it's sort of the kernel's problem. But that means essentially we leak it to some K thread or something that potentially potentially blocks forever.
I mean, there would be global queue or something where you have file descriptors that you just try to close and close and close and close.
Right, and that's what I'm saying is like, I think that the IOU ring thing is the solution because like that's what he just described is exactly what will happen. It'll get offloaded to a K thread that's going to sit there forever. But the other thing is like, I understand that you feel like it's annoying that systemd is responsible for this, but like where I see this often is a nspawn client has an OpenFD. And so yes, okay, the client inside is responsible, but like ultimately the whole package is responsible. So like you're being penalized, but like you're also the client. You're the one who has the thing open because you're the container management.
Yeah, I mean, we can just say basically that multi-user systems, everything's fucked anyway, right? And I guess that's true, right? Like if we have nicely sealed systems where we just pass stuff into, but never have two-way communication passing resources around. So yeah, I can agree with that, but still, I think it's something we need to be doing about because the original model of security in Linux is around users, and right now we're not protecting users in this regard. And and I think it's a major way how we're not protecting users against each other.
For sure.
For the most part, most file systems don't block you much when you're closing, right? It's mostly just, well, NFS is the big one, right? Because it wants to do CTO. So we have to flush all the dirty data when closing a file so we can hold on to the attributes right. But most of the time, I wouldn't think this would be a huge problem on most file systems,
I mean, it might even be nice to at least have half a solution. Like, for example, for the TCP thing, I really, I don't know, if it just closes it. Or maybe we can actually the TCP thing, we could just figure out if it's a TCP socket, then turn off lingering, and then close it or something like this, because you can do this. But Jesus, if we now, for every special subsystem that gives us an FD, we'd have to add these hacks that says, oh, please do not wait for whatever the fuck you're doing there, then I don't know.
But then really just have have like a little systemd daemon. No, I'm joking, but you have an IOU ring instance somewhere where you can offload that stuff into. And then you can also, the other advantage is like, or advantage, depends on how you look at it. If you have an asynchronous close, and then you have no way to figure out like what file descriptors, for example, are still hanging around and are still blocking you. So, for example, if you try to mount something again, but for some reason something was fucked, and that there's a file that still pins that file system, you now wouldn't be able to mount it, and you get that annoying busy thingy. But you have no way of figuring out what is actually still keeping that busy because it's hanging in some K thread in the kernel that you have. Not even the kernel probably knows what is in there. So with IOU ring, you have the ability to go and inspect what FDs are still in there, what is still hanging in there.
Do I?
Yeah, I think so.
Yeah. But I mean, isn't it a little bit tougher request telling everybody, oh, keep a IOU ring around where you can insert FDs to close? I don't know.
Why everyone?
No, it's not everyone, it's you. Well, that's fine with me.
So, to resolve this little DNS implementation that we have in systemd, we actually added something that we call the FD graveyard, like the socket graveyard, because we have this problem that if we close too eagerly all the file descriptors, then all the communication that might still come in from a DNS server will result in a packet bag that the port is closed, right? So we already have this little thing that it just keeps FDs around for a while because otherwise the kernel would do shit. I don't know, it would be good, maybe we can have a per subsystem way how we can basically say, this FD I don't care about, and then return all the
like a forced shutdown.
Yeah, and then if subsystems implement this, great. If they don't, then not. I don't know.
So close two with flags.
Yeah, because I have the suspicion that many of these behaviors I really don't care about.
If it's a file system specific problem, like for example with NFS, and you could make an NFS mount option.
Yeah, there already is one. I mean, you could turn off CTO if you really want.
Yeah, but nobody's going to do that.
Nobody's going to do that. And they shouldn't.
It's like a terrible idea, don't do that.
Oh, and then there's unprivileged fuse, by the way, which just blows everything completely up.
Well, the nice thing about that is Joanne's working on timeouts for connections. So hopefully that'll help in that regard, right?
Well, I mean, for my example, there are no connections anymore.
Right. So, like closing the connection on a fuse should be relatively straightforward. Like there's not a lot. I mean, it has to clean up any outstanding requests, but it's not going to be like NFS where it just fucks off forever. Sorry, goes away forever.
Anyway, so I don't think we'll solve this problem here, I guess. But I just, at the very least, I got you all to maybe think about this or something. There's some.
Maybe you could make async close fail on subsystems that don't implement it and then fall back to what you currently have. And over time, subsystems that can do this easily or in a reasonable way can start implementing async close.
So, I mean, I sympathize with that thing, but I have no illusions. Like, this is my problem, and it's very hard to convince all the subsystem maintainers that they should care about my problems. But I don't like this. It's Diva's Demon's problem. It's mine problem. It's basically everybody who accepts FDs in a somewhat generic fashion, not knowing what it is. And I think it's probably you can exploit a lot of other daemons with this because everybody does IPC and uses rec message, and people are not aware of the problem at all. I kind of find it sad that nobody actually spent some security research time into exploiting daemons like this. But I guess nobody cares about local exploits like this anymore anyway. But I don't know, maybe let's talk about another thing before...
5 minutes. 5 minutes.
5 more minutes. Oh, which one?
If we want to be lost in line.
Yeah.
Which one is interesting? Clock monotonic on network timestamps. So there's like the networking timestamps, and they use the real-time clock, and I think it's really weird that they do this. They should really get us the monotonic timestamp instead. Because and in system we use it for so many things, like for example for logging, because we usually just care about the monotonic one, not the real time, because who the fuck cares about calendar time when they look at, I mean, okay, there's NTP that cares, but other than NTP, nobody cares about calendar time. So it's kind of nasty because it would basically mean duplicating all the sock-ops that they have, and they have so many already because they support.
It would only have to be one. Like you wouldn't do it in the microsecond-based one, and you wouldn't necessarily. No, wait. Yeah, is it? Like we have 3 main interfaces, and then we have the versions for 32 and 64-bit time. You would only have to add one thing, and we already have with the SO time stamping. We have the option for device hardware timestamps, so we might be able to fit it in there.
I would love this. Like it's so useful for us because, like, for example, for logging, we now synthesize that on the receiving side, and that basically means when the system is loaded, everything goes to like the timestamps become completely unreliable.
So do you want the timestamps mainly for actual network devices or for the Unix domain sockets?
Like in this case, it's Unix domain sockets.
Because I'm not sure how the hardware timestamps are defined, but if they don't have to be related to actual real time, then we could just pretend that the hardware timestamps for domain sockets are clock monotonic, and we wouldn't have to extend any API. I don't know if this works, but that would be my idea.
I would love that. Like it's really like we use this for many things because, like, you know, when we log, we like the most interesting logs are always early boot logs where we really have no correct clock, and hence we get this information that is really useless, and we'd rather have something else. So everybody agrees this is something we want, and now we just need to find people to actually implement this. We still have a couple of minutes left. Immutable loopback devices. I mean, it's more like a bug, I think. And Christoph actually accepted that this is really stupid. But on Linux, no matter what you do, loopback block devices are not immutable. Even if you ask them to read early, it's really, it took like a couple of days out of my life figuring that out. So if you have a file system that maintains like a dirty flag, you mount it from a loopback device, where the loopback device is read-only and the file system behind it is read-only, it still will write through the change, like the dirty flag and things like this. It's terrible because I don't know. It's incredible, right? Like, because you would assume that if you mount a thing read-only on every layer, then nothing would happen. But yeah, so the only way, like, the kernel file system people now accepted that no recovery is the flag that you have to set to actually get read-only behavior. But it really sucks that you have to give that flag to the file system people instead of that this is enforced on the block layer already. I think Christoph accepted this, that this is an issue that we should fix, and he even looked into fixing it, but apparently something relies on that shit, that it actually ends up on the disk in the end. So, I don't know, it's very annoying.
Any comment on this one thing?
But yeah, and we make use of this because, like, in systemd we have this concept called DDIs, discoverable disk images, that we, like, for security reasons, we want to, like, always have these file systems that we mount and then run everything off. But this all falls flat if these things that are supposed to be immutable are not immutable anymore, because if we mount them, everything changes. And all the reproducibility goes out of the window because the hashes of everything changed just because you looked at them. Yeah. But anyway, I think this our time more than over now. Thank you very much for all your interest. For all the rest, go to the website and file PRs. And of course, the most preferred PRs are the ones that move some of these items from the top to the bottom as fixed. So yeah, thank you very much.
That's all for the room. Thank you all for coming. Thanks to all the speakers.
So the rendering of this list is not very clear, and the titles don't stand out. Okay.
zakomponowane napisy. Dobrze, to ja zobaczę, czy tam jest problem jeszcze. No tak zrobiłem właśnie. Ale to pan mówi, że tam było na ekipę.
I asked if you were going to upload it. Oh, okay. Yeah, it's probably my things as well. I went.
Mógłby pan tylko podesłać, co tam było dokładnie.
Yeah, I went to upload it myself. And then I took like the presenter. Then did you take it from me?
Yes, but then I realized there was
So like, oh, I must be uploading the slides. And what's his name? John doesn't have any slides. So John Kaser didn't upload any slides, so I don't have anything for him.
Let me text.
Oh, nobody did.
Yeah, okay. And Sebastian as well, right? Because it was
Yeah, Sebastian.
freaking out that
Sebastian has
who
his.
does not.
So where did this is unlocated on there. Okay, that's actually this is new. That they showed right there. That used to do that. You used to have to go to switch it and actually go to the window. And I forgot. I never in my training I never mentioned
Oh, thank you.
Just in case.
It was harder than I thought it was going to be.
Understood from what you replied to.
Like, yeah, I was like, the first lap, I was like, oh fuck, 9 more.
Ah, because it was a lap.
When it's like 10 repeats of 5 minutes of
right.
so 2
Yes.
minutes rest.
But yes, five in 50 kilometers, not bad. Not bad.
I got lost at some point. I wasn't
Lost,
sure.
yeah.
I don't know if you see that.
Yes,
But
yes.
it was like a pass. I wasn't exactly sure. I was.
No, okay.
There were quite a lot of trees also. Like,
Yeah. Oh, yeah. Yeah, you're first, right? Yes. Yes, good. We're almost there. Okay, we can take presenter and the sites should be ready here. Hello. I think the first one. Yes. Yes. I was going to see if there is also
Yeah, pulled into a meeting.
We have the. Stay you going?
No, I'm staying. No, I got pulled into, like, I just went to go to the bathroom, and then bottomly's like, I need to talk to you. I'm like, crap. He goes, what did you say to Jim Semlin? I'm like, oh, shit.
We have the slide and the sponsors.
We're in problem now.
No.
Yes,
Is it in this slide deck? So
Well, you know what it's
okay,
about.
yes.
Yeah. Great. I can just use this thing, right?
Right.
I'll use the keyboards.
Yeah.
I'm gonna try to make 2 more slides.
Is there any introduction after the break?
I think so, yeah. Maybe Steve will say something, although I can.
Should I stay here or?
You're welcome to stay there.
want me to start? Yeah. I'll let you decide who to give these to. They don't go to you.
I know. Best two presentations.
What? Best two?
Best two.
Sure, whatever. We'll see.
Best, more engaging presentation.
Yes,
The
one
that
yes.
More.
Okay.
Okay.
Who?
Let's keep
There we go. Should we bring that up first? Tell that first.
Yeah.
Just.
Hi, Steve. I'm Venom. Nice to meet you.
Yes. I'm assuming all the speakers, the live speakers that are here, the ones that are giving topics, okay? So first of all, microconferences including you, the purpose of a microconference is to have discussion. You come here when you give a presentation, what happens, usually what you do is you did research, you searched, you learned something, and you want to share, so you come to a conference to share with everyone what you learned. Microconferences are the opposite. You have a problem, or you're stuck, or you have some sort of thing you want to decide, you come to the conference to learn from the audience. So the audience there should be engagement. You should have discussion. Basically this is like a business meeting. The best microconferences always end up with like patches to submission. I love it when I see in the changelog, as discussed at Linux Plumbers, blah, blah, blah. So to make this into a competition, we have these nice, lovely chocolates. So whatever microconference has the most discussion gets these chocolates. This is the way, I'm going to be doing this from now on.
We have a competition.
We have 1 more minute before we officially start.
It's how do we monitor? I know.
I don't know.
It's gonna be.
Maybe let the audience judge at the end
Right.
who wins.
So what you're saying is we need to bribe the audience.
So anyway, well, we got 1 minute, but maybe I should have started because well, we're a little early, but I'm just going to start because this is just the introduction. John, were you here for my announcement about the competition?
No.
He's one of the speakers, so there's we have.
I
these-
already lose. Wasn't here.
We have a lovely chocolate. We have 2 of them that we could give out, and the two microconferences that had the most discussion wins.
I don't need more chocolate.
Okay. Touche. Anyway, thanks everyone for coming to the real-time microconference. Can you shut the door behind you? Can you shut the door? So first I want to start off is thank our sponsors. Without sponsors, we would not be here. Last I heard, by the way, we had 790 attendees with 25 that haven't shown up. So take your subtraction, but still, the biggest plumbers we've ever had before was in Lisbon with 550. So we are over 200 people more than we were in Lisbon. So this is, thank you, congratulations. So, Diamond, we have Meta, and I have to take my glasses off so I can read. So Platinum, we have eBPF, NVIDIA, Western Digital, Google, Gold, ARM, DigitalOcean, because I really need it's much smaller on this screen. Netflix, Intel, Microsoft, they need a bigger logo, I think. So Jump Trading for Silver, JumpJail, Linaro, Igalia, Red Hat, AWS, and I want to do a special shout out for the Linux Foundation because a lot of people don't realize how much work that the Linux Foundation does for us. And they're not really sponsors because we do pay them a very small fee to do this, but they are the ones that come help us find the venues. They're the ones that will set up the logistics of everything. So we don't have to think about it. It allows the Linux Plumbers Committee to just focus on the content. So, I mean, they do an awful lot for us, and without them, we wouldn't be going all over the world like we do today. If we wanted to do it on our own, we would probably have to pick one location inside a university and just stay there year and year and year. But if you want to go all over the world, this is why they've helped us a lot. And by the way, next year, it's not locked down yet, but if you want to come to Plumbers, I hope you like sushi. So, I'll jump to slide 2. anti-harassment policy. We do have a code of conduct. We do love discussion, heated discussion, but make sure everyone's nice.
Discussion, they get the chocolates.
Yes, that's what I mean.
Yeah,
But the one that with the most heated discussions, and but it's kind of like there's the rules of the game is once you have insults, then I'm sorry, you're kind of kicked out of the competition and the conference. But anyway, so everyone be nice, and I think that's about it. So our first presenter, and what was the name of your title?
I think it's.
I just put it right there. And do you know what to do?
Yeah.
No, I know. Very good. Thank you.
Thank you very much. All right. Okay, let's start. My name is Benno. I'm from the Technical University of Applied Sciences in Regensburg. And this panel will be about stochastic methods for probabilistic runtime evaluation and also about prediction of worst case execution times in the context of real time. I'm in an early stage of my PhD and interested in the field of probabilistic evaluation of runtime behavior, not solely from the perspective of the academic point of view, but also how it can be applied to address real-world problems. And that is why I'm here to discuss about some ideas and visions. So let's just dive into the topic about analyzing runtime behavior. So there are several approaches on how to analyze and go for it. The first one is the static one, so inspect the code, but that has a lot of issues if you're dealing with complex systems, especially with non-deterministic one. So we often go with the measure-based approach that is often used in industry. And we are looking at a different or kind of a third one that combines the measurement-based approach with some probabilistic tooling and methods. And this one seeks to balance the accuracy and also the computational feasibility of the both beforehand. So the idea basically is to enhance the measure-based approach with tools or with stuff to get better results. And why are we doing this? Well, as we often look at the worst case latency and worst case execution times, not interested in the average one, these worst case execution times are often the ones that occur very rarely, and therefore we have to measure a lot to actually catch them. And for example, if we let run a system for 2 days, measure all the latencies, and say, well, that is now enough, that is enough data to actually trust in the statements of reliability and stability of my system, then one question would be how much level of trust can I put into a system that I just observed for 5 minutes? So how can I quantify the assurance of observed worst case execution time? And one advantage of having this quantification would be to actually increase the turnaround times in development. So just put it into measurement and letting or seeing what happens. So maybe a little comparison between the current measure-based approach and the probabilistic one. Usually we have this scenario where we have some kind of start, interrupt, signal, event, whatever, and some arrival date. And hopefully this latency is smaller than the deadline we specified. Then we have this kind of distribution of latency values, and again we are only actually interested in the right-hand part of the worst case execution times that can be arguably seen as a two-component stuff. So first of all, this kind of tail latency, where this represents kind of a systematic distribution of the worst case latencies, and also this bar that I exaggerated some outliers. And one of the, and this might be very familiar because this is often what we get from tools like cyclic test. On the other hand, or our idea is to use these measurements, this data, and put them not into a histogram but into a model. So this combination of measurement-based and model-based. And we do a lot of these in university, and the goal is to actually giving a try at real-world problems. In the field of the model, we go for the simplest one, that is automata or state machines, and derive, as I said, some kind of stochastic model that incorporates more about the system itself, not only its behavior, but also the structure modeled as the state machine. And two side notes. First of all, these outliers are really hard to deal with. I think we all agree on that. And therefore, we do not seek to actually solve these or automatically solve these issues related to that, but support developers and analysts in using or doing more with the data at hand. And there is a second side note. So actually this approach is highly inspired by another researcher you are very familiar with, Bristow de Oliveira, who unfortunately can no longer be with us. But he did some remarkable work in this field of real-time evaluation, and also was one of the first that also played around with state automatas in this field. Having another perspective, so this approach that we are striving for consists of 4 steps. So we kind of extract an abstract representation of the system as model, where each state represents an effective system state that does not necessarily correspond to an actual system state, where the transitions between the states are triggered by any kind of events, for example, trace points or something similar. Then we kind of annotate these trace points or instrument our system, which is kind of a mapping back of our model into the system, retrieving the data, combining the model and the data to derive the stochastic model, which can then be used for analysis purposes and also the prediction of worst case latencies. Just another perspective of comparison. So the measurement analysis usually requires you to have at least some basic understanding of the system and precise information about the events happening. You may not discover all the extreme outliers, and of course you influence the actual system behavior due to the instrumentation. And for the probabilistic approach, it's basically the same. Besides, you have some further opportunities regarding introspection of the cause of latencies, maybe reduced measurement duration, and the extrapolation of the runtime behavior regarding extreme values. There is one example or demo case I just brought you. I just want to skip over it very quickly. So cyclic test, we are considering jitter, and what we did is we put some annotation points both in user space as well as in the kernel space to retrieve more information about what's happening in the system, in the system globally, where some other user space application is executed in between. And we run it on a RISC-V board with the cyclic test running on 3 isolated CPUs. On the right-hand side are the steps we have taken, outlined. And actually, we did a very basic proof of concept implementation of some very lightweight trace points, because we are only interested in 3 information: the timestamp, the event name, and the CPU ID where it ran on. The instrumentation looked something similar like this. So again, what this function does is it writes these 3 information into a statically pre-allocated array that is then in the analyze step collected, combined with the user space data in order to put into or merged into our model, in our stochastic model, which then gives us some hints and insights into the global runtime behavior of the system itself.
Is the model
wait. Sorry?
Is the model computed automatically some way, or do you start from an offline specification to be add data?
In this case, we retrieve the model from the data. So in order to make it very lightweight and comfortable for the user, it is retrieved out from the data. But it could also be pre-specified besides the data.
Okay.
In this case, actually, there are, for example, some states that were never reached in our measurements. Okay, just to give you basic results, and then we can continue or start discussing, this is what cyclic test usually gives you about the jitter values. And we did this, or this measurement has taken 7 hours, and the worst case, the maximum value that was observed was at 56 microseconds. And we did several other measurements with different durations, this one for 10 minutes. And there is a slight shift because we do not, we are not interested in the average values or all the values. We are only interested in the extreme one. We throw some extreme value analysis on it, so we only consider the maximum or the extreme values. So that's why the shift. And what might be a result is then this, where in green you see the actual measurements taken from 60 seconds of recording, and the red one are the predictions that the model, the stochastic model, gives you when being fed it with 60 seconds of measurements. And on the right-hand side, there are 2 lines that highlights the actual observed maximum value of the measurement, and also the worst case execution time that has been predicted by the model. And there are some further measurements. You can have a look in the slides afterwards yourself. Because I want to skip over it to actually start discussing with you about whether, because based on the results, we are carefully optimistic about opportunities to apply this method and enhance the actual or the measurement approach until now. And we would like to have chat or learn from you what your thoughts and opinions are on using stochastic methods in general, and where it can be incorporated if it is useful. For example, if I look at RTLR, and so on. Yeah.
I will start if you don't mind.
Yeah, sure.
I already have I lost I'm the lock owner, so I'm sorry. Yeah. No, sorry. What is the role of the workload in this? Because maybe many of the things you observe on the system are actually workload dependent, because if I run in cyclic test, you are doing databases or web servers or what, you may observe different distributions of. So how do you handle that? Because probabilistic means sort of absolute probability of, but actually that is correlated to, or seriously, depending on the conditions.
Yeah, so you mean if you have kind of different trace points and the latency of one transition is depending on another, or kind of the
yeah, one thing is the correlation. If you handle correlations, I guess you can also compute some way in your model some correlations. But my question was more about that. Even if you get this Bell distribution, it's actually depending on the workload. Like in the OSADL farm, while the system is idle, you get a shape, and while it is under load, you get a shape. But
yes. So again, this is not an automatic tool that solves all your problems and all your wishes. It is a tool that gives you power to do the right things maybe better. So one big assumption of this approach is that you or we as a developer know where to put kind of the pins, where to actually retrieve the values and the timestamps. So this is kind of an issue that we do not want to address in this approach because it is unsolvable. Because again, if you would, then you would have such a big model that this approach does not make sense anymore. So it is kind of having or seeking for the balance of expert knowledge and where to put or carefully put your trace points against enough power to nevertheless use the statistic methods.
Got a question. So actually, maybe I didn't fully understand. So I think you mentioned at the start worst case execution time, but then the example is wake up latency. I think.
Yes.
Right.
So this is a kind of a different approach,
right.
Yeah. Because first it is the worst case latency, and then it's jitter, yeah. But it is you can map it if you change perspective. So the jitter value is kind of you have a deadline or kind of an expected time to be waking up, and the actual, or in the case of cyclic test, and the actual time where you have been waken up, and this difference kind of can be seen or can be modeled the same way.
Okay.
So it is not the same. Yeah, you're right.
No. I guess my question is I guess the model should be able to actually also model the worst case execution time. So essentially your response time. So how much, let's say, runtime you need every time you wake up.
Yeah.
Because if that's the case, one thought was could be useful, for example, for sched deadline. I'm not sure if you are familiar with that, but essentially a CBS implementation in the kernel. I guess the number one questions we always get, you have to define two parameters, runtime and period deadline. So period deadline is always easy. Runtime, it's kind of tricky because you need to specify a parameter. So I was wondering if this model, since it's stochastics based on actual thing running, can actually help with specifying what your runtime is. So the idea is you run what you need to run for a while, and then that thing tells you that's probably most likely to be what you need. So that can be useful, I think.
Yep, we will take this and have a look into it.
Of course, that means can this work for user space, or is this just
that is kind of one of the interesting things. This is not coupled to one space or one domain. So you could use data from kernel space, from user space, from firmware even. As long as you have the same time base, so that has been ensured.
Okay, because I'm saying if you want to know about worst case execution time, you really do want. That's how it's usually the user space that's you're worried about.
Yeah.
Oh. Only if there's no others, if they want to. So just question about this. So you showed there were some functions you need to. So you need to hack the kernel to change the kernel code in order to enter your monitoring points, or can you do it with available tools, K-probes, or I don't know what?
It can be used. Static trace points, etc., can also be used. So in this case, we just used our very lightweight stuff to ensure that the influence is brought to a bare minimum. But ftrace and all the infrastructure can be used in that.
Actually, since you mentioned Daniel's work, so maybe you're aware of the RV thing. So the idea is essentially to insert those points, kind of dynamical based on your model as well. So probably that can be reused in this case as well.
Exactly, because we only need kind of the context, the timestamp, and which event has been occurred.
What? Who? Oh, ready?
So first of all, I apologize if I didn't fully understand the whole thing, but to what extent did you eliminate hardware effects, comma, could you use this to fingerprint individual CPU cores?
We did not eliminate any hardware effects. About the fingerprinting, I had to think about a moment. Yeah.
It's experimental. So
it is work in progress, and I'll take all the aspects with me. Yeah.
Yeah, I'm curious if you could actually identify individual cores based on, patterns. So anyway, there you go.
I think, Vivek, 1 minute. Anyone else for one last thing? Who? Wait, someone over here? Someone had their hand over?
No, I was putting up 1 minute.
Oh.
I don't have a point.
So, anyway, thank you.
Right, yeah, thank you.
So, I should actually have done one during the discussion.
You have to show me what I have to do.
Yes, all you have to do, we go here. And by the way, and then which one is yours? What was
Walk
it?
the line.
Walk the line, there it is. Click it. Okay, and FYI, we also have notes that anyone else can take, because I started to do it just because I forgot to mention it. But I'm a really bad note taker. So if anyone else is good at note taking, please feel free. The interface is really slow, but it's kind of like Ethernet. What, do you want to do it?
Maybe afterwards the presenter as well, if they want to add what they got from the...
Yeah, when you're done, the presenters can actually, when you're done, if you want to add your own notes afterwards.
Or at least the,
just
what
the
you
highlights.
got from the...
What, you want to use my laptop? No.
Good.
Easy.
Chime? Yeah.
Okay.
So, I would like to take the perspective of the real-time application developer today, but also sneaking in a little bit of knowledge and experience from the kernel side. How does it do? Okay. It is about hard real-time. It's a hard topic, so only the hard folks should do that. This is reality, obviously. So real-time application developers received extra training. They are very good in their job. They have real-time system design experience. They have a deep understanding how the kernel works underneath them, the tool chains, the libraries, you name them. They only write simple programs still, just a single application or a single thread, basically, no log nesting, whatever. And they obviously know what is real-time and what is best effort and how to split things properly.
Where did you know?
Yes, we have all these people on our side as well, but we have customers, unfortunately. Oh, no, sorry. No. So to give you a stage, what could go wrong, possibly? I mean, these are the simple things you look at if you ever list a real-time program that is not behaving as expected. You shouldn't do printing when you don't know where it's going to be printed to. I mean, the malloc in your critical loop is the famous one. It works most of the time, very fast, except when not. These are the simple issues, but it's getting more complicated if you look at the details. You may read from a file descriptor by, say, might be good, might be bad, depending on the context. So what are you reading from? So it's already getting harder just to read the code from that level to understand if there's a problem or not. Or if you're dealing with memory mapped interfaces, where does the memory come from? Is it RAM backed? Is it whatever hardware backed but deterministic? Or is it something which vanishes and comes back because it's coming from a memory mapped file or something like this? And then there are languages which can help you not that much. This is actually from real code, kind of. I've seen it. It's not that rare, apparently. There are languages basically hiding you or runtimes hiding you what's happening underneath, like what kind of lock you're using. The problem, if you want to do multi-priority threads, the lock has to take into account what the lock holder's priority is, obviously. Otherwise, things can take quite a while until it actually happens. And if the runtime tells you it's easy to do synchronization but doesn't help you with annotating it properly, you have a problem. That was also hard to find for us, at least back then. Again, this language, it's thread safe, but it's unfortunately real-time safe, because underneath this runtime does introduce some nice logs, which again leads to the previous slides, are not real-time, fully real-time aware. Now that's, so to say, a subset of the possible things that go wrong if you just write straightforward code which should behave deterministically. Now, the point is, or the good thing is, as we all know, PrintRT for the Linux kernel is giving us a very flexible environment, and everything works generally quite well. Too well, I would say, in some cases. You have standard syscalls. They all should behave well to the degree you use the right context, but they don't tell you very clearly if they're not behaving. You see it possibly too late. So fact is, the kernel by itself is real-time aware, but not all corners of it, obviously. This is the modern approach, some people say. This is the old-style approach. You have two kernels in the same base, so I'm also maintaining the Xenomai project for quite a while, which has a dual kernel approach. So you have two schedulers in one system, and the task have to choose which scheduler to use. So there's the real-time one, and there's the Linux one. And if a task is in the real-time domain, well, everything is done as good as possible for the real-time domain. It has been designed for that. It has been eliminated any kind of these problem spaces. You have special system calls you can issue, or you have to issue. And you can still use Linux as well, but then you are basically stepping across the border. And that is, yeah, this is an immediate feedback the application can get. So it has pros and cons. From an application point of view, this is what people tell me, again, when they're using the system. That's very convenient because the application can get, this is what we actually have in the system, early feedback when they are stepping over that line. But obviously, from the implementation point of view, don't want to go into this in this talk here. This is obviously, you pay the price in the system and the integration of the lower levels. But again, we are looking at the user perspective, so we have quite a few users who are very, very happy with large applications that they get this kind of feedback early when they are stepping over the line. So this is about mechanism versus policy. And now thinking in the two domains, because as I said, we have both scenarios. We're not only running on Xenomai, we're also running a lot of PrintRT. So what has to be done in order to have the same thing also with standard kernel? How to detect things, first thing. So we have Xenomai. As I said, this is architecturally separated. You can get this kind of information at the point of migration. What do you do with the mainline? Well, you have to instrument and you have to, well, have something there. That's, I would like to throw in here in the discussion as well. This is one thing, where to detect that there is possibly a problem with the application. The other thing is obviously how to report the problem. You can look at traces afterwards, but maybe the application can get the information earlier. In Xenomai, we built in a signal. We piggyback on an existing rarely used signal and say, okay, if the application wants the information, it gets the signal injected. So early report. How to do it maybe with mainline. But the trigger part is also when do we trigger? So application has a life cycle, setup, operation, tear down. You don't want to report about problems during setup, at least not real-time problems, because this is best effort anyway. So you have to inform the system, I'm operational, I'm just setting up, tearing down. That's the mechanism needed for that. And then the tricky part really is, as I said, we are paying on the Xenomai side the price in the kernel. How do you instrument? How do you tell what is real-time, what is not? For one is real-time is a microsecond, for others it's a milliseconds, for others again a second, for example. But what is the context? So here's the tricky thing, I would say. Is there a way to describe, so to say, your expectation as application developer or your promises as system provider towards the application so that this is, you can build up the treaty between both. And you can say, okay, this is what I can deliver, this is what you want, there's a mismatch, I will tell you, but how to maintain that? On the kernel side, on the userland side, library on library on library, if you want to allow that kind of thing. So this is, I think, probably the challenge, and this is the thing that is driving us for quite a while. there's some common ground, I think, between both worlds. And there's definitely some separate parts. So there's common ground, I would say, in this provide tooling, instrumentation, I don't know what, to do these late failing things. Ne? A malloc will be seen in the mainline kernel as well as a problem at some stage when you are close to short memory and you are doing the malloc from your real-time workload, you get the latency. But this is too late, because this may happen already in the field. You want to have it earlier. So having instrumentation on these calls, which are mostly behaving quite well, but should already on the first call give you a feedback, this is generally not a good idea. That could be a common ground, because it's high up in the stack. It's in general libraries. Maybe there is some ways to do that. But also in the way how to tell the system the expectations, like I'm operational, I'm in the setup phase, I have this kind of delay expectations. Well, get deadline obviously is a way to express this, but not everything is modeled this way. So maybe there's also some common ground in this area. And with that, I would open up for discussions and ideas. Thomas.
Hello. There's a similar thing has been tried, and the approach was horrible, for isolation. So we back then asked the people who were just, it was just duct tape into the code, trying to explore the trace points, whether you can hook up into that. And I think nowadays with eBPF, on a trace point, you actually can do it quite elegantly. I mean, not that I'm advocating for BPF, but sometimes it's actually useful.
Actually, this is something I've been working on for tracing is S-frame work. I'm very familiar with that, where we could actually, okay, so it's in a way, it's kind of like orc unwinder in user space, where we can actually do user space unwinding from the kernel. I'm wondering if you're worried about certain system calls, like, we have the might sleep or whatever, if we know something is like dangerous, if it's possible that we could hook into something that it would walk all the way up, and it could tell you every single, it could tell you where in user space you're calling dangerous functions. Would that, something like that?
That would answer part of the points, but this is the mechanism. Yeah? What we get right now with the signal, we also can obviously install a signal handler and do the backtrace, for example, from the signal handler application. Say, great, this is where I came from. This is my framework, and this is the syscall entry. Yes, it's an important element, and it's part of the problem, and it's good that we have the options there, but it's not only the full solution.
Right.
So you mentioned scheduling, and I get it's not for everything, but I guess the end bad results you get is kind of a deadline miss, right? So we are talking about, so anything that has a deadline can be modeled.
Yeah, but do you know upfront? This is my challenge is, do I want to have this information as early as possible? I don't want to sit down with the customer of our customer to debug their application by looking from a system level at this point, which is currently often what is happening. I want to have this information to the developer as easy as possible, as early as possible.
Yes.
Like from the compiler says you are compiling nonsense, stop it. It doesn't even compile it.
Right.
This is something I have in mind, however we can achieve that and how far we can go. No perfection, but this would be the interesting thing. But there were other questions before, we looked into many things. The point is, as I said, the mechanism is one element, it's an important one, but it doesn't give you automatically the information. What's the context? You need also some way to express the right context. Is this file descriptor the right one? Is it the wrong one? In your context, and even more complex things. It's not just binary, this syscall is good, that one is bad. There are such things, but there are also these in between. That's why I mentioned the read syscall.
I think perhaps you need to kind of break the problem down into the different parts. You're right, there's getting the developer feedback at the time they're putting the system together and being able to kind of trace where the problem points are. And then there's that actually verifying that a given process that needs the real-time guarantee in your integration is meeting its guarantees there. I think that for the latter, actually measuring it based on what the expectations of the process are and being able to document that, actually have those expectations documented and verified by perhaps by a user space process operating at the same time is one way to do it. But I'd be really interested in those kind of early feedback mechanisms on individual syscalls. But I think breaking the problem into two parts is probably the only way you're going to solve it.
I'm wondering how much real-time this real-time is, in the sense that if you have malloc there, really, and also, are you doing anything like mlock pre-fault in the pages? Are you telling that to your customers? Because it doesn't look like real-time.
It's very easy, just zero jitter. That's the customer expectation. There's zero jitter. There's maximum speed, nanosecond execution time, but Thomas can explain it better.
So just to clarify, real time is not about as fast or whatever as possible. It's as fast as specified. And if my period is 2 milliseconds, that's one thing. If my period is 2 minutes, it's still real time because I can't miss it. So I don't need mlock for a 2 minutes period. I might need it for 2 milliseconds. That's really a completely system and application specific setup and configuration thing. Real time is not something which is globally specifiable.
Yeah. I understand, but the thing is,
Mike.
And in some cases, it's totally fine to do a read system call inside of a real-time task, if your constraints allows it.
Real quick, I don't want this to fall into what's real time.
Actually,
I want to keep with the topic right now. Okay.
Yeah.
So I'm wondering. One question is: does something like what you're looking at? If you were able to give the customer something like an annotation, something that said, "Hey," and put in like a requirement from point A in this code and point B, and tell like the compiler that I expect this to take X amount of instructions or something like that. And if the compiler says, "Oh my God, you're calling this function that's bloating up and this blowing up," then say fail. So basically, it looks like what you want is a compiler help.
Kind of. I mean, I'm also competing, obviously, at least from some expectations, with these old-style RTOSes where you can read out, okay, this is taking me n instructions if I call this, or this is taking n times m instructions when I call it. We don't get there. I know the hardware already plays no longer that game with us, but we need something in between. We cannot expect that it's exact specified. Unfortunately, we can get into certain problem domains where we have a range of expectations, and obviously we don't want the customer to over document things. We need a certain level of, okay, gray, red, I don't know what, black areas, so that we can simplify the problem as much as possible.
But it still sounds like you have like some sort of, you're asking more help from a compiler, like you said. So basically, if the compiler actually knew like this function
the compiler, not necessarily, because the compiler doesn't know what you call in the end. If it's not a complete information.
No, I think you need also information which the programmer puts into it. Let's go to the file descriptor example. If it's on TempFS or RAMFS or whatever, it might be perfectly fine, but the compiler doesn't know, runtime doesn't know. So what you need is some information, hey, this is a safe file descriptor. Then the logic down somewhere can say, okay, if you call read on a safe file descriptor, I'm not yelling at you, but if you read on a non-safe one, then I'm going to poke you.
So basically, write it in Rust.
Something to throw.
I mean, we have quite some of these things. Think about the mini core dumper. It's a bad analogy, but the application programmer, only the application programmer knows which parts of the memory are actually valuable to be dumped in order to get information out of it.
So I think there are two options here that are both valid and very well together. One is you can do some static analysis of the program. For example, for saying, okay, you are using malloc there, that's not a good idea. So some of the analysis could be done just looking at the program. And the other aspect is that I think is what you need, you are looking for is to ask the system, for example, I'm going to have this kind of timer. I want to have this cyclic execution. So tell me at this point in time if that is going to be possible, taking into account the number of processes that are there. For example, assuming you are going to be a real-time process in the scheduling, how many are higher priority than you and all of that. So it's like, okay, at this point in time, all of what I'm asking is possible or not.
Would already be nice, yes, but I think this is already 2 steps ahead.
Okay.
But yeah.
So this is obviously, like, if we generalize a bit, it's first a business problem because you want to deal with customers, and then it's a communication problem, and then it's a specification problem, and then it's an integration problem across all that. So, and from my limited experience, for example, the security module folks, like the Linux security modules, whatever SMAC or the others, you can have like a specification of the requirements per system call XYZ and other hooks mechanism. Would that, such a mechanism would that be useful or not? So.
It could be. I mean, in the end, also the question is if you can then maintain the policy along that. As I said, if there's a simple mechanism, great. Is it also something I can maintain in the annotation, or can I offload the annotation to the user, or can I? That's the question. The second I'm driving with.
But then we go back to the point that each user has different.
Yes, I know. It's not an easy problem.
Yeah. Okay. So yeah, that's all from me. Thanks.
Thomas again.
Maybe you should just start building a library with very easy to solve problems, and then try to figure out with real-world application programmers whether they can use it or not, and whether there's a benefit. Yes. And then start from there and build more complex things on top and see how it evolves. I think that's the only approach you can take. I mean, there's no all-in-one solution we can come up with.
No.
One thing you could have the thing at is something like a glibc wrapper where you will see malloc and everything, and the glibc could look at the process priority and then figure out is malloc bad, is malloc not bad. Covering POSIX is huge, but this would.
Fact is, we already have this instrumentation and we shared it with some people, and they're now busy. Yeah.
Okay.
Busy and happy or busy?
At least busy.
That's the time. So thank you very much.
Thank you.
And what was the next? John. That's John Kaser. And what was your which? You have 2 PDFs.
I need both.
Yeah, but you have to do them one at a time, right?
Okay.
So which one's first? The 2 RT eval?
I guess the slides.
Which one?
The
you have outgoing and out. These are the 2 that you uploaded. RT eval out and RT eval ongoing.
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 And how do I get to the other one if I want it?
You click that plus, and it's right there.
All right.
And then you just hit the buttons for slides. I give up.
So I'm John Kaser. I maintain cyclic test and RT-val and Tuna and a bunch of other tools used in the real-time world. So this talk is not so much about the results or discussion, but about the RT-val tool and what we've been doing with it lately. So let's see.
That's a little plus or a little, yeah.
So if you don't know what RTVal is, it's a Python program, and it runs a measurement module, which is basically cyclic tests. That's all we've had in the past. And then we try to run a number of loads to stress the system. So there's some loads that are like built into RTVal, and one of them, all it does is compile the kernel with all mod config, which actually puts a lot of stress on the system. We run Hackbench as well, but you can hook up external programs. So we have StressNG is one of the loads that you can run. And by the way, if you're looking to contribute to a project, the interface from RTVal to StressNG is rather clunky. It'd be a fairly easy and good place if anyone wants to make some contributions. Okay. So when we started the project, it was started by Clark Williams and David Somerseth. I took it over when we moved from Python 2.7 into Python 3.x. And it basically ran the load modules and the measurement modules everywhere. And then when customers started running it, they were trying to fine-tune things, so they wanted the ability to run loads on some CPUs and measurement modules on other CPUs. So we've had that ability for a long time. So the problem with cyclic test is fine, but it's rather difficult to hook up the tracing to it. You can do it with trace command, but it's rather awkward. Then Daniel came along with RTLA, and has really superior tracing capabilities. So in the past, it's been very easy to hook up new load modules into RTVal, but we've never had any other measurement modules. So I've now added TimerLat as the first other one instead of cyclic test. It's going to probably be the default. Well, it will be the default in the future. I went too far. Yeah, all right, I'm going to switch slides here for a sec.
Hit the plus, and then find your slide and select it.
All right, how hard is that to see? It's hard to see.
Yeah, let me see if I can do something here.
I mean, I don't. We can skip it for discussion purposes. It's okay. If you want to look at those on your own time, all it is an example of if you run RTVal with cyclic tests. That's a typical kind of output you get. I switched back to it. We can skip those slides. If people want to look at those slides on their own time, it's fine.
We got two screens. We got two halves.
Let's try to see. Well, his is fine. It's the one it's on that thing that's all messed up.
This is easy to fix, yeah.
Shoot. Yeah, because yours, it looks fine on this one screen. That's why I'm wondering why your screen is.
Switch again.
Well, yeah, let me try. Yeah.
I could try to.
Let me just try another. Like, hopefully, I might just start switching different ones.
Well, that sounds fine.
Yep. And it's the ongoing or out?
Ongoing.
There we go. Wait.
Okay.
And now it's full screen, but.
Well, if anyone ever talks up, then leave it.
So if you just want to look at those other PDFs on your own time, it's just the output of RT-eval with cyclic tests and the output with timer lat. So you get overall statistics, and you get them per CPU. The results you're going to see are really bad there because I ran it not on a real-time kernel. But it's just to show you how similar the results are with timer lat and cyclic tests. Now, timer lat, in addition to superior tracing capabilities, there are some things that are a little different. It outputs statistics per IRQ, per kernel thread, and per user thread. For the first iteration, I've combined these into a single number again because that's what our customers will be familiar with, but I'm going to break it out again in future iterations. So that's basically all I wanted to show you there, the timer lat working. So Red Hat uses, of course, the purpose of RT-eval is to test if you're getting good real-time performance. But Red Hat uses RT-eval in order to certify customers' hardware. Some hardware is simply not capable of running getting good real-time performance, so we run this for, I forget how long, something like 24 hours. What we're thinking now is machines get bigger and bigger. Instead of, there's other things you could do with RT-eval. Sometimes customers don't need the hard real-time. They need good real-time performance, but they also want their machines to be running other loads. So you can think of load modules as non-real-time applications, and you can think of measurement modules as real-time applications. So the question is, can we use RT-eval to help a customer partition their machine up? So with that in mind, we've been slowly adding some new capabilities. One of them was simply to run measurement modules on ISIL CPUs, and that was done by Tomasz, I can't pronounce his last name, Gloser. We're going to add CPU sets. I've already got code that works. I just haven't pushed upstream yet because ISIL CPUs are technically deprecated by the kernel, but they're still widely in use, of course. Another thing is power saving. So right now, with cyclic tests, the default is to turn off any power saving. With timer lat, it doesn't do it by default, but you can turn it on. But the question is, could we have some level of power saving and still get a good enough level of real-time performance? So we're adding that capability, and we're taking a multi-approach on it. So Tomasz is trying to add this to RTLA timer lat right now. John Wyatt is putting in Python bindings in CPU power that we can use in our various tools. I had an intern, Manubov, who already achieved this on an okay level with just execing the CPU power tool. Then we're adding C groups, and then the final thing that we're working on is containers, and we've already got this going to some degree. So once again, we're trying to emulate what we think customers might want to do. Can you run a container that's running real-time programs while other containers are running something else and still get good performance? So that's basically it.
Any questions? Or
when you say using ISO CPU, does it also include full all the to disable all the kernel noise, or just the ISO CPU? Because ISO CPU you can specify several different parameters.
You wouldn't be able to use RT-eval to, if I understand you correctly, to set up the ISO CPUs. You'd be using other tools to set that up for you. All we're doing is allowing it to be included in when you're saying where the measurement modules are going to run, we're allowing it to be run on the ISO CPUs, that's all.
Okay.
To my shame, I think I missed it recently when I was looking for standardized load scenarios. I think we also discussed this. So do you say that RT eval is kind of providing this comparable load scenario? Let's say I want to reproduce the setup that someone else was doing, because you see always how people are measuring the real time, but you usually don't specify in details how they were putting the load up, and that may make a difference, obviously.
Yeah, we're simulating loads by doing.
And how stable is that then? How comparable is that load?
It's very stable, but I can't compare it. I mean, we're running this you can run it for a week at a time, but I can't compare it to a real customer's application.
That's clear, yeah.
Yeah.
If there's loads, by the way, if there's loads that you could think of, I think one thing that's pretty nice is if, you said you wanted kludge to get the stress NG and stuff like that, but what actually would be nice is if you could just say, hey, just specify a load, it just runs off the load, and is there a way to do that?
Well, it's very easy to add loads to RT eval right now, but
by modifying the code, right?
By modifying the code.
No,
We don't
so I'm
have,
saying is
I know
you
what
need
you're
an
saying, we
yes.
don't have something right now, a mechanism that can just run automatically where you specify the name of your load and run it, but that might be added in the future too.
Yeah.
I assume that you're in the final report that's produced, you're capturing a bunch of the metadata about the load and possibly about the machine and stuff?
Yes, definitely. You can see that in the report in the other PDF that didn't show up very well on the screen.
There's like, what's called the user loader, it's called the CPU loader.
Yeah, you get a ton of information about the machine itself, and then the results of running whichever your measurement module was. By the way, now that we've added timerlat, within RTLA there are other kinds of measurements that can be done, and as well as there's other measurement tools, so we could potentially add more measurement modules in the future. One thing Yuri said to me, I was thinking of adding one of the deadline tests from cyclic tests, and he said, well, just run timerlat with the deadline parameter on it. So there's many things we can do as well now.
When you are isolating the CPUs with the new C groups mechanism and then marking certain containers or certain processes within the containers as real time, are you doing this dynamically, or this is just static scripts, like initialization scripts? Like, how is the whole pipeline running? Or
like at the RT eval runtime. Yeah, at that moment.
Okay. And the containers, like some with RT tasks and some without RT tasks, and is there like identification mechanisms for that, or like some containers are allowed, for example, to have RT tasks, and some containers are not even allowed to have RT tasks and so on?
Yeah, well, this is all undergoing development right now, so.
Okay. No, don't think so.
Yeah.
Anything else? We still have time. I almost threw it to you. Let's put your hand up.
Do you also control IRQ affinity from RT eval, or is that out of scope? Or?
No, that's an interesting idea, though.
Okay. So just as you're putting there everything, just as I met it, besides containers, do you want to run it also within KVM?
That is not on my list of things to do right now. But I am always open to contributions from everybody.
Cool.
So.
Cool. I guess I'm a nice student. No, I'm joking.
To follow on with the question earlier about making the RT eval a little bit more representative of customer applications, I know you talked before about how the measurement units are more like a real-time process and the loads are more like a non-real-time. But I wonder if there's a way to have the loads be a little bit more like real-time tasks that are on the system, in terms of them having their own deadlines and priorities to simulate something more like a customer system?
I don't see why you couldn't do that.
So wait, I just want to make sure I understand the question too.
Okay.
So basically the question there is to have like your load actually be RT as well. So basically you're going, because that almost sounds like an OS noise source type of, because this is OS noise or
OS noise is mimicking like always running tasks instead of the periodic one. Okay. One thing that I know that there is this RT app application which you can specify essentially your composition using a JSON file. It's of course it's synthetic, but you can specify okay this task is only CPU specific. This task does I/O. Maybe I guess the tricky bit is to to translate from an actual thing, an actual application run by a customer to a synthetic thing that reasonably is close to that thing, but the application is there, so maybe you could try to use that.
I don't remember which one, but I know that there are a few different file system test benchmarks have loadable modules that with customer workloads. So I don't know if it's, so you might, like if you pick the right one, I don't know if it's like IOZone or one of the other ones, but if you pick the right one and made that one of the modules, you might get a bunch of workloads for free or something.
Mm-hmm. Thanks.
Anyone else?
Yes. Any interest in adding also not only the latency when you are woken up by a timer, but also maybe when you get an IPC, for example, container-to-container communications, or is that like completely out of scope for a tool like RT-eval now?
If I understand what you're saying, you're talking about a different kind of measurement there?
Yes, instead of only like, wake up time, it's just you have a timer and you measure, delay. But also, like you get another process sending you something over a pipe, a FIFO or network, local network, and just measure how long it takes for you to be woken up and react to that. So.
Yeah, that's not currently on my list of things to do, but I think we even have some tools in the cyclic test, in the RT test suite that do something like that. It's not on my list of things to add to RT-val right now.
I miss the old days back in 2004 when we were working on real time. I actually, where we had the power, what's it called, the printer port. I used to find the pins and take a paper clip and put the paper clip in the two pins, and that way I could signal one pin and it would trigger the other. And that was my measurement that I would use. That would be great to add. No. Anything else? You got anything else you want to say, or going once? Going twice? Thank you. Thank you. Thank you. Let's see which one is check the presentation. So no need to switch. So I was just I have to see which one I had for you for. So this the two was OPQW because you just had them generic, but I changed. I had it. So here's the first one. Do you want to put the first one up?
Yeah, it's the only one. I think it's
oh, so you, because I noticed you had another one.
It's the same. Yeah, I uploaded it twice just for the sake of.
Okay, so yeah, that's one. Okay.
Hello everyone. Today we'll present this idea of using to improve latency on CPU isolation without incurring much cost. It's a continuation of a presentation that I had last year at the same conference. This is me. I work at Red Hat, improving CPU isolation, live migration, trying to reduce overall guest latency. And also host latency as well, because it's necessary as well. You can find me over this handle on those networks. Well, what we want to run time-sensitive tasks with very low latency. That's the idea. So we can enable more real-time workloads on Linux. one way of doing this is trying to have this real-time task to run as uninterrupted as possible. Because, well, if it's running, if it's not like scheduled or the CPU is not on interruption, there is more time to process. I mean, more, well, it's ready to respond. So it's faster. I mean, it will have less latency. One of those issues that we have to deal with is like having interruptions on the CPU that's running the real-time workload, because, well, it increases the latency of the workload because it may take time to process the interruption, and at this time the workload won't be able to like reply whatever request that is forwarded to it. So one of those interruptions is called by interprocess interruptions. Like the ones inserted by schedule work on and queue work on. As of today, we can put some of those interruptions in housekeeping CPUs with CPU isolation, which is great. But there are some of them which we are not yet able to avoid. So what can we do about it? For explaining that part, I will try to introduce this problem which happens in some parts of the kernel. I see that on memcg, slub, and swap. But the idea is that you have a per CPU cache, which is quite efficient. The idea is that you are mostly touching this resource on per CPU granularity, and whenever some CPU needs more resource and you try to clean the cache that those other CPUs have, you will incur an IPI. It's great because you are mostly operating on local cache, and you don't have to use atomics or grab locks, like regular locks on that. But the reclaiming of resources from remote CPUs incurs an IPI, and if your processor who is running this real-time test receives this IPI, it will incur latency, which we don't want. That's the general idea of such per CPU cache. The idea is that the hot path, you just grab local locks, do your local work, and then local unlock. And when you eventually need to do this remote drain, for example, you just schedule work on every other CPU that's online. But as I said, that generates an IPI, and that's bad for the latency on that CPU. So how can we get rid of this IPI? I mean, not every situation can be done. I mean, sometimes you want to mess with like hardware registers and hardware resources, so you can't do this every time. But for those three applications that I mentioned before, you can just, for example, replace local locks with per CPU spin locks, which is the topic of my last presentation. So you get this per CPU spin lock for a CPU when you want to operate locally, and when you rarely happen to request an operation on a remote CPU, you just grab that remote per CPU spin lock and do the work anyway. And since this operation, like this remote operation, doesn't happen very often, you almost have no contention. There is some work that's done in this way by Mel Gorman on this commit that I mentioned here, where he successfully replaced local locks with per CPU spin locks and got some performance and latency improvements. And the whole idea of this replacement is like this. You replace local locks per spin locks, and then instead of running scheduler call, you just grab the lock, the per CPU lock, and do the work that you need. As mentioned before, the whole idea of spin locks is that they are expensive for three main reasons. Contention, getting cache line exclusiveness because you have to transit this cache line between CPUs, and memory barriers. which is the less of them. But in this case, in this per CPU cache case, you don't have a lot of contention because the drain operations are very rare. Getting cache line exclusivity is also very common. I mean, you are mostly having this local per CPU cache line exclusivity because you are mostly operating in your local CPU data. And the memory barriers are not supposed to be that much expensive at this point. But in any case, using the per CPU spin locks, we'll introduce like extra 3 to 15 cycles, depending on you inlining or not the spin lock call. And for some hot paths, that may be too much. But there is some point. When we enable preempt RT, we already have per CPU spin locks for local locks. So this price that we pay at the local lock grabbing and local unlock, it's already paid. So why not? Let me see. Why not get the remote spin lock and do that anyway? So it's already using a per CPU spin lock. It's just using for its own CPU, but we could just grab that spin lock and do the work that we need. That's where I introduced this idea. The naming may be not final at this point because, well, but the idea is that we can queue per CPU work. And this interface is supposed to keep the things working the same way on preempt RT disabled and apply this new strategy of per CPU spin locks on the preempt RT enabled. As I said before, when it applies, because hardware, things that touch hardware, that can't be done. But creating an interface for that is kind of messy. But we need to have this new helper to request and to flush the work when we need it. And also, we have to have a new way of getting the other CPUs, like the remote CPUs, local lock at this point, because it's kind of messy if you just like, well, remote lock of this CPU. So that's where I introduced this idea of QPW, which means Q per CPU, right? Work. The idea here is that we replace the local locks with these QPW locks and use this per CPU spin lock strategy to that you use the strategy of using the spin lock that's already available on local locks with preempt enabled. And this Q per CPU work will mostly grab the CPU, as I mentioned before. I mean, the idea of replacing it, it just happens here, like in line for preempt RT equals yes. On the preempt RT equals no, it will just fall back to the current functions. Those are the structures and functions, the idea of those functions that I just mentioned. You have just to create a new QPW struct to hold both the work struct and the CPU that you want to request work from. The QPW lock is just a spin lock when preempt RT equals yes. So the unlock is the same thing, and then you just grab the work structure and run the function. The flushing is nothing because you're already doing all the work. So it would vanish with some bugs, such as this one, where we grab, the CPU was very busy, and for some reason the flush work got stuck. Since the flush work in this implementation does basically nothing, this kind of bug would just go away. The implementation of this is like replacing, for the first example, we just used QPW lock instead of local lock, and Q per CPU work on instead of schedule work on or Q work on. Then I sent this implementation on the mailing list on those, and I implemented the QPW and applied it on mem controls, lub and swap, and tested it to find that it actually was very able to reduce the latency that we experienced on these virtual machines, and also in the host. The advantage of this implementation, where we just have to manually select the applications that will be using this and converting everything, it's just that we can convert uses on demand. And it doesn't mess with other users, but when we have to convert it, it may take a while, because if you're running a function on this queue per CPU work on, you have to convert it so you are not using local locks, because if you, in this context, grab a local lock and you are intended to grab the remote CPU's lock, that will be just messy. So we have to go through this case with a lot of caution. We have to analyze what will be called, and it's kind of hard to do that. So I was talking with some colleagues at Red Hat, and this idea came on, the idea of emulating the DCPU and SMP processor ID. Yeah, it's kind of hard, but it's a little bit better, I mean, for converting those previous usages, because we just replaced the queue work on with queue per CPU work on.
How much do you have?
Sorry?
How much do you have?
How much?
How much slides do you have to go on?
Right. How much main slide?
Oh, it's just that, almost.
Okay.
Sure.
In RT in the early days, we had local log on, which is basically what you suggest. We had, I have no idea, 20, 30 users in total. And then I started cleaning up, and we got down to C group and MM. And I didn't get around with MM folks and C group to get cross CPU access. They didn't like it at all. And this is actually the only reason why we ended up with local log or mainline. And over the years, I managed to get them all done, and except for MM, because of the latency you had. Because like memory accounting, it was hard. And it doesn't matter if it's networking or other subsystem, all of them appreciated having the same implementation for RT and non-RT. But this, if you go into this way, you're going to break it. Next thing is, it's not only RT. No-heads full is having the same limitation. They will also want this if you go that way. I think in the long run, you will be better off if you would transform them manually one by one, if the upstream maintainer appreciates that, to have cross-CPU access instead of doing it locally.
Okay, so you're suggesting that the previous idea of changing the whole implementation of local locks plus API to just ping locks would be better than just using this?
Yes, this is what I've been doing case by case across the kernel.
I see.
And if it wouldn't be for MM and C group, you wouldn't have it today.
I see, yeah. Yeah, I tried to do that like a couple of years ago, to try to convince people from MemCG to migrate the caches from like local to per CPU spin locks, but that didn't go well. They didn't like the latency that it's introduced.
It was me years ago, yes.
Yeah, okay. I can try that again then.
But if you go and emulate SMP processor ID and this CPU, and then you have migrate disable somewhere in between, this is getting messy.
Kinda, yeah. But the idea is to create an option for the neck that I take before and actually try to fix this. This is a lot of work, I agree, but...
How many users do you have?
Sorry?
How many users do you have?
I found those 3. I suppose there are more. For like, not just for I mean, I picked the per CPU cache idea, the local log plus API, but the idea of this KPW is that it could replace any QR con that does not touch hardware, so we could potentially save a lot of APIs on the per CPU, sorry, in the real-time running CPU.
Right, okay.
So it just created an opportunity. Maybe there are not that many schedule work on or queue work on, so maybe it's not that good, but I think it's worth to try because that would remove a lot of APIs at the same point.
To give another example, we had VM stat earlier, which was scheduled on each and every CPU, and it had to be that way. But then folks were on the other side that we could skip it, and now this is gone. And the MStat was one of those workers which was scheduled on every CPU every now and then regularly to update statistics or something like that. And then we talked to them and they agreed that we could slide. And it's not happening anymore. Only on those active CPUs, no longer on the isolated ones.
I see.
So maybe you're saying that we first want to confirm that we cannot really just remove the thing before. I mean, the three use cases, just confirm that they are really needed.
Yes, because it's not just RT, just no heads full should also.
No heads full to use this feature would require preempt RT because, or else we are introducing spin locks the same way. So.
Okay.
Well, I was just saying the advantages of like emulating the CPU number would be to don't have to touch every case by itself. We would just make to work on the helpers and emulate the CPU number. But the disadvantage is that.
Yeah, it's just a quick comment actually.
Sure.
So like the IPIs, I mean, this is from the RT context, but I've seen IPIs actually being a source of noise from CPU idle as well. So like this work is actually could be interesting beyond RT. So like making these things available outside of preempt RT only, I think there will be interest in it because like IPIs, I've seen a lot of IPIs just waking idle CPUs from deeper idle states and they are very hard to track. And what you are doing here is probably part of the cause, although I've seen the work queues as well, especially with the new CM queues. It seems they have a scheduler of their mind where it decides what CPU to wake up. But this work would be very interesting as well outside of RT for power management, especially CPU idle management. So like making this available would be quite great.
We could try to add an option and try to enable it without RT as well. And it would cost us the CPU lock and the spin lock and the spin lock, but if it's interesting in some case, that the person could enable it in like command line or so. Thanks.
Would it be automatically enabled for no hertz full then?
Yeah, we could, but they would have to pay the price, right?
There's already a performance hit when you enable it.
Yeah. That what I was talking next, the option of enable and disable it in like both parameters.
You have 7 minutes left. So
to the next one, okay.
It's up to you.
Sure. Then that's the slide where I would ask more suggestions if someone has anything, please, on this work. No? Nope. Well, thanks everyone. I will just jump to the next one. It's right here. Well, this next topic is like improving guest latency throughput by improving the interaction of RCU in KVM. In this case, what we want is to run time-sensitive tasks with very low latency inside KVM guests. And the issue that we were perceiving is that we were having latency violations in cyclic test and OSLET that were caused by RCUC threads running in the same CPU as the RT tasks. But, well, what is an RCUC? This is the kind of bug that we had to deal with. You see that there are context switches between CPU and for the vCPU and the thread and the RCUC, and then it goes back to the guest and you perceive a latest violation. The RCUC thread, they run RCU core when it's necessary. When some time has passed and you haven't reported a quiescent state. I will go a little bit on that in the next slide. But the idea is that in RCU, if you don't report a quiescent state for every other CPU that may or may not be using that structure, you will end up getting a CPU stuck. That CPU that's waiting for the RCU to finish that operation, so it can like free the structure, the copy of the old copy, right? RSU is a very efficient parallel programming mechanism. In read, it does not use atomics or anything like that. And on write, you just have to ask for every other CPU to make kind of report they are not using our structure, which we call KSN state. Once they all report it, you can go on with your processing. So if you do very little writes and use that data across many CPUs, it's a good way of protecting your data. When no CPU is, when your CPU is not referring or like trying to use any RSU protected memory, it's safe to be in KSN state, as I mentioned before. The issue is that if a CPU stays too long without reporting a KSN state, as I mentioned, that CPU can, the other CPU that's requested that grace period will be stuck. That's the case for the host, and that's the case also for the guest. And you can have a lot of latency on that workload, and that's not good. Well, let's say that you just entered the guest. You report a KSN state, which is already happening. You run your guest for a long while because your vCPU is doing a lot of work. And at some point, the timer will just interrupt you and say, well, you need to report the KSN state because I have another CPU there that's waiting for this. And then it reschedules out your vCPU and schedules in the RCU thread. If you end up to the timer interrupt and it asks for that. So one idea of doing this, of solving this, is that we report a KSN state in the guest exit as well. So it saves most of the cases of like running RCUC outside guest context, but it still happens. Then you just left the guest state. But there is a chance that after you just exited, you receive this request from another CPU from synchronized RCU. And when your timer interrupt happens to hit that part on its routine to check for RCU reporting, it will just run RCUC anyway. So we have this suggestion to have this RCU patience. We'll just act on RCU grace periods requested after some time, like some microseconds or some milliseconds. So the idea is that whenever we are just exiting a VM, we don't get hit by RCUC unnecessarily because it will just soon join enter the guest again and report KSN state as well. So the idea is that we don't run RCUC and we have more CPU time for our real-time workload. With those, we perceived a drastic reduction in the max latency on guest cyclic test. And as well, we perceived performance gain in the RT roast, even though it's marginal, it's something because you have more CPU time to your workload and less CPU time spent by the RCUC at this point, because it's cheaper to report a KSN state in guest exit where you are sure that you are in a KSN state than reporting it with RCUC thread because you have to switch back to the guest. Sorry, you have to switch back to host and schedule a task for that. Thanks. What we also notice performance gain in non-RT hosts, which is quite significant. I mean, we noticed like 4.5% more CPU cycles that were used for that CPU, vCPU. So the guests run longer, 4.5% longer with those changes. So on top of improving the latency, it also improved around 5% of the CPU time available for the VM, so you can perform more work at this point with the same machine, with the same VM, just by applying those changes, because you're running less RCUC and you are having more time. And that's it. The commits that I mentioned just got merged, so very recently, so it's kind of merged, but I thought it was interesting to comment to you guys.
Well, right now it's break time, but well, I'll take one question if there is one. But no, yeah, I know everyone wants to go for the. Oh wait, there's one question. Sorry, guys.
Okay, so just for being sure, you didn't have any peak latency in this case where there were hundreds of milliseconds or so. You are just lowering the worst case scenario, but there was no problem with latencies, right? I mean, you didn't have, okay.
Yes. Yeah, we have this target of latency of like 40 microseconds, and when it went out to that, we reached it to try to fix the bug. I'm not sure I got your question correctly.
No, that if it was a worst case, maybe higher than what you achieve now, but there was no problem with having determinism before.
Oh no, I think it was a question that basically saying what was before you did the change, how bad it was before the change.
No, how bad, but that the worst case scenario before these changes was also known.
Yeah. The latency that I mentioned here is the worst case scenario. I mean, I run cyclic tests for like 24 hours and get the CPU that performs the worst, and that's the number that we have here. So it's the worst case. I mean, we can't lose a deadline. So if that one case we got a higher latency, we have to deal with that, right? Yeah.
Okay. Thank you.
Thanks, everyone.
And with that, we are on break for 1/2 hour.
Because in one of the slides you wanted to still have some driving, and I saw the 16-year-old girl, do you think they will get to the point where all of those
It's just because you're kind of got kind of ruffling my feathers a little bit. Yeah, it bothers me that it bothers me. It bothers me that it ruffles my feathers. Yeah, I usually think I'm pretty thick-skinned. It's pretty rare that my feathers get ruffled, but it's such a free self-push to the yeah, I know. But that's what bothers me. I could care less, right? But it still doesn't.
You would expect that that will get scheduled out. If it's gets scheduled out in an isolated CPU, I would expect that it's for something very important. So you don't want to preempt that one with a so you want to make sure that it does the stuff as quickly as possible. So it doesn't make sense to combine it in real-time scheduled tasks with isolated Yeah, those videos are pulling something like that.
Sendo que esse projeto tem a ideia de ter uma força pelo menos. Então, aí então eu imagino que então mais CPUs, vamos dizer, 128 CPUs lá no sistema, então mais threads e mais timers. E quais timers? Provavelmente os high HR timers são e aí, só que não deu tempo, tinha uma pergunta. Aí, tipo, os HR timers, se eu não me engano, quanto mais existem, vai ter uma interferência deles mesmos. Ele vai ter também, se eu não me engano, ele vai perdendo a... I would be here for you to be a good
So, well, I think that so the last mission is about using the API design. Using there are two implementations. The first one is the one I sent over. The other one is like recommending so like this CPU becomes something else, and you have some raw CPU that you actually use. I find that are better way compared to from porting. And that's probably you only change the user in that, but the sure will be a bit complicated that way. The basic implementation now we get the API and just teach the user how to use the API. It's fine. Yeah, but
we could do that if, let's say that we have just those 3 cases. It's fine. It's already implemented, so just use it.
Yeah.
Maybe it would be a problem in the future. For example, like you're using the local lock in some places. User local locks on that point. Let's say that you call this other function, and for some reason it's using local locks, and you're using like simulated local locks.
Yeah.
It's a problem.
Yeah.
And that's why I went through the second option, because even though it's more costly and more complicated to implement, it's feasible.
Yeah, I think the second option is right. I haven't really think about things to it. Okay, but you can maybe all the others like you just and to make sure that it doesn't break anything. That's yeah, that's the challenge. I will try to implement this more. Yeah, it's very hard to do that because we do more different. Yeah, I will try to and see how that does work. If it does work, and if it doesn't bring anything. So this implementation that is let it run for a while.
So this is
yeah, but as the basis just not me for me, and you have to be the
Yeah, that's the idea of the second implementation. Because they made more because the first implementation we have is okay, I migrate to the version. Let's say that someone wants to add another function there and it's calling local. That's it.
One of those.
I mean, we could just try to get something like, I'll take this network on what stickers that you work on without the local parts, and okay, it does not work local, so it's also on the I think it's better choice. Yeah.
Honestly, I think
doesn't matter how
yeah, I think that kind of is a good part of the name. Like it's use my guys in the abstraction scenario. Maybe it's not too complicated, but complicated is different.
yeah, it's the same thing. Using skills or maybe we end up that in the way that cache pieces but you need to add instrumentation for all the CPU.
I mean, it will just be a delay. It will just be a normal. So it's
no, the thing is, they are expecting the to be operating on the local CPU. Then you may use some of the CPU data. But if you run on a different CPU, then you're accessing the wrong data.
You need to fetch to correct the
That's why we have some instrumentation for the CPU access.
After, let's say,
Could be overhead.
Well, we could have like a flag that would say, well, you're trying to use local lock, or you should use W lock because
I need
Run some tests.
threads
Yes.
that
Yeah, because in your case,
that are
you can
delete
I put
because
some but you need to change it in some way.
other hierarchy threads
Big
created,
thing, yeah.
and then I may have kernel thread, kernel key timer threads accumulated. I don't know. I mean,
The whole point, I mean, it's a whole complicated API interface, like the new function and so on, how to use it properly. But if you think about it, it's just like use that use block that you already have and get it over. Yeah. But you see, I mean, the solution is very simple, but in the other, it's very complex to implement a way of doing that. That's the hard part.
Yeah. But if you have RT priorities higher than one, those one for then you get back behind.
And
this is actually
appreciate
the problem is in other cases because then I can select my own priority for my
break time?
Yeah, it's break time.
Yeah, that's a problem, the biology problem. But the wake ups, we are like for Nanospeed and all those kind of things, they have to use right away. Just only priority. The other arm wouldn't be it. For the same reason, because they are not important.
Right. So, okay, thank you very much for the question.
Yeah.
Yeah, I'm just to see your API before work.
I need to remember what I put on the slide.
So, how ready do you think your current patch?
Sorry?
How ready do you think is your current API before work?
I think for the instruction patching, I'm good. There's some questions I want to ask about it, but I think I'm fairly confident that we can go through it. It's more the memory management side of things where people raise things and I'm a bit lost, so I need guidance. Mostly, so it's for deferring TLB flushes, but for the kernel range. And there's two aspects where things can go wrong. I mean, I could say wait until you see the presentation and I'll think more about it.
We are
but
wait for.
one is, because normally if you send an API, like to several CPUs, at least the standard procedure is you send your API, you have the callback that's run on the CPUs, and once all of the remote CPUs have an executed operation, you get the completion back so that it's all synchronous. When you defer that, first of all, it becomes asynchronous because you can exit like the procedures that would send the API without the callback having been run on the remote CPUs. And when the remote CPU enters the kernel, there is a non-zero length of code that is executed like super early in the entry code until you get to the point where you run the delay or deferred callback. So in this region of code, you need to be really careful that you are not impacted by what should have been run before, but it's going to be run after. So for TLB flushes, it's like, yeah, well, for instance, I'm deferring the flushes for Vienna. So you need to make sure that you're not accessing anything that was in a Vienna and that could have been modified. Like one thing that was brought up was if your stack is remapped, but that's not a problem because you remote tasks can't modify your stack, so you're okay. But then there are things where I'm not sure. So I want to see if people have ideas on maybe how to instrument this and flag accesses in the vmalloc range in early entry code. I have no idea if that's feasible.
So people aren't using RT to run check anymore, so that's really my napkin for that.
Okay.
So I think Jan won one. His was the most active.
That was
question
pretty
is,
active, yes.
I just have to figure out who's
Another.
Oh my God! Yes, I said, hey, you look familiar. Yes, nice to see you, man. Nice to see you in person. Yeah, good. And this work was more of a. Oh my God! I made a fool of myself at the RT meeting. Yeah. And I would participate. I don't really know today. But you're still routine. Oh, yeah. We were sleeping. Oh, we were sleeping. Oh, yeah. I haven't seen him on TV for 2 years. It's like obviously, I haven't seen people for the same time. Yes. Actually, we should be starting.
I have no idea how this works.
You know how to switch?
Nope.
Hit the plus. Find your slides. And which slide is yours?
API, LPC, that sounds like the right thing.
That's it.
Okay, brilliant. Okay. Am I good to go? Yeah, okay. Hi everyone, I'm Valentin Schneider. I work for Red Hat and I'm going to be talking about APIs and what to do when you don't really want them to hit certain CPUs. So the nice thing is, Leonardo kind of touched on it, at least for the context I'm interested in, which is CPU isolation, no hurtful, SU no callback, the whole shebang. And the idea is you have a single user space task on one of those isolated CPUs, and it doesn't really want to enter the kernel, at least not voluntarily. So it could be your vCPU thread, it could be DPDK style packet processing. Really, it's full user space, and as long as it doesn't get interrupted, it's going to stay in user space. Now, unfortunately, when you look at that, you can still end up getting IPIs sent to the CPUs, and that comes from work that's happening on the housekeeping CPUs. So we have, in a way, an isolation break. And the two I'm interested in are, first of all, for x86, when you patch kernel instructions, you end up sending IPIs to do a synchronization for that. So static keys, for instance, are going to be the main culprit here. And also, when you do a TLB flush for addresses in the kernel range, you can end up sending IPIs to these CPUs. Now, if you look at these two, you can actually start reasoning that they only really concern the kernel. Static keys are instructions that are only in the kernel, and if you're flushing the TLB for the kernel range, as long as you're in user space, that doesn't really concern you. So the logic or the idea is, can't we actually wait until the task enters the kernel for some other reason, and then do this work? Because it's not urgent to do that immediately if the task is in user space. That's pretty much the idea behind IPI deferral. Now, it's not a new topic. I've talked about this at OSPM, at LPC, and so there's been a few little bits of work that's been accomplished on the way there. First of all, just to figure out what IPIs are we getting and where they come from, because until relatively recently, we didn't have anything. We had some IPI trace point, but it was Arch-specific for ARM64 and ARM, and it just told you, hey, you've got an IPI. It didn't tell you what really it was or where did it come from. So we have trace points for that now. And we can also filter a bit more cleverly with ftrace. So we couldn't actually use like CPU mask intersection for ftrace filters, which is something that's really useful when you do say, hey, I know my CPU mask, my isolated set, and I just want events that target these CPUs. Because then with the level invocation there, anything that you have in the resulting trace is interference. You don't have to do post-processing. You know, if there is something in the trace, that's something you have to look at. Actually, if you replace Hackbench there with RT-eval that John talked about, that's how I found out about the two IPIs I'm talking about. Now into the meat of the subject. There is some complications with deferring IPIs. So here, there's probably a bit too much detail on textbook, so that's what you get when you're updating static keys or really any instruction. I'm just going to keep saying static keys because it's faster than kernel instruction patching. But right now upstream, when you update your text, you're going to end up sending IPIs to a lot of CPUs, and then at the end of all of that, synchronously, you're going to get the completion back, and then you go on and carry on with your life. If you start deferring that, so you would go, okay, I'm updating text. Let's go through all the CPUs I need to send IPIs to. Oh, actually, this one is in user space. I don't need to interrupt it immediately. I'm just going to automatically set something somewhere, and I get in return the promise that as soon as possible, when that CPU enters kernel, the kernel, it's going to execute this callback. The devil is in the details. It's in what exactly is as soon as possible. So you can see here, for the lack of better naming, I've called that the danger zone between actually entering the kernel and going through context tracking and realizing, oh, actually, I have to run this deferred operation. Let's run it now. You haven't run the operation. So if you reason about static keys, which I think actually is my next slide, if in this region, I'm going to go back, you have a static key that was modified previously, you haven't run your synchronization operation, and you're screwed. Like, it's not really a nice place to be. Thankfully, at least for static keys, maybe I should talk about other stuff. because yes, it's instruction patching, so you can also have any sort of probes, so K-probes, BPF. Thankfully, we prevent that from happening in early entry code because it's all no instrumentation. So that gets rid of all of those probes. You can still have static keys, but with a little nifty thing called obj_tool, we can actually look at the objects that we generate, and we can see, oh, in those no instrumentation regions, which I'm kind of abusing. I'm using it as that means early entry, but that's good enough for me. Are there static keys that are being accessed? And then I can generate a warning at compile time to say, hey, you need to look at that because it's a bit risky. And actually, yes, there were quite a lot, but they weren't really a problem because they were static keys that are set at init, and then they stay the same forever at runtime. So we have a little annotation for that, which is read only after init. So slap that on these, and then the warning goes away. There are two static keys that are still problematic, and I can't really reason about changing them. One is Yay mitigations, MDS idle clear, which gets modified whenever we do SMT hot plug, because as I understand, that only needs, like the operation or the mitigation for MDS only needs to happen when you have SMT. So if you end up in a state where you've hot plugged all of your hyperthreads out, then we disable this, so we don't have the cost of the mitigation anymore. And the other one is for the TSC, which I really know not a lot about, but as I understand, pretty much any time at runtime, it can be marked as unstable. For instance, if you load the KVM module, and that ends up flipping the static key, and then you're screwed because that's in early entry code. You want to say something, Steve?
I think I was just going to say I agree with that last point.
Yeah, so the question here is, can we just leave them as they are? Because MDS idle clear, that means you have SMT hot plug. If you're doing hot plug, eventually you're going to get a stop machine.
No, I was saying, can we just annotate like that function or something like that to say that
that we are okay with getting the API anyway, because...
Yeah, but the question is, how can we... or can those two functions actually check that an API was done? So basically, and you know, can it be you said they're in no instrument?
Yeah.
Well, then if you modify it, wouldn't that fail the no instrument? Because you're not supposed to be able to modify a no instrument function.
So no, with obj_tool, I'm not modifying anything. I'm just catching the cases and warning about it at compile time. So there's no modification. It's just about getting warnings.
Oh. Because I'm wondering, like, because I thought there's going to be a time where you won't be able to do modification. I mean, that means...
Oh, you mean like the static key itself?
Yeah.
That's a good question. So...
Yeah, so that's something I think we should report. Have you reported to Peter?
About these, I think, at some point on IC, but I haven't made like a formal report.
Okay.
So... But I think the reasoning I was going for with the first one is you're going through hot plug, so you're screwing over your latency anyway, so you lose. And TSC I don't really know much about, but if you're doing something that marks it as unstable, is it reasonable to say, well, same, screw you?
No, this code doesn't work.
Wait. Yay! Problem solved.
Yeah, but usually that's the only time I've ever seen that triggered is always on boot. Okay. I've never really...
It's when I looked at the functions, there's mostly init functions, but there are some that aren't marked init function, like loading KVM module. So
yeah, so it's like I'm saying the mark TSC unstable. I mean, like I said, I've only seen that trigger like on a boot. Like it's usually detected early on.
Maybe sometimes if there are like tasks like always running starving, and maybe there is some check going on, and the check freaks out. But so there is something not working correctly on the system anyway.
Okay, but so I think the outcome for that would be modify these static keys to give them like a special annotation so that obj_tool says, okay, I know these are in this region, but we are okay with getting the cost anyway because it's not going to be the worst of the latency anyway. Okay, cool. The other one is a bit more tricky. So if we defer TLB flushes for the kernel range, now the problem is, okay, what if we access something? I put vmap here because I'm only doing this for vmalloc. What if we access something that should have been affected by a TLB flush in this early entry code? One of the things that was raised by Nicholas was if you have vmap stack, but as far as I can tell, that's not a problem because only yourself can really touch that, and that's going to be, well, when the task is initialized and then when it dies. There shouldn't be, as far as I'm aware, any messing about with this in the lifetime of a task. One thing I'd like to get ideas on is there any way to generate a warning or figure out if in no instrumentation regions we are accessing vmapped addresses? Because then that would be the equivalent of, oh, I'm catching that, I'm accessing a static key.
Well, I'm just, the two people that I know that could answer that question are not here.
It's like, that's what I'm thinking.
Peter
Like, is there
Zylstra
an actual validation that that's the case? That's my question.
What's it called? Mark Rutland would be another one, because he does a lot with the no instrument code. But
isn't this the case when you address the stack in no instruction? If you no instruction phase and you touch the stack, then it is foul mapped, right? Or do I misunderstand the question?
Oh, no. The map, the stack is like, it's not VM mapped.
You have an option to have it.
It is.
Yeah,
it's
actually the default on x86.
Oh, it's that's right, it made it.
But the problem is not if it's VMAP, the problem is if it would have been affected by a flush when you were entering this.
Right.
And
So
as far as I can tell, the stack cannot.
Right. So basically, okay, I see what you're saying. So basically, the problem is if it's VM mapped, that means that the question is, could this memory be pointed to something else now?
You can reuse it.
No, I'm saying is, could this map, because a VM map is, because it goes to the page tables, and you could put it here, and the flush would say, okay, now put it here, and that's where the error will happen. The question is, like, the stack doesn't change. Once you VM map it, you're not going to say, oh, let's give this thread
a different task,
a new,
maybe, but not the same that's currently.
yeah, the same task. That's what I'm saying. When it comes into the kernel, it's going to look at the stack. So I don't think the stack would be an issue. I don't think of anything else that would be touching.
So the thing is, like, I don't know. So would there be a way to find this out, figure this out, or?
So basically, to say if you're in no instrument code and if you do a VM map?
At least like even just experimentally, so that I can have an idea of, is there something else? Because I can look at code, but this.
The VM, or say the no instrument sections are marked, correct? So you could find it. So why don't we just put a trace point in that or hook something into the trace point for the faults, or is it any faults? Like, because you're only worried if it's a fault, right?
Well, you're not always. Are you guaranteed to always get a fault?
If you change it, wouldn't the only way? Well, will it automatically fault then if it comes back, or would it require a fault, or do you?
I have no idea. I'm not.
That's a question.
What?
That's like do a perf thing, is the CLP flush, or no? Well, we could do a cache miss. You could do. I'm trying to think. How do you know if something's that could be mapped? But the question is, if you're saying you're telling a map, but you're saying if it ever changed.
I mean, as a start, even if I just get something that's mapped, and then I can have a look at it, see how bad.
When everything you get to see a map, or is there a way to know when something got remapped? So if every time you look at something that got remapped or unmapped, either unmapped or whatever, check to see if that came from a no instrument or instrument function, and that might be able to tell you.
Yeah, I could do something with tracing on that.
Yeah.
But you unmap, you reuse the address, you have a different task. This one gets scheduled on a CPU that didn't have the TLV flash.
So basically,
you free a task, it gets unmapped, then it gets reused again for another task. This task gets scheduled on that CPU. And that goes.
Yeah, but I think it only works because then it's basically, but the same. It's the address. So it'd be if that's a task going away, a task coming in. It will have the. It's a question: is would the task have the, or would the address be the old, in the CLB?
That's the question. But theoretically, it's going to happen.
But okay, but freed and got back. I'm trying. Okay, so I guess the question.
If you like in this sscenario. At least, I know. Are you talking about the stack or any other?
On the stack, yes.
For the stack, no, because that task can't go through exit and free stack until it has re-entered the kernel.
Right. No, I think what they're saying.
The problem is only in the early entry.
Okay.
It's the danger zone.
Right. It has to be in user space.
The problem is only this. Once it's in the kernel and through context tracking, I don't care anymore.
Yeah. So, was there a question? Anyone else?
Okay, thank you. And another thing which I was not aware of, but was raised in the last thread by Nadav and Dave, which is apparently x86 can do this thing where it's free to cache the paging hierarchy at any time and kind of access it, or access whatever it has cached at any time. And so the worry was if we unmap something and we end up freeing an intermediate or like a page table page, and then we enter the kernel on one of those isolated CPUs, then you could have something where the CPU still accesses this intermediate page that was freed, and then it explodes. But VNmap actually doesn't free any of those intermediate pages, so we're okay for now. But I don't know if people have more concerns or comments on that, because yeah, that's something I was really not aware of, and people had to point it out to me. MM is fun. And yeah, if there's no comments or questions, that's my last slide.
Anyone have any comments or anything? I'm trying to think. So for, and this is just basically to say you don't have the deferred IPIs, because that's something that we do actually want. I know we definitely want.
Actually, maybe I can add on something. There was talk about for power management as well. At the top of my patches, I have an option to also do that for like if you have an idle CPU. It's kind of reasoning the same, but if it's running in user space, you don't have to send the API, so you can stay in the deep idle state. And,
yeah, that's right. That you want to have to, and yeah. So idle CPUs or power. Yeah, so you want to wake it up.
Similar reasoning. Yeah.
So how many APIs do you have that bother you? How many got you rid of, and how many are in unknown state?
You mean in terms of like different callbacks or like?
Yes, let's say you have this API and this is like easy peasy, I got rid of it, so this one deferred works.
In this implementation, so I have these two with the instruction patching and the TLB flush. And I can't remember in the initial implementation by Nicholas and Peter, I think they had 5. But I can't remember what they were.
Okay.
So the only time we care about that is for no hertz full.
Yes.
LT wouldn't mind.
No, I'm saying, but we the only time this would be useful is no hertz full, because that's the only time we stop the tick.
Well, if we do the idle thing, then it would be like regular no hertz, not no hertz full.
Well, no, but I'm saying if for both, the only time we care about the incoming into from user space to kernel is for no hertz full. That's the only time, because otherwise you're being interrupted by the tick anyway. So we don't care about IPIs because you constantly get a tick.
But I think so. This came from violating some very low threshold cyclic test, I think. So I think if you receive an IPI right after you're servicing your time, so it can, I think, still make a difference.
I mean, it's added
but then but then a tick could cause the same thing to you, can't you?
But the tick doesn't mind. The tick is something you can live with because you know when it's coming.
Okay,
tick. You have no idea when it's coming.
I mean, what we could do is bash IPI. Like whoever's going to send the IPIs, bash it. Say, well, we're going to wait for the tick to happen, so they all happen at the same time. I don't know. It's just, like,
this gets spiked.
But that's what I'm saying is most of the time, if you care about the IPI, you're going to probably probably going to care about the tick. I mean, yes, maybe certain things, workloads. The question is, are in a real world situation, is there a case where the tick is okay, but I don't want the IPI? That's the question. Is in the real world, is that a problem? If not, otherwise we're just getting to a scenario. Yeah, my cyclic test is a little bit longer with IPIs on.
I think it depends how many IPIs you get and how.
Yeah, and then of course, then you could, if you're controlled, then you kind of control the IPIs, because the IPIs only happen on usually user events mostly.
Right.
So I was just thinking with Frederick here. So with what's it called? No hertz full on. How early do we attach when we come into, how early is it when we turn on the tick, when we come into the kernel? Is that later on, or is it immediate? In other words, so with no hertz full, how early, when you come back in, so you're user space and you have the tick turned off. And then when you come into user space, you're going to have to turn on the tick again. Where does that happen?
Where does that happen? When the tick starts?
Yeah, no, when does the tick start?
Starts.
It only restarts if, it might never ever restart unless there is a grace. Well,
It depends, really it depends. It might never even restart if there is no need to. It can stay in the kernel without a tick. Yeah.
No, it's in there. I heard it click. So no, because does the RCU depend on the tick? So if you're coming to the, or when, like I said, don't you need to start the tick for?
Yeah, if there is a grace period.
Yeah, grace, because I was wondering.
And at some point, there might be a need to restart it.
Because is there, my real question is there code to detect you just came in to user space? Detect, yes. For you, maybe RCU. So I'm like, I'm trying to think about where the problem would be for that user. So you already looked at every place where you could start the, where you can enable IPIs, right? So you know where like all the like where you start, where you could say we're back from user space. That's the main thing.
Right, it's context tracking. So it's when we
right.
the RCU stuff.
Yeah.
Or
Right.
say RCU is watching again. It's the same place.
Yeah, that's what I'm worried about. My other thing was the no hertz side. We could do that now, basically. So we could use the no hertz code and just not send IPIs to no hertz, and still send IPIs to user space. Then there's no problem with that. Do you maybe have a config for that if you're worried about power savings?
At the top of the stack, yeah, I have a patch for that.
Okay. But is it? Oh, it's time.
Final question.
Final question. Yes.
It's actually just a very basic question for me, because IPIs have been a theme in almost a lot of talks. Are IPIs also problematic just for the latency RT case, or even in the normal case, they can cause more trouble than they should be? Of course, they are done for a reason, but I'm just saying, is it an RT thing, or it's also
I mean,
normal?
technically, if you're looking at CPU isolation and no hertz full, you don't even need RT, because you're not even entering the kernel if you're staying in user space.
Mm-hmm.
So it's really just like generally more latency, like interference problem.
Okay. Thanks.
Thank you. Well, thank you.
So you're next. Which one's yours? Oh, really? You're talking about proxy execution? I'm surprised.
All right. Hey, everybody. My name is John Stoltz, and I work on the Android systems team. I'm going to talk about proxy execution. So, of course, I got to say thank you to all the folks who have worked on this before. You know, it's the shoulders I get to stand on. I'm sorry I've been gaining weight. But one of the issues I've had is as I've given talks at OSPM and other things, because there's been so many talks about proxy execution at other conferences, I've kind of assumed that it was, I guess, better well known as I've kind of gone through those ideas. So after my talk, sometimes I get a lot of curious confusion or interesting looks. So I wanted to try to go through some of this in a little more detail, kind of moving through it to an overview of both the ideas and the code. I've got way more slides than I can get through, so I'm just going to kind of increase the complexity to the point where people want to ask questions and interrupt, and at that point it'll probably be over. So quick background. So in Android, we've got foreground and background tasks. We've got a whole bunch of other categories as well, but just to simplify. And you know, these tasks for the most part run as sched fair, or sched normal. And so that means that they're going, you know, as we have more background tasks, we kind of have proportionally less CPU time for the foreground task. And, you know, the foreground task is the more important one, so we want to find ways to prevent the background tasks from impacting that foreground task. So the, you know, kind of straightforward answer would be, well, let's use C groups. So we use both CPU sets to restrict the CPUs that the background task can run on. And then, you know, we could also try to use the CPU shares to further restrict the amount of time that those tasks could get on the CPUs. But this pretty quickly runs into trouble. If you look over here, we've got kind of a test that does some simple file system operations. And when we try to basically restrict some background tasks doing those same file system operations, the average for the foreground task gets better, but we start to see these really big outliers blow up. And this is just classic priority inversion. And this is an example on an Android device of just kind of launching the calculator. You can have, you know, just the baseline, just launching alone. If we add some CPU spinners, obviously the performance gets worse. If we bound those CPU spinners to the background C groups, we're back down to the normal case. But if any of those background C groups start calling into the kernel and grabbing a locks inside the kernel, it just blows up. So not ideal. This is kind of the canonical example of priority inversion in the real-time world. I think everybody's probably familiar with that. The kind of normal solution for this is to use priority inheritance. And so the idea is we want to have something like priority inheritance, but we want something that can apply to sched normal tasks where we don't have a strict linear priority order, because we have to deal with, the various C groups and the VRun times of each individual task. It's hard to figure out, what we should actually inherit there. So we're kind of going to use two tricks to make this work. And the first is we're going to leave the mutex block tasks on the run queue. So this is sort of like the opposite of the preempt RT package set, where we're making mutexes spin locks. And so they're just going to spin. But then what we're going to do is we're going to use the pick next task function in the kernel to pick the most important task to run. So we're kind of going to let it be the black box of deciding what's the most important task. If that task is a RT or is a mutex block task, we're then going to, instead of running it, because that would just spin and waste time, we're going to go through and traverse kind of, which task or which mutex it's blocked on, and then we're going to find the owner for that and run that instead. So we're kind of running this lock owner on behalf of the task that we think is most important to run. There's kind of this simplified example of the code and schedule, where again, it's just pick next task, we check to see if the task is blocked, and then we find a proxy task to run instead. Pardon?
Problem solved.
Yeah, very simple. So with this, so again, at the top here, we have the previous chart. With proxy execution, when we do that, it does exactly what we want, where we're kind of constraining the background tasks, the foreground tasks don't get interrupted. It looks really nice, just, attractive stuff. With the Android example, again, some of this is I'm using the worst case values, so some of the variance there is, I guess, just part of the test. But again, with the outlier here, when we get the mutex contention, we're able to stay down in the baseline space with the proxy execution. So it's something we're excited about. So in order to do this, we kind of have to have this idea of having kind of dual context, because not only do we have just the task that's running, but we also have the task that we are running kind of on behalf of. And so this selected task that we think of as the most important task to run, we're going to call the donor, and we keep track of it in the run queue in the donor pointer. So this is the task that if it's mutex blocks, it's not actually going to run. And sometimes we'll call it the scheduler context, or the waiter, or the donor task. And then basically when we go through and try to find the task that we are going to run on its behalf, that's going to be basically the current task. This will call often the execution context, or the lock owner, or the proxy task. And basically, this is what we're going to run on behalf of the donor if the donor is mutex locked. Now, these both can point to the same task. If you don't have a task that's not mutex blocked, it's just kind of, they're the same, and we just kind of carry forward. So with that, I've also kind of sprinkled links, so hopefully the slides are helpful to kind of go look at later and look at the actual code. So another aspect that kind of adds some complexity to this is that we're dealing with the fact that mutexes nest. And so you can end up with this aspect of tasks that are blocked on mutexes that are owned by tasks that are waiting on other mutexes. And so it can become these long chains. And one particularly difficult part is that we have this kind of alternating of types that we're kind of moving through as we go through this. And so this makes the locking extra complicated, because we have to have a strict locking order, which we have over here.
Well, I mean, you have a locking order, but actually, I was just telling people the very beginning, when I first to get rid of the global PI lock, it was because I wrote a proof from if the PI lock or the task lock, the PI lock and the locks lock, whatever, I don't know, but the RQ lock would be a problem maybe. But if the order of the locks themselves do not deadlock, then you can actually rotate through those lock owners in a specific way, and you're guaranteed not to deadlock as well. I don't know if you use that at all.
So in this case, I mean, so potentially, I know, just getting past locked up with that might be a little complicated.
Yeah,
but
that thing is locked up doesn't know about it, and
Yeah.
I know Thomas does tricks with the current code.
Yeah.
In the PI inheritance.
And so one of the things is that allows this to work is because we have to kind of let go of the locks as we move to the next step to preserve the locking order, is the fact that, these tasks are on, as long as they're on the same run queue, that kind of isolates them and keeps them from disappearing on us. Because we hold the run queue lock as we kind of iterate through this, we know that, okay, those tasks aren't going to disappear. And so since the tasks are blocked on the mutexes aren't going to disappear. This only gets us as far as one step off the run queue. So when we look at we can kind of look at one task that's not on our CPU to be able to assess things. But that's kind of the limit of it. So we can't kind of zigzag across CPUs as we are looking at these chains. So let's go through some simple proxying. We're going to just assume we're just working with one CPU. And so in this case, the first bit of change that we have is just basically the logic to keep the mutex block tasks on the run queue. We've kind of changed the logic that deactivates the task into this helper, and we pass in this simple task is blocked. So this isn't super interesting, but it's kind of straightforward there. Later on in schedule, this is what I call the pick again loop. So we basically will go through, we pick the next task. We'll then kind of, as I said before, we check to see if the task is blocked, and if it is, we'll call find proxy task. Now, if find proxy task can return a couple things. So if it returns null, that means something has changed and we need to start over again. So we will go through and call that balance callback, which basically undoes some state that was set in pick next task. And then we can go back to pick again and start over. If next ends up being pointing to the idle task, that basically means that we want to do something with the current running task. And obviously we can't do that while it's still running, so we need to quickly switch to idle, and then we'll come back in, and so we preserve the resched so that after that happens, we can come back in and do what we need. When we look into that find proxy task, this is basically the logic that does that chain walking that I was talking about earlier. So again, we start with kind of that donor task that was provided, and then we will kind of iterate through as long as the task is blocked, moving on to the next owner, basically each iteration. Basically we could find the mutex that we need, we grab the locks, we revalidate things, and then basically find the mutex owner. Then there's a bunch of complicated logic that I'll dive into as we get into it. But we kind of traverse this along until we come to the unblocked owner, and then we return that. Okay, so now we get to the next step as it's kind of getting a little more complicated, and we're going to start dealing with the fact when we have multiple CPUs. So one of the aspects that we have is if we pick a task and it's the owner, so that it's the mutex that it's blocked on is actually on a different CPU. We kind of, I guess there's two options here, because either we could move that owning task to our CPU and run it there, or we could move to the owner's CPU and try to boost it there. The problem is that that task that we're trying to boost may be CPU affined so that it can't run on our CPU. And since the block task isn't going to actually run, we can migrate it and use it for this selection process to boost it, to boost the lock owner. And so that's basically what we'll end up doing. And so in this case, we migrate it over to the other run queue, and then it basically is used for selection, and then it can boost and run the lock owner. Now we do have to be careful, because at some point, that owner is going to let go of the lock. And at that point, the task is no longer blocked, but we can't run it on the CPU. So we have to do what I'm called return migration before we get that task to a runnable state. So I'll cover that in a little bit later. But just for initially dealing with that first migration, when we're in that find proxy task loop again, so this is in that complicated chunk of code I mentioned earlier. So we'll find the task owner. If it's not on this CPU, we basically let go of the block lock and the mutex locked, and then basically call, this is the check if the current's in the chain. So if we're trying to migrate current, we can't do that until it's not running. And so we'll go to return idle instead for that cycle. And then we basically call proxy migrate task. In proxy migrate task, we have to do some cleanup initially for some of the state that we've set. Then we kind of iterate through. This part's a little interesting because we basically walk backwards through the chain, adding each task.
Real quick, just so I understand, just go back one of the current in the chain.
Yeah.
That's something. So is that because it's in the process of being blocked or something? That's why it's running?
Well, so yeah, so if the task is running and we're trying to kind of go through and say, okay, well, what are we going to run next? And if in that chain is the current task, like we can't migrate that. We can't do any operations on the current task while it's running.
Well, I'm saying because it's always, that's what I'm saying, because ideally it's blocked, because otherwise it wouldn't be in the chain if it wasn't blocked. But that's the point I'm saying. It's in the process of either going off, or is it in the process of coming?
It may not be, because we may have done something where we've been running an important task that just wasn't blocked, and then it's done. And so we pick the next task to run. And that task is a mutex block task that then needs a lower priority.
So I'm trying to figure out, so I'm confused with the current in the chain. That's what I'm saying.
Okay.
How does current in the chain happen? Like how is current, like the current is a running task.
Yeah, and so if the current task is suddenly blocked.
Wait, what? So. Here, ready?
So even if current is blocked, or should be blocked, it is on the CPU until you've context switched to whatever task is next.
Yeah, that was basically my question. It's either in the process of being blocked or coming out of being blocked. That's the only time current is in the chain. I mean, like you said, you're blocked. You're on the CPU because you're about to say, okay, I got to figure out things and go to sleep. So is that
probably?
So basically, it's a transitional phase.
Yeah, but you need to deal with it.
Yeah, but I'm saying is that was never clear. That's why I was asking. If you just said it's a transitional phase, I mean, just for articulate, yeah, it makes more sense.
All right. So what we do is we kind of walk backwards up the chain to basically dequeue each task in that migration, or deactivate, I'm sorry. And then basically we will set the task to the target CPU. As we do that, we do the zap callbacks again to kind of clear that state that we were set in pick next task. Then we basically let go of the run queue lock. This is scary. And so at that point, we grab the target's run queue, run through that list and queuing things, or activating them, and then switch back to grabbing that run queue. Now, because we've let go of the run queue lock, danger, things are not possibly what we expect. But we're going to return null from this and start over at the top of the pick again loop. So there's no kind of existing state that we have to worry about. So it's a little messy, but it's there. So now we get on to the return migration. This needs a little extra state because we need to have kind of a sense that if the task is runnable or if it's blocked on a mutex, and then we also need to kind of have a third state, which is this waking. Just so that we make sure that we don't accidentally run it as soon as the lock owner lets go. I kind of feel like this should be able to be integrated into the task state because there's some overlap in kind of conceptual ideas, but I haven't been super confident on how to quite do that right. So right now I'm keeping it separate. In try to wake up, when we get a wake up on one of these block tasks, the first thing that we check is kind of if the state matches what we expect it to be, and if it doesn't, usually we'll break out and just say, oh, it's already been woken up in some way, so we're done. But what we're going to do is add some extra checks to make sure if it is running and it's in the waking state, then at that point we need to not break at this point, and we're going to continue on. Down here, we're going to check if we're on the run queue, which of course we are if we're a mutex blocked task. And then we call into TTW runnable. And in that runnable case, we're basically going to we've added a little bit of logic to check if the proxy needs are sked. And if that is the case, we skipped the do wake up. In that proxy needs return, again, we're checking to make sure that the task is waking or in that waking state. And if it's the CPU that we're currently on is not the wake CPU, which was preserved when we did the initial migration. And if that's the case, then we basically deactivate the task and we return true. So at this point, it's off the run queue. And then we'll set it as runnable. And then we'll kind of fall back down through the rest of the try to wake up logic, where we call, just as normally tasks do, the select task run queue, and that will basically set it up to run on the proper run queue. And so that's kind of the point where we're returning it back on that wake up. So again, it's complicated and messy.
Yeah, but I was about to say real quick, what's the overhead?
I mean, so this is one of those things where I think there is some extra overhead, especially in the trying to grab the run queue locks multiple times through going through this. A lot of it also comes into the, we try to be good about when we do that, we do the whole chain at once. So we're not kind of iterating through each step. But it's there's some overhead. It's not zero, but it's
maybe a silly question. So do you do the migrate return even if the tasks that should return is fine with the current CPU in its affinity mask?
I'm sorry, say that again?
If the task to be migrated back is actually fine with staying with the current CPU, do you still migrate? Why don't you leave it?
I still do
where
the
it
return
is?
migration, and part of that is because with the scheduler decisions that happened before we hit that locked on state, tried to place that task on a CPU that it was most suitable to run.
Yeah,
and so if we migrate it off, and then it gets running on like a little CPU at that
But
point.
only that, meanwhile, anything can already be changed, like in the other CPUs. So like a scheduling decision happened, I don't know, milliseconds ago. Maybe now it's completely different situation. So maybe.
Yeah. So I mean, so basically, while it's in the proxy state on another CPU, and load balancer triggers.
Yeah.
What does it see? Does it see is the load balancing, because it's processed, like all the numbers are on its original CPU. Does the load balancing notice that it moved over, or is it just?
So it will see it, but the task is not migratable.
Right.
It's not on the migrate
No,
list.
I'm saying is the fact that can the load basically it looks like you confused the load balancer. So basically, like you said, it's not actually, we migrate it to allow the chain and everything to go up, or for it to run, maybe not. So I'm trying to think, how's the math on that? So for load balancing, if the other one's running under its kind of context, does the load balance, how does the load balancer work? Does it, if say things are building up on its original CPU and maybe it got picked to be, would the load balancer see it as one of the things queued on the original, or is it completely invisible, or is it completely off, or did it actually migrate?
So on the CPU that it started on,
it
has been migrated. So that one will see it as not present during this time.
Right.
It will seem to be present on the run queue that
Right,
it's
so
migrated to. However, it's not migratable, so it's not pushable.
Right.
at
So
that
I think that's the problem, is the fact that if the load balancer is doing its numbers or whatever, balancing this, it's going to see it on this one. So if you put it back, maybe the load balancer already fixed everything.
This is true.
You push it back, and now you screwed everything up.
Now, although the thing is that it doesn't just push it back. It says the select task run queue. It provides that wake CPU as a suggestion.
Okay.
And so basically that's where we'd like it to go, but this can choose a different CPU.
So it could
that
say,
is
you're
best
not,
fit.
okay.
And so, all right, so we got down to 1 minute. So if there's any other questions, I'm happy to do that rather than get into the next step.
Question I'm interested in what type of workload motivated all that work. So
On Android, we run into any case of trying to do that restriction of the background tasks so that they don't affect the foreground tasks. And we just see really bad latency. So it basically means that those like CPU controller for CPU C groups just isn't usable. And so right now, we still use CPU sets, but even with that, we don't restrict it very much. So it's like we'll give the background 4 of the little CPUs just to make sure there's enough space to run stuff so that we don't run into big problems.
I see, thanks.
Yeah, sched idle is another thing that would be nice to use for this, but it's just impossible.
Yep.
So anyway, that's it. Thanks so much. Check the slides for more details. I appreciate
So who's next? But also another use case is anything that does periodic calculations. Proxy execution works much better than priority inheritance. So you're next. Do you know what your slide is? Yeah. Which one's yours?
DL server.
Which one?
DL server. Yeah.
Did it have a name on it? Proxy.
FIFO starvation.
FIFO starvation.
Yeah.
Okay.
Good afternoon. So, going to talk about deadline servers for FIFO tasks, starvation avoidance. Just give a quick background on myself. I'm a kernel generalist developer with a specialization of finding and fixing bugs, which means that this is not my area of expertise. And I'm here to gather some feedback on some bugs that I found, and maybe they are not even bugs. So to give the background of the problem, so this is something that most of you should know about, that the Chad FIFO policy tasks, they run until they sleep or high priority thread becomes runnable. But there's a mechanism where non-FIFO tasks may run when the system is full. So if we have a lot of FIFO tasks running and they're past their runtime, the configured runtime, which is usually by default 95%, like 9,500 milliseconds over a period of 1 second. Those other 50 milliseconds are used to run non-FIFO tasks. In that scenario, if we have like multiple FIFO tasks with the same priority, just to simplify some of the rules here is that the task that is running, it's going to continue running until it sleeps. But what may happen here is that those tasks may end up starving those other tasks that are with the same priority. If it's a CPU-bound task, it's running in user space or even kernel space under a loop. And now those tasks that are not running, they're waiting to run, they may hold or be waiting for a mutaxes, right? So you have 2 FIFO tasks running. One of those sleeps because it's waiting for a mutax. The second task starts running, taking the same CPU, takes the CPU for itself and never yields. That second task is never going to be able to pick that mutax. And it might be the case that it may even starve other tasks, non-FIFO tasks that are still waiting for that same mutax, right? And that will lead to RCU stalls and task hangs warnings on the system. So basically, you have a task waiting for a mutax. The hanging task detector notices that, hey, this task has been waiting for this mutax for 140 seconds, and now you have some warnings and stall warnings about that. So similar presentation on LPC 2021 showed a similar problem where the kernel thread was starving for a similar reason. They showed that stall-d, which is a user space solution, may be used in such cases. So basically, the stall-d, it's a fair or normal schedule user space that notices those tasks that are hanging, and then it kind of bumps their priority until the stall is resolved. But they propose a stall monitor inside the kernel that would notice such cases and bump that priority or run those tasks. But I looked it up and I even sent an email, but I never found any of the mailing list patches to try to pick up that work. So deadline servers, they were introduced as an alternative mechanism for the throttling. So instead of having a timer detecting that the FIFO tasks have run for that 1 second period of time, and now it's time to throttle and give time for the non-FIFO tasks. Now you schedule the non-FIFO tasks in a deadline run queue with the same parameters, such that it kind of takes like 5% of the CPU time. But those patches have not been merged completely yet. But it's a solution that even improves in the current situation for the fair tasks. So a proposal here that I started working on, but I thought that gathering feedback before I continue that work is using that same mechanism for the FIFO tasks. So we would pick any tasks that are not being run for a while, put those into the deadline server, and run those tasks under those same parameters. One of the challenges that I found when trying to develop that is how to pick up the next task. Maybe one of the solutions would be to put every task into that deadline run queue and let it run. And but maybe the answer is this is working as intended, right? And so assigning a FIFO policy to a task is a privilege operation. So if any user has assigned the FIFO policy, it's intended that the higher priority FIFO task needs to finish, and if it never finishes, that's a bug on the system design, and not really a bug in the kernel, not something that we need to fix and care about. Or maybe we are happy that SolD can solve any misbehaving programs, or we just identify if there are any cases where a kernel thread may misbehave like that, and we fix the kernel thread and don't care about having FIFO tasks being scheduled under a deadline server. That's it.
So so SolD I think is going away as soon as we have DL server merged upstream, which maybe should happen soon. And so. Okay. And so among FIFO tasks, I guess, the natural extension of the DL server is to have the hierarchical scheduler. So you schedule FIFO tasks inside deadline reservations. So currently we have RT group scheduling, and I guess the natural extension is to use essentially the DL server idea to service FIFO task. That won't solve completely your problem, because if you put more than one FIFO task at the same priority inside the same group, they will be picked up, and one of the two has a chance for starving the others. I'm not sure that's solvable in the sense that either you put them in different groups and they can be co-scheduled, but at the point you are solving already your design problem, which was you have two tasks running at a fixed priority, which always run. So that was a design problem from the start, probably.
Well, I'm wondering if there's sometimes also, I was thinking use cases for real-time tasks to be in theirs, because there could be some critical real-time tasks that you want to make sure never get starved, but then let other things come in that could be run, or that if it overruns, it's not going to kill these critical ones that you run. So they're kind of almost always guaranteed to run, but you want it to run higher as a real-time task, not to basically it could. So the task could actually preempt almost everything else, and you want to give it, but you might allow some other things that can run that could possibly starve it. But maybe it's even by design to start it. So it's like I need this thing to have be instantaneously run, so not periodic. So basically, kind of like that mixture between having a the problem I always have with deadline server is because it's best for a periodic thing, but if you have something that's event-driven, but you only want it to, after it runs, and then you could throttle it after it ran so much, but it has to be able to run immediately. So that's the problem I have with deadline schedulers, is because it could always be delayed. That's,
No, that's true. But I guess if you have, so immediately, I guess, I mean, if you play with the period and deadline parameter, it's not immediate as of today, but it can be quick enough for the use case.
Yeah, we tried that and we just could not find a good. It was just basically we're doing what basically I know Thomas hates, which is trial and error to get what you want. Where no, we just want something that says this will run, but if it there's cases where it starts adding too much. Kind of basically think of it as like soft IRQs, where soft IRQs will run immediately, but if you find out like we've queued up too much, now throw it off to case-off IRQD. Yes, Chrome is, I'm not going to design, but I know I have to say this. What I found out was pretty much every single user space application is misdesigned, and we're the ones that are shipping them out, and now we can either fix all programmers out there. So not everyone is a kernel developer, so unfortunately. So. Any other question on that?
Yeah, so I wonder if since we are already given that 5% to the fair tasks, if we give it to the other FIFO tasks, they're starving, if that's okay.
Yeah, sir.
I guess going back to what I was saying, so if you have, I guess if you have the moment you have more than one task at the same priority, what do you do? Because, I mean, one of the two will starve. Maybe you can, I guess, have deadline server for maybe your most priority thing, but then maybe you have three at the same priority and the problem is back, right? So the fact that it works for SCAD is that they'll be able to essentially be using the 5% bandwidth that we give them because they are not like fixed priority. So they will be sharing that 5% automatically. That works for normal. For FIFO, I'm not sure.
So like I said, actually right now in Chromebooks right now, I think the deadline server by itself as is has been actually good enough for now. It's like, so we haven't had a case where we need to do real time. We're just worried that we might have, there's a few things that we run unprivileged, or not unprivileged, basically running JavaScript. And running JavaScript as a real-time process is scary. And that's the thing, but the thing is these things actually have to run immediately, but if what the feed, so basically when you're playing like a game online, there's certain things that we want immediately done, but we also don't want this thing to take over the machine or lock up or whatever. So we actually said, okay, when it comes in, when we schedule it, it gets immediately, but if it starts abusing it, then it gets throttled.
But in the case, if you have a group of, let's say, even more than one FIFO, that we want to run a FIFO, if you put that into a deadline group, that will be running instantly, if that's the only deadline group, right? And also you will have the throttling in case they go more than what allowed. So it will still work. I guess your problem is that if you have more than one deadline thing running, then it's true that.
This is like several RT tasks, where there are several, like I said, we're not so worried about them interrupting, because a lot of times one will wake up the next, wake up the next, wake up the next. So,
yes, but if you put them in the same group.
Yeah, but that's why I said we just let them be real time and then just let the deadline server make sure that the other tasks don't. So actually I said the deadline server actually works for us right now as is. There are some cases like that it might help, but we could get by without it. So the question is do we have a strict, I guess the question comes down to what is the use case of having the deadline server handle RT tasks, because I had one case that was like it was helpful, but we found workarounds that we didn't need it. So do we want to make the code complex for something that we could find other solutions for?
No, so there is a general use case. For example, if you run in application in containers, and some of those are running FIFO tasks, it might make sense to have group of tasks, and you can assign bandwidth to those group of tasks, and each container has its own RT bandwidth, and that is actually use case. It's different from this one. It is a use case, so that's probably what we're gonna do.
Or actually, if we could actually make the deadline server replace RT groups, Yeah, that's the idea. That basically, because that's the thing, is right now RT groups are just broken. In fact, everyone that enables it, and then they get a bug report saying, like internally, like we just said, turn it off. That's basically the solution for RT. Kind of like the same solution for SE Linux.
So, question?
Yeah, so in our case, we are using SCED-RR, but as Euro was mentioning, if it's SCED FIFO, putting it in a DL server would not help because...
No, not SCED, yeah. I said SCED-Other is DL server, yes.
Yeah, but in his use case that he was mentioning, putting the SCED FIFO in a single DL server group will not help because that will keep on running, right? So either you have to put individual task into a group, but we don't know which task to put, so I don't think DL server would work for this scenario. Probably Stoldy would be the better option.
I had one scenario where I said, oh, this would help, but then we found something else, and this is, yeah. So that's why it's like, it didn't really need it. Anyone else?
So I think like the deadline server between RT tasks would not make sense in a pure point of view, except for the RT group when you explicitly specify you want to give up. But like as a general, I think that will just break the whole concept of like that designing priority and stuff.
There's no compose. If you've got two different FIFO users, you can't smash them together and hope that the result is anywhere near the same. So you have to then isolate them between each other. And the only way to do that is with FIFO, with deadline service.
So wait, how do you repeat that so people online can know?
Very near miss. So the problem is that SCED FIFO fundamentally does not compose. You have two separate FIFO workloads and you smash them together, it'll be a train wreck. It will just not work. So the only way to do that is to isolate them from one another, and the only way to sanely do that is with deadline service. The thing that FIFO C groups currently does is horrific and broken. It sort of does this, but it's, yeah. Everyone wants to. There's just a small matter of affinities.
Anyone else?
Okay.
So what you're saying that you want different applications to have their own RT priorities defined independent of other applications, and you assign bandwidth to them with the deadline servers, just basically, so you give like 50% like kind of fair to each application, and the RT priorities hierarchy work locally only for that application, kind of. Okay.
Did you need a response or no? We have like 3 minutes, so anyone else? Otherwise, we could just go on to the next.
Okay.
Thank you. This is the big one. The last one. Good. We could get early so we could, so I could get ready. There you go.
Here we go. No.
Did you upload the wrong slides?
No, it's okay. We go to gitkernel.org. That's how it looks like. We look for the tip tree, right? And then this happens.
Do you have full screen?
Come on, okay? But then right, now. So we go one further to the SCED RT, and you get early this happens, right? Now then you wait a day, and you see a tag appears. And then you wait another day, and the whole print key disappears. Because this one got merged on Monday, right? So we have left like 3 patches, and
By the way, explain what that was. I mean, is that the RT patch set?
That's the remaining ones, right?
The remaining patch, I don't think you explained that.
Yeah, I get to it later on.
Oh.
But this is what we have so far for as a pull request. And this is what actually looks like, right? So this is like one select for x86. So I wouldn't say there's nothing that can go wrong, this merge window. But it's fairly limited. Now,
I didn't double check whether you got that select right.
but there's still RC2, right? So
Wait.
I didn't double check whether he got the select right, but we can fix that after RC1.
Right. Now, other than that, we don't have anything else in it, like maintainer-wise. Do we need an entry for it?
Entry for what?
Well, maintainer RT-wise.
Maintainer RT.
Maintainer, right.
Yes.
Yes, as...
So maybe I should bring a little background on this about maintainer RT.
Go ahead.
Okay, so so basically, one of the things is that we noticed, we've had the RT patch and everything else, and people send code or bug reports or whatever. Now it's mainline, kind of like the RT patch is disappearing. It doesn't really need to exist. But the question is, when someone finds a real-time issue, who do they go to? Now, one thing is the maintainers file, which I think is probably the best place for it, but it won't be for users. Users are not going to go look at the real-time. If they have a real-time issue, here's the workflow that I believe, and I want to ask, because I'm sure there's some distro people here. The question is this, if this will happen. Someone using RT finds a problem, goes to their distro and says, hey, I have this bug that's real-time related. And it gets assigned to one of their kernel devs. And the kernel devs looks at it and goes, I have no idea how RT works, because really I think all the people who understand RT are in this room. So everyone else in the other rooms they're clueless. So when they get a bug, they're going to say, what do I do with this? And they might want to say, well, wouldn't it be great if I could imagine that they would actually go look into the maintainers file, and should we have a thing in the maintainers file that says real time, and here's the people or mailing list, whatever. Is that something that you think would be used?
Yeah.
Yep.
There's another aspect to it also for kernel developers who do the driver or whatever, and they get the bug report, they don't know whom to talk to, so they will look into the maintainers file and say, hey, we are all these people who actually pretend to understand real time.
So yes, honestly, it's something that a kind of problem that we kind of always have, because of course we maintain a stock kernel and a real-time kernel. Honestly, especially in the last few years, most of the bug reports that said this is happening on the real-time kernel then ended up being issues in the stock kernel. So as of late, most of our, let's say, the tickets that we receive on the real-time kernel actually go to the stock kernel developers, because they are actually working. And so it might be that the thing is actually reproducible, maybe only on RT, because we know that it's more easy to reproduce. But yeah, so what I'm saying is that if you add the thing in the maintainers, you might receive lots of issues that are not actually specific to RT, just because it's easier to reproduce them. So,
So that's, I think I'm about to repeat what Peter said, because I was about to say the same thing. Basically, is when we get it, the people that are sending it, like, oh, it's a real-time problem, send it to you. We're the only ones that know, no, it's actually your bug.
Yes.
It's like lock depth. The thing like lock depth, I've seen people, this is something I'd like to audit lock depth before, or all the places in the kernel that quiet lock depth, because that's one of my fears. I see people look at lock depth and go, oh, false positive, boom. And then I go look at the report and it's like, no, it wasn't a false positive. It was a real subtle process, but they missed it from the lock depth report. So I feel the same things when it happen. They say, oh, there's an RT bug, and they'll send it to us, and then say, we have to turn around and say, no, it's your bug. So. But as I said, we still need someone to tell them that.
Okay.
So we need an entry. We do an entry. Who wants on the list to be listed in the entry?
Remember what Yuri just said. You're going to get a flood of everyone thinking, oh, this is RT, even though it's not. You'll get emailed.
Asking for volunteers, people get volunteered to be on the list.
Peter just said Thomas is on, but then Thomas is retiring, and he's just going to set his mailbox to dev null. So,
Anyone from the RT stable folks that want to be on that list?
yeah, Clark. Pick the one person that's not here. He should wait.
I told you it's volunteered based.
Yes, and I'm sure he's probably online. Did any face pop up? You could probably zoom it down again. I'm wondering if a face popped up.
Okay, so it's going to be Clark then. That's okay.
No, he's not. Yep, he didn't show up, so I guess it's Clark.
Clark, Sebastian, Steven.
Yeah. So of course Clark's older than you, so he might retire first. Who knows?
Yeah, we plan to retire together.
Adding to what I was saying, and I guess you can jump in because, I mean, those two guys are, for example, two examples of people working in a stock kernel, but we work kind of close to them, and I guess the realization is that probably you now acknowledge the fact that those kind of problems are maybe not RT specific. So what I'm saying is that I guess as a start makes sense because then it's kind of telling people and educating people in the long run. So it might be that you receive lots of bug reports right now, but maybe in a year or something, people start realizing, okay, it's not very RT specific, it's a problem to solve. So,
which I think basically another question to ask is, do we need an entry in the documentation directory for real time? That basically, I don't know, right now it would just be like one file, I would assume, just like what is RT or whatever thing is, but I'll get right there. Because that's another thing is a lot of people don't know. And if we had, do you think it's an RT bug? And you'll have yes, no, maybe we have to document these things.
Just quickly. Another thing that we do is to make sure that who's reporting tested the same thing without the real-time kernel. Because sometimes it's actually reproducible also without the real-time kernel, and it's time spent that you...
Now they're one and the same.
Yeah, and then that's what I'm saying. So it's easy to do now.
Yeah.
So anybody that's monitored any new kernel bugs that have come in knows that there's hundreds, thousands, and thousands. So if there's going to be a misconception of what...
CVE for each one.
Exactly. So if there's going to be a misconception, is this a real-time bug or a generic kernel bug? If you have one person in that mailing list, you might as well throw away that email address because they're going to get flooded. So maybe it's best to have a mailing list, not an individual or a group of maintainers, because I could just see flooding.
Like right now we have RT users or Linux RT users mailing list, which is not the proper place. And well, but hello. The one thing I think we mentioned too is having a Linux RT devel and having that just be a mailing list that will go to. So let's just put that as the mailing list and everyone send to that. So if there's any question, you have Linux RT devel, send it there, and then it will go to dev null, but no one will know.
So doing the list then.
What?
So we do the list as well.
Yes, we do the list. And Constantine's here because I think I'll just tell him to create one.
No, okay, so that's easy going. So we good here?
Yep.
What's left? The atomic console for the A250 is the only one that we have in RT. This is not merged. This is being worked on for the merge window coming next, right? That's correct. There's bottom half trouble with force-threaded, for instance, and networking, like for one example. This is being worked on, but this is going on. What's not in as of today is, for instance, ARM, PowerPC, and a few other things like pream out.
ARM 32, you mean, right?
Yeah, that's what I say ARM. Otherwise, I would say ARM 64.
ARC 64.
Or ARC, yes. Is anyone interested in ARM 32, PowerPC? I left out MIPS by accident a few releases back. No one noticed.
I'm sure there are ARM people still.
You think there's still ARM people that, well, actually we were told, but okay, this is something we brought up. The reason why is because we kind of were talking about this in the stable thing, because right now it's kind of like all the stable folks are kind of retiring. Went there because we were going, oh, here's another thing I want to let everyone know too. As soon as RT goes, it's like, what's called 612 is released, we're looking at all the dates for the current stable releases, and we're going to lock them for RT for ourselves. Because it seems that those end of life for an old kernel seems to keep creeping forward. And we're like, oh, God, like we're thinking like, oh, this December of this year, I'm done with this. And then you look at it and it went, oh, it's December of next year. Like, what the heck? So no, we're going to say this and we're going to basically make it that the stable releases for that. So basically, I guess we have 6.6, 6.0, 5.15, 5.0, I think, 5.10, 4.19, which is the end of life of this year of December. And there he is. So once the 6.12 is released, we're just locking those dates in. If they forward it and someone says, oh, I thought you're going to need help, we'll say, great, supply us with someone, and we'll train them. Daniel has a great set of tools. The what's it called? The ST thing, whatever. SRT, thank you. Stable real-time tools, something like that. But it's very much automated. Joseph here, we came in. How long did it take for you to really become, one of the?
A month.
A month?
2 weeks.
Yep.
Yeah.
So basically 3 weeks for a month of training. So if someone wants a support kernel that we're not going to support anymore, if you have people, we're happy to help train them. But we're not going to do it ourselves. Just FYI. And like I said, with ARM and these, if you say, wait, but 6.12, like we'll support everything as we do of the old ones, but for 6.12, we're not going to support a 6.12 ARM. We're not doing it.
And that's what I was going to ask. We're not going to do it. So we drop ARM right away.
And if someone asks us, I said, great, give us someone and we will train them to do it. It's not we're doing it. I believe that was the decision we kind of made, was it?
Steve?
Just perspective on ARM. So 80% of the patches I merge are for 64-bit, but there's still 32-bit. It's, at this point, mostly existing users, but there are existing users with RT kernels that are still updating their kernels, and that will continue for a number of years. So they are there. There are not that many, but we can't just ignore them, unlike MIPS.
And I probably have to say that if I understand correctly, there's only like 4 patches for the ARM port that's missing.
Yeah, which are ignored since 10 years or so.
Yeah, so they have not been touched for like 10 years. So like the forward porting of ARM boards is 4 patches that have not been, those have not gone upstream, but we don't plan on it.
But to be completely honest here, Russell did report, and I tried to get the 4 big ones first, and then I have a few others left, which I didn't present to Russell at all. So I had like first the big ones and the small ones, and if I don't get the big ones, I don't need to care about the small ones. So.
Okay. Is it similar is true for PowerPC? I mean, I saw your patches and I saw that some bits of PowerPC is missing. We like to get the support. As far as I know, there are no current use cases, or there's no one is rightly using RT in PowerPC, but we like to get the support, and I can volunteer to get the support on PowerPC.
Give me your email address. Just email me your email address.
Could someone repeat? I didn't get a word. I'm sorry.
Yeah. Email me your email address.
For what?
So it would be nice to have an RTDef config that would also disable things where RT is not welcome, like transparent huge pages.
Oh, wait, that's actually.
They are disabled automatically.
Well, yeah, we usually have transparent, like a lot of those things are, it depends on, not preempt RT.
Yes, you're right, yeah.
But, what might be good is have a def config, I don't know, maybe we could go through and find just various things that are not turned off that just, here's your def things.
Def config would be helpful. But coming back to PowerPC, after 6.12, it's easy. We don't care about it. The PowerPC people can take care of it themselves if they want to have it.
Oh, you said you volunteered.
Yeah, great. No, but it doesn't have to go through us anymore. It's an upstream problem now.
Wait 20 years to say that.
Who is the RT person on the maintainers file? You can email that person, right?
Yeah, sure. I mean, you can obviously people can CC those people on the in the maintenance file to help reviewing patches and whatever. That's obvious, but it doesn't have to go through something anymore.
Well, actually,
I mean, we can carry it in the out of tree patch for a while.
well, I think we start probably the outer street patch, but also I'm thinking the stable RT could still exist.
Yeah.
So we still have to continue stable RT until everything goes. But if someone wants to say, hey, I'll continue PowerPC for 612. We, like, 612, you could create that would be under like the stable kernel, like so it'd be kind of a stable thing.
The other thing why we probably have to keep the preempt RT series or the patch series around, stuff like I915, and if you it's also a good breeding ground for, we want to enable whatever transparent huge pages or something. You can stick it in there and let RT users test them out, because they are used to, hey, we apply another pile of patches on top, just to breed them out and figure out whether there's something which is going to break tomorrow. So for a while we probably will have the series around for various things.
Sorry, Sebastian.
Yeah.
Go on. So Sebastian patch queue will be RT next, or?
You may have RT next still, or no?
So no RT next at all, so not planned.
Well, the PH work that is going on, this is most likely be stuff upstream as soon as possible, or in big pipes, but I don't think I need to carry it around.
So I think what's going to happen. Okay, now I want to ask you. So this is what's going to basically happen, just like ftrace. Okay, I'll just use the ftrace thing or tracing. I have a tracing, Linux tracing Git repo that Masami and myself maintain. You could have now a preempt RT or preempt real time thing.
Yeah, but
but I'm saying is no. But that is where you're not containing patches. You're not doing that. That's where you could go to Linus and say this is ready. Pull request to Linus. I mean, as a development tree like tip. It's no longer this tree that's like out of tree patch. Now, like I said, when you're saying you're doing the development upstream, now you're going to be switching into an upstream workflow.
But
right?
I'm still going through networking, through scheduler forks and so on. I'm not
but still that's the hierarchy. I'm saying is that's still the upstream workflow. You're like, okay, you'll push it to tip, and then tip will pull it in there. So I don't know. I don't think you've ever you have worked with that, but I'm saying with the RT patch, it's always been the RT develops has been basically what we called upstream for RT. Your patch was, and we would backport from you, and you never actually pushed that stuff directly. I mean, except for don't you usually go to tip, push it to tip, and then tip
depends.
goes to
If it's scheduler, it goes through Peter.
Peter. Yeah, but I'm saying is you're no longer right now. You have a RT tree, like RT next, and you put in the -RT and all that stuff. That's going away. It's now just 612, and you're just your own tree. So you're just going to do your modifications, right? Your development, just like I do development for I have a bunch of things for tracing, and I do, and then when I'm done, I send it out. It's not like I don't have a Linux ftrace tree. It's just your own Git tree that you are just feeding into upstream. Does that make? Whoops. Hold on a second. Hand up first.
The person doing that should be the person with the name on the maintainer's file. Sorry to tell you that, but makes sense, right? Makes sense because that's the way to get into the main line. So
maybe.
The tree should be in Linux next. So everything in that tree should be the stuff that's destined for the next kernel.
Right. So basically, that's it. Yeah. So you'll have a for next or something or next branch that when you feel like it's ready, you put it in there, and then it goes to Steven, and he'll put it into the next Linux next tree and
continue what?
What? No, I mean, say if you find something that's your fix. Oh, so you're done working on upstream real time, totally?
Apparently.
So,
For example, the stuff that you're working on still on the networking, they're gonna be, I mean, once accepted from the mailing list, they're gonna be in some tree of some networking maintainer, right?
Right.
So you don't need like an additional thing for.
But I'm not going to send it for next before the net people agreed on it.
Yeah, I mean, from now on, if you look at the outstanding serial stuff or something like that, this goes all through the subsystem maintainers now. So we left the esoteric out of tree stage. Finally.
I'm going to actually end this conference a little bit early because I have to get ready for the next one. And what's it called? First of all, I have chocolates to give out. So I don't know. First, actually, I was going to give it to Jan Kirska, but I don't see him here, so maybe he just forfeited. I can see it. Well, okay. Who should I give these chocolates to? Anyone have any votes for it? I mean, I could have done a poll. So, anyone have any preference, like of any talk you liked that you wanted to give? I could do the poll up there. I thought about doing it. Okay, you got it. Yep.
That's because you tried to throw him under the bus.
Well, yeah. So, and then how about John Cage? Well, you said no, you don't want it because you said you had enough chocolate. So wait, where's who's else that gave a talk that's still here? What? Yeah. So you're front. So I guess you get it. So thank you, everyone. I get unauthorized for shared notes. I don't want to kill it. I want to get to shared notes. There was some notes written, so I need to save them. And I got to go. Shit. Can't join it. Oh, crap. And I can't save the notes. I can't save the Yeah. Could you, I'd like to.
And it's up in 21th floor.
Okay, 21th.
So, and don't try to follow Google. It wants you to walk completely around. No, from the main entrance of the conference, you turn right up to a building where you hit the wall, and then you turn right, and then the building is easy to distinguish. It's a tower. Up there is like a board, and it has a roof over it. Wolke 21. 21. Huh?
Chocolate?
Oh, are you kidding me?
caneca para todo mundo que apresentou.
And it's 40 ounces, so there should be alcohol and drinks and stuff too. Oh, did someone already come and take this? What? Okay, someone already took this. Stop up.
Da stehe ich schon mal an, keine Ahnung, wie die auszuschalten ist. Das ist wahrscheinlich nur übers Kabel. Schätze ich mal.
Ich glaube, die hat keinen eigenen Anschluss.
Ich schätze mal nicht.
No.
Heißt das HRS-Kabel? Oder heißt das HRS, diese Verbindung?
No, das ist ein ganz normal Cat 5. Anderes Cat. Genau, Cat 5. Ja, die läuft so.
Achso, ja.
stays on?
Yeah. And the camera actually